Hello. Okay, working. Good morning, ladies and gentlemen. I'm really happy to have you this morning at this, probably your first session, I guess. So 2 hours of really dense knowledge at 8:30 on Monday morning. That's good. So I'll just say some words about me first. So my name is Henri Tremblay. I live in Montreal. I usually speak French, so that's why I'll screw up one or two verbs during the presentation. I apologize in advance. I work for Terracotta on EHCache mainly and on other enterprise product, let's say. I've joined them a month ago or so. I'm also honored to be a Java champion. I'm really happy of that, and I'm among a lot of really nice folks in this community. So it's really a great honor for me. When I'm not working on EHCache, I'm also doing some other stuff on EasyMock and UpGenesis, which is the frameworks from which I've been known first. I'm the guy who pretty much invented, or I don't know how to put it, but all the class mocking that we're currently using and the proxying of class was made by work I did a long time ago, I'll say. That's it. And then I think I've pressed the button I should not have pressed on my clicker. So let's put that back. Here we go. I'm also a jug leader at the Montreal Jug. If some of you pass by there, come say hello. If you want to do a presentation there, please do so and just ping me. We'll manage something because I'm always happy to have friends in Montreal. I'm the founder also of the performance user group in Paris. I think it's the first performance group in the world. So if you're into performance tuning and happen to be in Paris once in a while, you can go there. I don't manage it anymore, and of course, since I'm not living there anymore, but it's always a good place to be. About you now. Who's currently coding in Java 8? Not bad, not bad. Java 7? Okay, Java 6? Still a bit. Java 5? No, stop. Okay, so a bit of it. Good. So the agenda of the presentation, the first thing is, since not everybody is coding in the same version of Java, I'll just do a recap of some important things in the previous versions. So I'll say boring stuff about old Java version, but I think it will be useful because I will use it afterwards when I'll live code my stuff. So just to put everyone on par, you'll get some information. Then I'll live code for a bunch of time. We'll take 8-minute breaks. Why 8 minutes? Because 5 is too short, 10 is too long, so 8 is good. And then normally you'll be back if everything goes according to plan. And I'll live code again. So as you can see, there's a lot of live coding going on there. Feel free to ask questions at any moment, because if you get lost in the middle, you will get lost forever, probably. So just ask whenever you want. There will be also a session question at the end if we have time. I don't know how much everything I'll say is dense, so I don't know how many time it will take me to finish. We'll see. If it happens to have a voting machine at the end, or if someone asks you if the session was good, please do vote for me and tell them that I was awesome. This will allow me to become a JavaOne rock star, which is my next goal in life. And let's get started now. So first and really old version is Java 5, 2004. It's the latest, biggest version before Java 8, and it was containing, of course, generics, but also concurrent collections, enum types, annotations, static imports, and so on and so on. And I won't talk about all of this. I will just tell you about one thing. Sorry. It's called the type witness. So let's have a look. Who knows what is a type witness? Ah, okay. I told you it was useful. So what is a type witness? Here we have an anyObject method that I've put it here. It's a method from, it's taken from EasyMock, but I've put it here for simplicity. So it's just returning a T that is assigned from the return type, so there's nothing telling what it is. And if I try to call this foo method here, as you can see, there's an overload, so you have a list, a foo list, and a foo set. So if I do that, of course, the compiler has no idea which one I want to call. So it gives me an error. In my case, I would like to call the list one. So what can I do in that case? The classical solution for that is to add, wrong keyboard, here. It's to add just a fake parameter that is totally useless, except to give the typing and put it here. Woo. Give me my type. No, sorry. Up, here. This works. However, I'm getting a warning because I'm putting a list and I'm returning a list of strings, so it's not exactly the same type. And so normally it should work if it was a normal type, but since in that case I want to return a generic type, I get a warning. In a beautiful world, I will do something like that, but I'm not allowed to do that because it's a generic type. There's erasure, and because of erasure, it's not possible at runtime to know what's the real type. If you have no idea what erasure is, I have a really nice other presentation about that, but wasn't selected for JavaOne. But just remember that this is impossible. So what can I do? So in my case, I just remove these parameters because they're pretty useless. So now I have another solution. I'll just cast it to whatever I want. This also worked, but I still get my warning because it's the same problem. There's no way to know at runtime that I'm really returning a list of strings, so the compiler doesn't like that. So the real and only solution that works nicely is called a type witness, which I heard the name of this thing. I knew about it like for 10 years, but I learned that there's a name for that, I think, last year. So it's the fact that you can set the type yourself. So you just do this. And if you compile, everything compiles nicely. If you run it, it runs nicely also. So what does it do? It just set the type. So you're telling, OK, I would like my T to be less of strings, so cope with that. And the compiler will check if it works. So if the compiler is able to put the return type at something that is a list of string, it will do so. If it doesn't work, it will give you a compilation error. So it's pretty much one of the first things to do when you have weird compilation error that you're not able to get rid of. You just put the type witness of the actual type and you see if it works. OK, so that's it for Java 5. It's one feature that's not that well known, and from the shown event, I guess I was right, and that you need to know. Java 6, so that's the last version for Sun. There's pretty much nothing in there. They did a lot of performance improvement, in fact, under the hood, but in terms of feature, there's nothing except there was the first scripting API, and so the first JavaScript implementation it's called Rhino. But that's it, so nothing else about that. Then Java 7, the first version from Oracle. This one was quite nice, actually. They've added a lot of syntactic sugar and also a new IO API. It was the third new IO API, I think. And the fork join, which helped a lot for parallel programming afterwards. Also invoke dynamic, that it's a bit under the hood, but it helped all the other, like the alternative languages on the JVM to be a bit more efficient. I'll tell you just 2 or 3 fun things on it. One is you can switch on strings. just comes handy when you need it. Another one that I love is the diamond operator. So it's the fact that you don't need to type the right side. If you type the left side, the compiler will infer the type by itself, and it will compile nicely. So it removes the terrible redundancy we had to type all the time. Some more fun stuff. You can have integer in bit now, in bits. You can also put underscore for your numbers. It's kind of cute, and make them more readable. By the way, there's nothing requiring you to put the underscore there every 3 numbers. You can put them all over the place if you want. Just nobody will be able to read you anymore, but it's allowed. Okay. But then, let's talk about the real nice things in this version. Let's open this here. Okay, I'll just remove that so you'll be able to see it in one bunch. So here I have a method that reads all the lines of a file, and it's returning them here. So this is before Java 7 coding style. I've decided that I don't want to return an IO exception because it's funnier like that. So I'm doing the normal stuff. I have a file, and then I'm putting a buffered reader. I'm putting the char set I will need from the file. And then I have a while loop that reads all the lines, put that in the list. And then I have tons of try-catch all over the place, and finally, to make sure everything is closed correctly. If close fails, I just ignore it because that's the way we do. And that's it. Okay, so if I Java 7ify it, what will happen? The first thing that will happen is I don't need that anymore because I now have a really nice constant that does UTF-8. So I can simplify that part first. Then I have there's some new files in Java 7. It's called path. So instead of doing this, I can use the path class, which will return me a path. And since I'm doing this, I can then use a really nice class called files, which will give me a buffered reader right away, in fact. Get a file, and I still need my char set far away there. Yeah, add catch close. Okay, let's do that here. And then I can do this. So as you can see, it's already a bit nicer. So I have something quite more dense than before. Then what else can I improve? There's something a bit more, a bit less obvious, I'll say. It's this part here. If you remember, so if I rethrow the exception instead of just ignoring it silently. So let's say I'm doing something like this, which is not really allowed because I'm not catching it above, but I don't care for now. What's happening here is the first, so when you get the stack trace, the first exception will disappear. So if you do it that way, the runtime exception that is thrown in the first catch, so in this one here, you won't see it in the stack trace. So that's not really fun. And if you do it that way, it's the close exception that will disappear forever. So what they did in Java 7 is they've added a concept of suppress exception. So in fact, you're able to do something like this. So I'll recode it the way it should be, in fact, to make it work. So if I have an exception, I try to close. If the close also brings an exception, then I add the suppress. I need to put one here. Add the suppress exception to the original exception, and this will give me a nice stack trace that will contain the suppress exception. So you have an example. No, I should not put that there. So I'll give you an example here. So here's pretty much the same thing, but I'm mocking the stream to be able to throw an exception on the read and to throw an exception on the close. And what happens is you have the first exception, the reading exception, and then you see the suppress part, which is the closing exception. So you get the information about both exceptions. So this is quite useful. And if I want to test it for real, normally I would uncomment that. This is expected exception. If you never use that, it's in JUnit. It's a rule that lets you assert an exception. So this is also something quite useful. From there, in fact, I don't really need to code the suppress exception thing, because in Java 8 we have something called try with resource, which is probably the best feature of the entire version. So instead of doing this, and I have problems with my fingers today. In fact, I could have done just this here. Ooh. And remove this. So this is a try with resource. It means that everything that are in the parentheses there in the try section will be closed at the end. This is because buffered reader implements an interface. It's called auto-closable. So as soon as you're auto-closable, it will magically close with the normal finally. It will add the suppress exception if there's an exception on the close. So it will work all by magic without you doing anything, pretty much. As you see, it will remove tons of boilerplate code. If needed, because that's quite frequent, let's say I want to write also to a buffered writer. I can put a semicolon there and just add a bunch of things I want to close one after the other. And it will work also. So here, it means that I can get rid of this. So I can go up, I can go there, I can put that here. I don't need all these things here, and I'm there. I can also go in my test to make sure the world is still turning as expected. It is. So how's that? That's better? Okay. And in fact, you don't even need that in Java 7, because you have this. So they finally decided that Commons IO wasn't any fun anymore. And in fact, if you want to read a file, you just do that. And you're done. And this is called file. Yep. And I still have my exception there. However, that I need to put back. Here we go. So we've turned, like, I don't know, it was 50 lines of code into like 5 lines of code using all the syntactic sugar. So please do this feature, because it will save you a tremendous amount of time. Okay, enough about that. These other slides that are there just because at some point it will be on SlideShare, and otherwise it's boring to read them if I don't put them there. And then Java 8. So 2014 contains Lambdas, contains the new date API, contains Nash-Horn, compatible future, JavaFX embedded, default methods, metaspace. We'll talk about a lot of these. I'll just say 2 or 3 words about some features we won't cover. So this one is just for fun. Previously in Java, if you want to do a base 64 encoding, you had 2 choices. One is to use Commons codec, I think, so a third-party library. The other was to use Sun Misc base 64 encoder, but that's forbidden, but everybody was doing that because it's easy to do. And in Java 8, they finally decided to give us a base 64, so we're able to code it properly instead of using hidden classes. So it's just a clin d'oeil, a wink to it. So now it does exist. It's not that useful. Something that is really, really useful is the new date API. It's based on Javadoc. As soon as you're in Java 8, you should not use Gregorian calendar, date, and other terrible things like that anymore. It will probably get deprecated in Java 9, in fact. So you have the new date API, which means that all your dates are immutable. Yay. And a date is a date, a time is a time, and it's not a mashup of both. Yay again. Also, it's supporting correctly all the other calendars. So if you want the Muslim calendar, the Buddhism calendar, the somewhere calendar, you can implement it quite easily. It's not Gregorian anymore. So here I won't go far with that. I won't talk long about that. But so here you have all the classes that implements it. And it's to give you an idea, this is the Fluent interface for it. So so this is I'll call it a synthetic example. But I'm taking the now time, and then I'm asking to get the first day of the month, then I'm zoning it in Europe, then I'm adding 5 days, and then I'm formatting it as in ISO. So if you want to do that with the old date API, it will take you probably 500 lines of code, and it will be buggy. Here it's 6 lines, and it works perfectly well. As you can see, I'm 7 minutes late with my time, but I was close to it, to the output. One other thing is Nashorn, so it's the new implementation replacing Rhino. If I have time, I'll give you an example at the end related to Lambdas. So I won't talk long about it. It's called Nashorn because a Rhino is a Rhino, and a Nashorn is also a Rhino, so they thought it was fun to name it like that. Enough. So let's talk about Lambdas. It's 11th Greek letter. That's the capital and the lowercase version of it. In our case, we're talking about lambda calculus. So lambda calculus is a formal system in mathematical logic for expressing computation based of function abstraction, blah, 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 blah. In fact, what all that means is above, it's a function. Under, it's a lambda. So a lambda is an anonymous function. So if you remove the name from a function, it becomes a lambda. So that's the only thing you need to know about it. Then, what is functional programming? Functional programming is this. It means I have a bunch of functions that I put in one another, and at the end, it provides the result I want. So it's not iterative programming, imperative programming anymore. It's not that much object-oriented either. So it just functions into function into function, and that's what was added in Java 8. It's not really related to lambdas. It's more related to new methods that are now existing in Java 8, because if you remember from the previous slide, a lambda is just an anonymous function. So if I put function and function and function, some of them are allowed to be anonymous, of course. So let's see all that in code. This is a code from Linus Torvald. It became so famous that he got a T-shirt. So let's get started. O3. Here we go. And I'll put this there. I have my cheat sheet in case I forget what I'm supposed to tell you. Woo! So here I have a print method that prints a name. And let's say I want to get some flexibility. I decide that I want to have a supplier of my name instead of just hard coding it like that. So I would do this. And here, and instead of this, I'll put a name supplier. Name supplier. So here I give an interface. It's called a functional interface. It's called a functional interface because there's only one single abstract method in it. We'll talk a bit more about that after that. And I pass a lambda to it here. So if we run that, of course, and if I don't forget to just call my thing here, of course it prints hello Henry. So that's your first lambda. So here are the parameters. In this case, I don't pass any parameters, so I have empty parentheses, and this is the content, and this is what is returned. So the return is implicit here. I don't need to put it. And that's pretty much it. Then someone asked me, yeah, I would like to decorate that a bit. So to decorate that a bit, I just add a decorator. It's called a function. Woo. So decorator like this. And I'll just call my decorator. So this one, so a function is something that takes something and returns something. In that case, it's getting a string in parameter, and it's returning a string. So it will look something like this. So I'll put Mr. plus name. So this is a more standard lambda, let's say. You have one parameter, and it's returning one thing. As you can see, when you have only one parameter, you allowed one argument, you're allowed to drop the parentheses. So if you have 0 or 2 and more, you need the parentheses, of course, otherwise it's unparsable. If you have only one, you can drop it. It still works if you do it, so that it's optional. So if you add them, it still works. You're also allowed to type it. So by default, the type will be inferred by the context. However, you can fix the type. It's a bit like the type witness. If you do that, you help the compiler in some cases. So if your compiler is completely lost, normally your first instinct should be to type your lambda. Your second instinct will be to put a type witness, and the third instinct will be to add an ugly typecast and to add a suppress warning annotation on top of it, because there's nothing you can do anymore normally. Okay, so that's the way it goes. As I said, the return is implicit, so in fact you're not allowed to put it here. However, what you can do, you're allowed to do what we call multi-line lambdas. So if you add braces in your content, in your lambda content, you're allowed to put multi-lines. In this case, you're forced to put the semicolon at the end here, and you're also forced to put the return here. So I'll just extract to give you a real two-liner. Here we go. As you might have noticed, here I'm using a function which is one of the functional interfaces that were added in the JDK. So you have function, you have consumer, you have a big bunch of them. You have things like B functions, which are taking 2 parameters and returning 1. There's also the equivalent board for primitives. And it also means that in this case, there's no reason to use a dedicated name supplier. I could have just used a normal supplier, which is also a built-in function. And the funny thing about that is that if you notice, I've changed the interface, I haven't changed the lambda at all, and it still works. Why? It's because the lambda doesn't care about the type it is in. So as soon as the parameter wanted by the function, so in this case the get function here, as soon as the parameter of the lambdas are matching these, which is no parameters, in that case, it will compile whatever the type being. So as soon as you've casted it into some given interface, you actually have a real type, but before that, there's no type mentioned. Here, I just wanted to talk to, so that's pretty much how it goes for lambdas. There's just a little, I just wanted to give you a little thing about this one. So you have a supplier that just returns something without taking anything. You have functions that are taking one thing and returning another thing. And the last kind of function is called a consumer. So a consumer just takes something and returns nothing, so it's void. So in that case, yeah, that's it. So I have one just down there. So normally I will just do something like this here. So as you can see, in that case, system.out.println returns void. It still works. And it's called a consumer. So your Lambda is not mandatory it's not mandatory that your Lambda is returning something. It can be a consumer. I forgot one fun thing. Okay. One last thing here. Let's do this. Here, and then I pull that up. Ooh, this one. Okay. If I do this, the Henry goes out of the Lambda and is used inside the Lambda. So I could do a bit of cleanup here just to make it more readable. This is called a closure. So it means that the Lambda has captured the value of the variable above it. What it does, to make that work, you have it means that this value here is what we call effectively final or implicitly final. If you remember, if it was an anonymous in our class, so let's say I do a supplier like this. In the old world before Java 8, normally you have to add a final here, otherwise it doesn't work. In Java 8, it's not required anymore, so this still works nicely. So the final is not mandatory, which is a great relief because it was quite annoying. And but it also means that it's actually final. So if you try to reassign it to anything here, the compiler will complain telling you that the variable is accessed from an inner class, so it needs to be effectively final, blah, 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 blah. So you don't need the final anymore, but it is still considered final. And it's the same with the Lambda. If I get back to the Lambda, it will be implicitly final here. So if I try to reassign it in the Lambda, it will complain the same way. Let me do it here, in fact. Complained. And the important thing about that is that it's really trapped in the Lambda, so the value will be in the Lambda. Even if it's in the code of the Lambda, it needs to be trapped. You can see that a bit like in JavaScript. In JavaScript, when you declare a function that is using a variable above, the variable gets captured by the function. That's the same kind of principle. It's in there. You'll see an example a bit after to make that clearer. No questions for now? Things going according to plan? Okay. So, now you should probably wonder how does it work under the hood. So here I have a little main method that just takes all the methods of the class and does a for each, which is one of the new methods you have in Java 8. So the for each will just go through the complete list. And I'm writing them to the console, so it's writing main down there. So as expected, there's only the main method here. And of course, if we look at the compilation, we have the under the hood method and class. And then we have the anonymous inner class with the $1 here. Then, if we turn that into Lambda here, and I replay this thing, hey, there's a second method that just magically appeared. So it's called a synthetic method. So it's a method that is added by the compiler at compile time. If I get back there, the anonymous inner class is not there anymore. So it means a lambda is not an anonymous inner class, even if we compare it to it frequently. It really is a little tiny method that is added in the class containing the lambda, and the code that will appear in it will be done at runtime. I'll give you a link at the end to have a complete information about that. So to put it quickly, you have this method there, which is empty at runtime because of the capture we saw just before. And when it's called at runtime, from the context, the JVM will see, okay, this is capture, so I need this value, and this will be the code. So it's replacing the fake methods by the actual methods, and the actual methods gets added at runtime. They did that for flexibility and performance reasons. So if they want to change it afterwards, they can put whatever they want into the lambda method to make it more efficient. When they did the anonymous inner class, it was in fact a bad decision at the time. Because as soon as you've compiled an anonymous inner class, you're stuck with it forever. So if you delay until you get into the runtime, your implementation result, you have other possibilities to optimize afterwards. So it's quite well crafted. However, there's two funny tricks about that. One is if you do a reflection framework, these will appear and it's not that expected. So that's why some Java 7 code might break in Java 8, because then there's unexpected method here that you want to just pass through. And the other thing is more a security thing, in fact. It's that you're allowed, let's see that, pass, get. It's an actual method, in fact, so you're allowed to call it. So, for instance, I've just copied the name here, and I put it there. And then it takes a method and parameter. So I get it there, and I need to assign it to something that must be better. Then I set it accessible because it's static. So it's synthetic, it's static, and it's of course private. And then I'm invoking. And so this is static, so I put null. But then I need a method argument, so I'll put myself. I'll put the method itself, and we'll do something like this to show it. Okay. There we go. So if I do that, null, why null? Where's my null coming from? Invoke, null, No, there's. Ah, you're right. Woo. Okay. I can remove that, in fact. I forgot that I was printing a line. Okay, I can just do this. My God. So as you can see, it works. I called it, and it's printing itself because I've passed it itself a parameter. So the funny part about that is if you do something like if user dot has access, then I will do my lambda thing here. It means that if someone wants to go through that and just call the lambda directly, it can. So if you have a really sensitive security framework, watch out, because anybody could call your lambda as it feels, because it's highly possible by reflection. It's rare that you have such a sensitive framework, but it could happen. So it's a good thing to know, let's say. Next. We talked a bit about that. So in fact, pretty much everything could be a lambda. So any interface with one abstract method could be a lambda, which means you could assign it a lambda, and it will work. One example is the old school runnable. Runnable has one method, which is run. So it's a functional interface like the others. So instead of doing new runnable and all the anonymous in your class you used to do, you can just do that, and you'll get a running thread that works nicely. I won't talk about all the boilerplate code around. It's just I'm trapping the system out result to be able to assert on it by doing this here. So if you wonder what is my assert output here. One thing that is important is Lambda is nothing until you cast it in something. That makes sense so far. Where am I? Oh. Where's my... Oh. Okay, there's a sheet missing somewhere, but I'll do it by heart. So by that I mean that here, I'm showing that to you a bit before. If I want to use my interface instead of using the consumer, there's no reason I can do it. I just need to put print here. So it's really assigned at the compile time. And just a second, please. Let's see what I did with that. No idea. How did I manage that? Here it is. Okay. And I'll put that there. And so what is a functional interface? If we go here in Runnable, we'll see a functional interface here, but that's not what makes it a functional interface. It's really the fact that there's only one method here that makes it a functional interface. The interface here is just good manners, I'll call it. So you normally put that to tell this meant to be a functional interface. Please don't add other method in there because you will break all my Lambda all over the place. So you just put that as kind of decoration. It's also looked at by the compiler. So if you do something like this, the compiler will tell you that you've broken the functional interface pattern, and you should not do that. But as you saw like 2 minutes before, it still works without this annotation. So the actual important thing is really to have one single abstract method here. Why do I say abstract all the time? That's because in Java 8 you can do two other things. One is, no, I won't call it print. You're now allowed to have static methods in your interfaces. It's frequently used as a builder or as a factory, in fact. And so you're allowed to add these. The other specific things that you're now allowed to put in an interface is called a default method. A default method is something like, let's do this here. It's an actual method with an implementation. This was added because otherwise nothing will have worked. In fact, you probably know that as soon as you add a method to an interface, you're forced to keep with it forever, because if you add another method to the interface, you will break the contract, and then all the implementation will need to be fixed to make that work. So you get runtime errors in that case. For Java 8, we needed to add all the functional interface and all the functional methods to all the collections, so we had to break that. So what they did is they had default methods. The rule about default methods is that you need to provide a default behavior to it. So in that case, you would do something like I would call print. You're not required to call another abstract method in the interface, but it's normally the way it goes. So for instance, when you've seen just before the for each, The for each is a default method that does call iterator and does the for loop inside. So there's a default implementation of it, and then normally when you do your actual implementation, you will override it to make something more efficient. But at least you have a normal, correctly working default method, which is why it's called default. And they kept the default also because it was preventing adding a new keyword, so they're kind of reusing keywords there. So if we do something like that, that's working perfectly, and my interface is still a functional interface. So, and of course I can call it here, and I put my I, and I rerun that. No, that's test everything, so I'll just, here we go. What did I do? Ah, yeah, okay, doesn't matter. Where's my output? Disappeared. Anyway, you can see the stars there. Okay, so that's all for functional interfaces. Now something funnier. Check. Here, what time is it? Do you need a break? Yeah, we can take a break, I think. So, as I said, we'll take a break so we can get some fresh air, and then we'll see how to make a Lambda serializable. Check, check. Okay. My counter was 8 hours instead of 8 minutes, but so you still have 43 seconds of break. So, yes. A lot of it is about the shortening and the efficiency. Then I haven't entered functional programming yet. I will, of course. It's the name of the session, and you'll see why it's useful. So, like in 10 minutes, probably. 5 seconds. 3, 2, 1, and we go back. So far I've said that a lambda doesn't have a type. It has a type because you assign it to something. So for instance, here I'm having an object output stream and I want to serialize my lambda. If I remove the runnable cast, it won't compile because writeObject is taking object and parameter. Object is not a functional interface. So I get an error telling the lambda must be converted to an interface. So I really need the runnable here. However, of course, if I run that, I will get a not serializable exception because the runnable isn't serializable. So what can I do? In fact, the solution is to do this. So this is a weird and probably unknown syntax. You're allowed to cast anything, in fact, but in this case it's a lambda, but you could cast anything into multiple interfaces now. You will normally use that with tags interface, so you could add clonable if you want. And then you could also add some my other interface. However, to be able to add my other interface, you would need to have a run method with the exact parameters as runnable, which is quite rare. So normally you never do that. It just doesn't really make sense. But being able to tag them as serializable it's quite useful. So if I rerun it here, you see it passed nicely. And it also means that my lambda has been serialized now. So what could be funny about that is if I do something like this, I'll just move my test above. So if I put my test variable above, I'm using it in my lambda, it will get captured in the lambda, and then if I serialize it, it will still work. So there's a magic trick to serialize a lambda with its capture values, and it will then get deserialized, and you will get the result back. And it's in fact, it started to be used in high efficiency frameworks because it seems to be faster than serializing an actual class. It's weird, but it's true because the content is tinier, which is quite fun. Of course, you could serialize anything you want. So for instance, I have a class underneath. However, whatever you're capturing, so what did I do? A. However, whatever you're capturing needs to be serializable, which can be weird, but it's logical. So in this case, if I try to do it with A, it doesn't work. But then if I just implement serializable here, it will start to work nicely. It should. I think I was too quick, in fact. What did I do? What's the A? What's the A? No, that's fine. And then IntelliJ is going mad. No, that's fine. Why does it like me? UA. And who's not serializable there? Hula. Funny. Okay. I don't know why it never happened to me before. There you go. Because, of course, since it wasn't static, it was getting the context of the outer class with itself. So the A class was also serializing the outer class, and the outer class was needing to be serializable also as well. But I have no idea why it worked so far. Okay. So, because A doesn't need to be runnable. The runnable is the lambda. Question was why the A doesn't need to be runnable. And so it just passed the system out in the lambda, but there's no, it's not related to runnable. It's really the lambda that is a runnable. There's two other things about that. The first one is if you serialize a lambda and you deserialize it somewhere else, you need the class that contains the lambda to be available in the class path on the other side. Since the lambda method is linked to an actual class, it really needs to be on the other side. Otherwise, you will get a class cast exception. No such class not found exception. But otherwise, it will work perfectly, and you get your value on the other side. Okay, that's all for that. Now, something a bit more useful, in fact, that we'll use more often. So here I have trains at passenger, and I have a collection of trains. I'm doing a for each, and I'm repairing all the trains one after the other. In fact, you should try to avoid using lambdas most of the time, because lambdas is not that clear to use. So the good replacement of it is called a method reference, which is this. So it does the exact same thing. So here I had a train and parameter, and the train gets repaired. Repair being a method of the train class. If I replace it by a method reference, it means the same thing. It means the train of the for each, I would like you to call the repair method on it. However, you get something shorter, nicer, and it has a name. Why is that useful? It's because if you start doing functional programming with lots of pipelining, as we'll see right after, and you just, I don't know, if my train is blue, then I want to repair it, and blah, blah, blah. So after a while, if you put a lot of things in your lambda, it gets quite hard to understand what was the idea behind that. So you better just extract it to something. No. Let's go like that. Hey, give me my... I want an extract method here. Here. It's repair if blue, for instance. So if you do it that way, you give a name to what you're currently doing, and it's also always a good idea to have a name to something. So it makes it a lot clearer to call it repair if blue. Nobody needs to read the content of repair if blue, because we know it means that we'll repair the train if it's blue. So please, yes?
So question, if you do train color repair, is it going to run the passenger train repair method and the freight train repair method depending on what T is?
So the question is, will it overload depending on the kind of train? Yes, it's normal Java, so yes. No, sorry, no. Okay, yes, and now I got it why you asked the question. So yes, if you add a freight train and some other train and whatever train, I need to put back the other example to make that more clear. Here. So let's say so train is the base class. You have other classes. So you have child classes. if you call train repair, it will overload with the correct overload of the real class that is actually in the list. Yes. Because you've asked, so it won't call the implementation of train. It will call whatever, what is it called? Whatever overload there is, but it's not overload the name I'm looking for, whatever. So yes, it works as expected. Okay, even if it's train that it's said here and not the subclass. There's a 4 flavor of method references. So this one is the repair one is I'm calling a method on the instance of the train. The other that you have is I have a static method that takes a train and parameter. So that's another flavor of it. Then you saw it with the this repair if blue, but I'll do it with the passenger now. So it's in board, it's called. Oh, my passenger is called passenger. Yeah. So here I'm asking to pass train to the method of another instance. So that's the third one. The last one is a bit weirder. It's a constructor method reference. So you can do create train. You can do this, in fact. So you allow. So this will call the default constructor on the train. Where is it? So the create is here. So it becomes a supplier. So the default constructor is a supplier. It supplies a train. It creates a train. And so you can call it here, and you will get a brand new train. The funny thing about this one is, in this case, it's calling the default constructor. But if you have a constructor with one parameter, for instance, it becomes a function. So you're also allowed to do that. I don't know if I can quickly give the example, in fact. So let's say I change a constructor. So I have big problems with my finger today. So if I do something like that, it will stop compiling here because there's no supplier existing anymore. However, if I change that to function, taking a string and parameter, returning a train, it will work again. So the new can be, depending on the constructor, it could be a function, a supplier, it could be a function, it could be a B function. And it could also be primitive if you have primitives parameter in it. And I'll just apply, just fix that to make sure all my other examples will compile correctly. Okay, so please use that extensively. So as soon as you can have a method reference, just use it. It will make your code way, 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 way clearer. Okay, let's go into functional programming. I still have 20 minutes. That's good. I'll try to go quickly. So the entry point for functional programming is the stream in Java. A stream is a pipeline of things that will happen in some random order because it's the decision of the stream to optimize that as it sees fits. So you will see the stream as something that will process an element one after the other through a pipeline of events, let's say. So for instance, here, I'm doing my read all lines of my POM XML. But in fact, in files, no, I'll put it the other way around. The problem with that is that I'm reading the entire files. I'm putting that in the list. Everything is in memory, and then I'm doing a for each on it to be able to print it. It's not really a good idea. So in fact, the Java guys were wise, and they gave you a lines method here that is returning a stream of string. And the big difference it will do is that it won't read the file right away. Instead, it will read it one by line. When it's done with one of the line, it will just throw it away and read the other line. So it won't be kept in memory. It will be processed linearly one after the other. So streams are quite useful, and I'm saying it's your entry point to functional programming because all the cool functional methods are on the streams. In fact, on the list, the actual list, you will get for each, but that's it. A stream could be infinite. So if I do this, for instance, you have ints here, so it will generate a random ints infinitely. So you will normally do something like, I want the 10 first, for instance, and then I'll print them, and then I'll use a method reference that you will use quite frequently, which is called println, like this. And as you can see, it prints my thing, and if I go down, I get my 10 ints, my 10 random ints. So stream can be infinite. Your goal will be to keep a string as long as possible. We'll talk about collectors after, right after. But let's say you have a DAO, for instance. You better return a string than a list from that, because the stream will stay without loading anything for a while, and then when it's really needed, it will get the values. But otherwise, there's no it's lazy loading the value inside the stream, let's say. So it's way more efficient. The weird thing about that is that it means that if you code in Java 8, you will change pretty much all your interfaces to return stream instead of returning collections, because it's the way it is, but it changed a lot, in fact. It changed a lot in the mindset. The other thing is, at debugging, it's a bit weirder, because when the method returns the string, for instance, if it was a database call, it means that the call to the database wasn't done yet. It will be done when you will use the termination method on the stream. So it's really going lazily through your stack, and at some point it will be used for real. And that's the moment when it's interpreted, I guess. For example, here I have my get people thing, but here I could just return a stream from this and stream there. No, I could do that, but that's stupid. So I'll just use a stream. By the way, there's something weird about arrays. Is you have two ways to do it. So you could do that also. So there's a stream of values, and you have an arrays of stream. Both are doing pretty much the exact same thing. So you will see both in the code, and it's a bit strange. So here it's returning my string. And then this is old school stuff with a for each. So I have my list above, and I do a for each, and I'm filtering to everything containing an I, and then I'm adding the result. This is working, but that's not the spirit of what we're supposed to do. What we would do here is more, so that's the actual functional programming part of it. We would do this, something like that. Name, so name that contains an I here. Oops. So I will filter to have only things with an I. Then, and then I will extract them. So that's where I need a collector. We'll extract them, and all this goes in there like this. Here we go. So that's functional programming. As you see, it's way more readable than the terrible Lambda, and also you don't need the boilerplate of initializing an array list and putting things in an array list and blah, 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 blah. The filter will filter the values. The collect will collect the values, and it will do that in the order it feels it's the right one. If you want to debug that a bit, there's a peek method. If you run a debugger on that, it's a bit awful. So you have to get back a bit to system out stuff. You might found it sad, I agree. No, I'll do like this. Out to the println, and I've screwed up my system here. So the pick method will be really helpful to be able to know the order of things that are happening. So as you can see, the filter was above. So everything that was behind the filter is something that contains an I. So I only have these three. And you can see that it was processed in this order. So the peak does nothing except returning you the value, and it's really useful to use for debugging. Shook. Now, real functional stuff. So I'll show you a bit how it goes. So now that we know how to do a stream, we can try to implement this kind of method. Here I want the strands of all lengths of first names containing I. So my first thing is I want to check if I have a I. Here we go. The way I'm indenting it is the normal way. Some people will indent the stream also. I think it's useless, but it's just a style thing. But then try to put all your different steps of your pipeline one under the other to make it readable. Otherwise, people will get totally lost. So I have all my first names starting with I. Then I want the length of them. So I will map that to an int by doing by using a method reference here. So I'm getting my length. Now that I have my length, I want the sum of it. So map to int will return a int, and so you have an int stream, it's called, because so you have streams for all primitives and streams for objects. So then and on the primitives one, you have a bunch of methods allowing you to aggregate. In fact, so I will use the sum one here. So I'm getting my sum, and as you'll see, it's working nicely. So that's to get a map. Here I want something different. I just want the list of length. So again, I will just move it to an int. No, I should not do that. I want a list of integer with a big I. So I will do a map. Map is something you will use all the time with filter. Map is I want something and I want to have it transform in something else. So here I'm taking my name. It will get the length, and since length is it's returning an int, which is a primitive, it will be boxed in an integer, and it will return at the end a list of integer. And then I will use my termination, which is collect. So as soon as the collect is called, the entire pipeline will be resolved to be able to fill the final list, and the list will be received. So if I was to, I'm probably some will think I'm repeating myself, but I think it's important. If I do something like this, again, if I call get names, the streams won't be read at all. It will be read when the collect will be called on it, because it needs to be read to be able to fill the list of integer that is the actual result. Really, 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 really important. And here, so my collector is existing. You will see there's a session, I think, tomorrow about streams by Maurice Naftalin. He will talk extensively about this kind of thing, I think, because there's tons of flavor of collectors. You can do a tremendous amount of things. You can pipe them one into another to combine them. So it's actually quite complicated. So you can dig in the API and also have a look at Maurice's session probably. I suppose José Pomar, I think, is doing something on that too. So you could have some other Lambda fun tomorrow. So that's just a sneak peek. There's no guaranteed order in there. So so if I don't know, if I do this, there's no guarantee that it will come in the exact order of the list above. If you want to make sure of that, you need to do this, in fact. So you need to ask for something ordered. Otherwise, it won't be by default. It normally will be because list is flagged as an ordered stream, so it should be in that case. But there's no real guarantee on it. Up. What time is it? Ooh, getting to the end. I don't think we'll do the JShell part, so if you're interested, we'll see after. I'll just talk about parallel a bit. One of the other cool things about streams is that they can be parallelized really easily. This is an example. Let's say I have a user DAO, and I want to read all the users in my list above. Normally, I would do something like this. DAO find point collect map collect. Here we go. As you see, when it's not indented, it's not that readable. So here, I'm just reading all my users one after the other. However, it could be useful to just do that in parallel, because I'll do all the database calls in parallel, and it should work. In real life, it doesn't work that well, because if you use, for instance, Hibernate, you have a Hibernate session. The Hibernate session doesn't exist in other threads than the threads you're in right now. So it's a bit more complicated in real life, but in my fake demo life, it works really well, and I just have to do a parallel stream here to make that goes in parallel. If we have a look here, I'm going to set a user, so we'll just do this, and then system.out.println of thread point get name. Here we go. And I'm here. Let's run that. And so now that I'm in parallel, you see that all these things are executed in some other threads, which are called the common pool. The common pool is, in fact, where all the parallel stream will be executed. It's shared among the entire JVM. So you need to watch out about that, because it's shared. So if you stuck it, it's stuck. If you blow it, it's blown. If you overload it, then you overload your CPUs. It's for everyone on the same JVM. So you need to watch out. It's auto-sizable, so it will normally size slower than expected. So in when you do something in parallel, it will probably be faster than if you were to do it sequentially. However, if you want to tune parallel processing, you will probably want to use your own forejoin pool, because it will be way faster, because you will size it to the correct size at start, and it will get a better result. So it's nice, but it's not the fastest way to do parallel programming. If you want to play with it, you have it here. In fact, you have access to it. So if you want to just submit a task by yourself, you can. If you want to know how many threads there's in it, you can ask. And it's there and available. And then, I think there's a link here that it's a good explanation of all the parallel things. Another way to do parallel programming is to use a completable feature, it's called. I think I'll skip it because I won't have the time. I'll just show you the solution. So a completable feature, again, it's a bit like promise in JavaScript. So, and it's fairly complicated. There's tons of methods. I think it's about 50 methods to work with them, and it's strangely not documented. But the way it works is you create a completable feature. In this case, I'm supplying it async, so it will be submitted to the forejoin pool. So this part will be done asynchronously, and I can get the value for my feature when I call get on the feature. Otherwise, it's done asynchronously. So in this case, for instance, I want to get my user. On the other thread, I will get my event. And then I will just combine the two threads using a by function that will add the user to the events. There's a then combine async here if needed, but in my case, I just do it inline in the current thread. It will be done there, and then at the conclusion, I'm just getting my users that I wanted to get back to make sure that it was done correctly, and I'm just checking it in my assertion. So it's extremely powerful, and it allows you to do some reactive programming in Java without using any reactive framework, in fact. So it's something that's worth to look at, but I won't do I won't go in depth because there's some last really important thing I want to talk about. It's called optional. So the normal imperative way to look if Henry is in the list is to do an index of. If I'm there, then just get the element and blah, 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 blah. In the functional style, you're not doing that, of course. You will do something like this. So you will filter. In this case, I will do something like that. So if it's named Henri, then I want to find the first one. And so here, it should be a string. Call it just S here. And normally, I would print it like that. However, this is not working because find first is not returning the string. It's returning an optional of string. Because it's possible that find first won't find anything. So instead of returning null, which will break the functional pipeline, it's returning an optional where you can ask the optional if there's something in it or not. So normally, when you're there, you would to get the value, you would do that. This is bad, almost forbidden, and it's probably the first method that will get deprecated in Java 9, even if it was added in Java 8. As strange as it seems. This is because this one is throwing an exception, in fact. So if the value is null, it will just throw you an exception. So when you call get, you need to really make sure you know what you're doing. So you won't do that. So the ugly way would be to do this. So first check if there's something in there. Ooh. And if there's something, to getting it. But that's not the functional way, let's say. For real, what you will do is to do something like that. So let's say I want to print it only if it's present. You will call if present here. And then you will do this. Shook. And now it's returning void, so I don't need this anymore. Okay, and this is all. So you will do it that way. Let's say you also want to return, here we have the example here. Let's say you also want to return something if it's null. What the? Life is complicated. You can create optionals. So I will just create an optional of notable here. And you have this thing, for instance. Yeah, let's use. No, I'll map first. So there's a map on optional. So you can do, I'm getting lost, get name. So you can map it. So if it's null, it will do nothing. It will go just through the map without doing anything, but it won't fail with a null pointer exception. If it's not null, it will correctly map it. And then I can call or else. Is it? And so or else will return the name if the user was annulled. Otherwise, it would return whatever I want, for instance. So if I do that, and I do a string name, like this, without a name, So if I do that, I'm getting Henry because right now my user isn't null. And if I rerun it again with the user null this time, it's returned 404. No crash, everything is nice. It just goes through the pipeline. And I'll go great. So it's really the concept of nullable object. So the object will behave normally even if its content is null. You will see that everywhere. So the main thing to remember, don't call get because it will fail. Don't use if present or thing like that because you're breaking the functional stream for no reason. Just do it that way, in fact. Okay, I think I'll stop there because there's no time. I'll take a bunch of questions. Ah, and I have slides normally. Yeah, I have slides. The last example, applying JShell to functional programming, but I don't think you will ever use that just for fun. So, long journey, I'm done with it. There's a question I like to ask to know if I should retire this session or not. I have one that I've been running for 6 years. People are still raising their hands, so I'm forced to play it again and again. So this one, who has learned something today? Okay, can redo it again. Great, no, that was the goal. Some really useful links. So if you want to know what's under the hood a bit more seriously, Brian Gertz has a really, really, really nice blog post about it. So have a look. If you want to play a bit with it, there's Ninja Squad. It's a French firm, so the site will be in French, but then it's unit test and English things, so you should be able to figure it out. It's a nice kata. You go all the unit tests one after the other, and when you're done, you're normally able to do functional programming correctly in Java. So have a look. The last link is, so Maurice Naftalin have two great things. Has two great things. One is a site called Lambda Fact, where you have all the information about lambdas that you might want to know. The other is a great book that I've read after doing this, in fact, and it's explaining pretty much everything I said here with more details, with a better English. So it's a good book to have in your bookshelf, I'll say. Don't forget to vote for me. Because you do want to make Java great again. And if you have any questions, I'll be in the hall or by there because I think they will throw me out like 1 minute ago. Good. Half an hour? Ah, it's 8:30. Oh my God! Half an hour. Oh. Are you tired or you want some other stuff? I forgot it starts at 8:30. My God. Ah, wow. Plenty of time. Why haven't you told me that like 15 minutes ago? Before I start skipping things. Where was I? Okay. Oh, but I have too much time now. I went too fast. I'll show you the JShell thing then. Because completable feature, I think you saw the idea, so that's fine. We'll have time to questions. So I'll show JShell and we'll go with questions. So we should be all right. So at some point, I just wonder, because since JavaScript is mainly based on functions, I wonder how easy it is to call a function in JavaScript and like cast it into a Lambda. The answer is not easy, or not that obvious. No, here, check. Script. So here I have just a normal JavaScript. I'm doing a sum. I've did it this way because in JavaScript you could do this to give it a name, but this is the Lambda way. So you see an anonymous function that is assigned to a variable. So it's just a sum that I have here, and so this is. So the way it goes is you read the file, and then you ask for an invocable, so you cast your engine in an invocable because you know that you have something you can invoke in there. And now we would like it to become a double binary operator, because double binary operator takes one int, another int, put them together, return the sum. How do you do that? Answer is not easily, but it's still doable. So I want to return a double at the end of it. And you do something like this. So you will invoke the sum function that was in the file. You will pass your parameter like this. And so you need to do that. So you need to go, it's not that hard, but you need to go through an invocable, and then you need to declare your lambda. So there's no way to say, I don't know, invocable, or let's call it invocable dot get lambda of something. You need to type your own lambda, and you wrap the invoke function in it. It's okay. I would prefer something nicer, but I'll say it's okay. The bad part is that you have terrible, ugly exception there. Here you can use a neat trick that I haven't talked about, which is this. This is also a Java 7 thing. So as you can see, you're now allowed to pipe different exceptions in one short cast. And you can call in the catch part, you can call any methods that are common to all the exceptions that are piped one after the other. So as you see here, it prevents to having tons of catches one under the other that does the exact same thing with a terrible cut and paste that everybody hates. So another neat trick from Java 7. And so if you do that, it will actually work. Like this. Okay, my assert. So, and here's the call. So I apply as double, and I'm passing the values, and I'm getting a file. Also, this thing here, this is called assertj. It's an assertion library that I'm using a lot. It's kind of a harm crest with a fluent interface spin, I'll say. So if you were to use armcrest, you would do something like is equal, something like that here, like this, this here. But then you need to have the import, and it's nasty, it's kind of annoying, and it's long, and I don't like that. So, so instead I'm using assertj, which allow you to assert that, and depending on the parameter pass, so if it's a list, it will give you like contain stuff. We've seen that in the, I think it's in this one, like here. So here it's returning a list. I can do a content sequence with parameters of what I'm expecting it to contain. For this one, I'm just doing an equal. So I think the guys really did a really good work to have fluent assertion that are nice to use. So I'm using that everywhere in all my projects. Now, so that's how to call a function from a JavaScript function from Java. Then you might want to do it the other way around, in fact. Here, and I'll remove my meeting here. We'll do that with their JJS. JJS is a Nashorn console, I'll say. It's like JShell, but for JavaScript. And from there, you can do all the Java in the world you would like to do. So let's say you want to do an array list. You will do something like this. What did I do? Oh, semicolon. For some reason, that's not working. And hello, Oracle, please fix that. So I'll just retype it. It's good for, I feel like I'm coding in COBOL in 1990 something. What did I do again? Syntax error. var. Whew. Should have not looked at the keynote yesterday, remembering the val thing. So I can create an array list, a normal Java array list. I can add an element to it, and then if I want to have a stream, I can. And so far, so good. But that's the funny part. Here, I really can use a function, so I can put a function in there. And so I'll just call print on it this time. Check, 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 and it prints. So in fact, the other way around, so using Java and using function as lambdas inside the Lambda API in JavaScript works quite nicely. The other way around is a bit cumbersome, but in this order, it's quite cool. Okay, so now I'm done for real. We'll go back to here. You have all my information, and if you want to contact me, Montreal Jug, EHCache, EasyMock, Genesis. And button I should not press ever, but I do press here. Ooh, and I'm at, damn it. Okay, I think I'll get back. I'll put the slides on SlideShare. I'll add some other slides that for like summary of what I've just told you with live coding, so the slide will be useful. Let's get there. So let's get back to here. Vote for me. That's the only thing you need to remember. And I'll take some questions because we have plenty of time, in fact. 20 minutes, I think. Any questions? Yes? JavaStack? I don't know what JavaStack is. I know JStack, the command line tool, but I don't think we're talking about that. Or? Here. So, no. Other questions? Yes. If you have like the bin directory in your class path, the Java bin directory in your class path, you get JJS. It's there. It's one of the tools. It's built in the JDK. It's probably since Java 7. 8 or 7? No, sorry. 8. Nashon is 8, so it's 8. Yeah. There was.
So when you're making a lambda that accesses a variable outside its JavaScript, so outside the lambda, you say it has to be effectively final. Does that mean everywhere, not just in the lambda?
So I'll be a good student. I'll repeat the question. The question is if a variable is captured in a lambda, is it final everywhere? And in the method, the answer is yes. So if you try even inline somewhere else, let's say, we can code that, it'll be easier here. So name equal something. And then I'll do what? A consumer, let's say, of string. No, consumer is not a good idea. I'll do a supplier of string like this. S equals check. Okay, so here it is. So it's really it's really considered final. So if I want to reassign it here, I'll get the same. I'll get the error also. So it's really, from your point of view, it's final. You could even add the final, but it's not required. And it's more ugly than anything. There was Yeah, so you first. You just need to read all the files. So if you want to use, I don't know, Mustache or something complicated, or jQuery if you go crazy, you just really need, you can call a bunch of evals with all the JavaScript you want to use, and as soon as you invoke a function, I haven't tried, but I guess if the function is wrapped in a given namespace, it should work also. So I don't know if you're in jQuery and I think that should work. I can see why it wouldn't, but I haven't tried, to be honest. So yeah, you could use any library and it will work. There was another for you.
Just a question around optional not being serializable. How are you using that, when you're actually, calling AGB or whatever remotely? Are you using that currently?
I don't use AGB. No, it's true. The optional is not serializable. So you need to resolve the value and pass the null or not the null if needed. So you just work around it. But it's true that if you're stuck with, I must say I rarely assign an optional to an attribute in a given function. I'm normally returning optionals from stuff, but I don't store them. I prefer to store null or the actual value. But that's me. Yep.
That's great. Earlier you showed serializing Lambdas, and I was curious, why would you want to serialize Lambdas? Because you mentioned that they need all the same classes for the scope that they're in, if they're referencing anything. If you've got all the classes, then why serialize it?
For fun, and no. The real reason why people are doing it is for efficiency, because it's faster to serialize a Lambda than to wrap the values you want in a given class and then serialize the class. So just for efficiency, it's just faster. Because you can hide them nicely in the content of your Lambda, in fact. So it's really the main reason. Sometimes it's quicker, because it could be quicker to create your Lambda and to pass it than to having to wrap your object all correctly. But the real reason is for efficiency. Yeah.
Just to add to your answer, there is also the use case where, for example, if you have a data grid and you allow the developer to express this data grid of functions using the functions, then you may want to ship the Lambda so that it's executed closer to the data. Rather than shipping
Yeah,
the plans, you ship the Lambda to the server. That's also a use case for shipping Lambda.
That's also true. You still need to have in your class path the actual result, the actual class that will be used. But if you want to do distributed computing, you could serialize any Lambdas, and as soon as it's available in the other class path, you just call it and trap values in it, so the values are coming from the caller. Other question? There was one there. Okay, you. Sorry? The Stream API, yes.
Performance enhancement.
They are okay. They are optimized as much as possible. If you may micro benchmark them, you might see that so if it's like just an iteration on a list, it will be normally it will be a bit slower, I'll say. However, it's frequently faster. It depends on what you're using, because there are some complicated things, like when you do an iteration. If you do an iteration on bytes, for instance, you better process 4 bytes at the time, or if you're on a 60 bytes architecture, you will do 8 bytes at a time, because they will be read in chunks like that. So in fact, you should offload your, you should duplicate your code to be able to process a big chunk of bytes together. Sometimes the JVM will do that for you behind the scene. And also the streams might do these kind of things behind the scene in some cases. So it will prevent some false sharing or some low-level optimization. In some cases, it will be faster. In general, from my experience, it's a bit slower than imperative. However, the fact that it's lazy loaded and lazy interpreted will give you a big performance benefit, in fact, because a lot of things won't be done at all, and they were before. So I think depending, if you're doing, I don't know, some high-performance trading, you have to think about that. For all of us, just don't think about it and use it. It won't be that slower than doing the iteration, and it's much nicer, in fact. So that's, there was one there.
What happens if you find first one? Do all the other threads terminate, or how does parallel stream manage that? So when you're using parallel streams.
So when we are using parallel streams,
When you find a first match with filter.
no, it's a thread pool. So it will be submitted to the thread pool. So the tasks are submitted to the thread pool, depending on the size of the pool at that moment. And if needed, it will grow. The way the fork join common pool is done is that it should stay lively. So if you submit tons of really long tasks, it will add new threads forever and ever until it crashed your JVM, in fact.
What happens when it finds the first match with filter? Do all the other threads?
Yes, it stops. So if you do parallel stream and then first match, it will stop. Yeah, but it will. The ones that are running will still be running, of course, but it will just return you the first value like it should. Yeah, but a lot of the methods in the streams, whether you're parallel or sequential, will stop as soon as it finds the value it's looking for. So you can get really nice performance improvement for find first, any match, these kinds of methods, in fact. Yes, sir.
Can you define the parallelism when you do the parallel streams, like how many threads per executable?
As I was saying, so the question is how many threads there is in parallel. By default, I think it's the number of CPU plus 1, if I'm remembering correctly. Then it's a bit weird because if you have one CPU, nothing will be parallel. You get a sequential pool, in fact. If you have two CPU, you also get a sequential pool for some reason. If you have more than two CPUs, then you're in parallel. And I think, yes, you have one. At startup, you have more threads than the number of get available CPUs from runtime you get. And then for liveliness, if all these threads are used, it will add threads. And in fact, it will grow and shrink as needed. So that's what I was saying, that it's this growing and shrinking thing that might slow up parallel processing. So you could optimize by using your own pool. Other questions? Or true? Yeah, one other.
So you mentioned slide share, where you can post slides.
Yeah, I haven't done it yet. So look for my name on SlideShare. And no, yeah, SlideShare is a place to share slides. Yeah.
So just Google slide share.
Yeah, exactly. It's just like this. Here. No, but yeah, that's the French, but because for some reason it loves me in French, but and now it's all broken because it doesn't want to identify me, but that's it. And if you look for my name, you will find my slides for this presentation and others. I'll put it tonight probably. Yeah, that helps. You think? Yeah. Okay, I'll do. Then I'll do it. For sure. Yes?
Could you go back to the JavaScript slide?
The JavaScript slide?
Calling the JavaScript method from Java.
Here.
This one. So when you say engine, which browser can I?
The JavaScript is like ECMAScript. It's a standard, so there's no browser involved in there. It's just a language that is interpreted in Java. So it's not linked to a browser at all. It's really the Nashorn implementation. So the Nashorn, it's Nashorn that runs the JavaScript there. That's why you also have access to all the Java API. But if you try to do document.something, that won't work. There's no DOM in there. No. 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 It will evolve through the delivery of new Java version, but you cannot use V8, for instance, because you want to use V8. That's the only one you can use. In fact, that's the only one that's really easy to do and that is available. However, if you want to do, if you want to do a Groovy scripting, you could plug your own Groovy scripting in there if you need. So if you want to swap the JavaScript implementation, you could, but it's a tremendous work. It's not like just swapping things around. So you need to code a bit. So it's not impossible, but it's kind of hard. But as you see, it's a stream, in fact. So the stream can come from wherever you want, in fact. So so no, it doesn't need to be local. It could be if you read the stream from an URI, it works also. Well. Yes.
Can you show your correct example?
What?
The correct example?
The correct example. Functional here, yes. Yeah, this one?
So this list is actually initialized and then populated as in when it gets the values from the filter. Initialize the list based on, it's a good practice to initialize the list with
the stream will do it for you. Normally, it will check a bit like what size of the final stream, and it should size it correctly. However, there are some issues on that. Yeah, there are some collectors where you can give the actual list you want to be used, because you could also, because by default it's an array list, but you could want something else. I'm not sure I remember, however, where it is. You know, Louis? Yeah, okay. Here, and you provide a supplier. So for instance, here, you can say, yes, I know what size it will be, and I would like a linked list for some reason, because I'm crazy. And you could pass it. And it's true that in some cases, you might have performance issues. For instance, the concurrent map. So if you do two concurrent map, you will get a concurrent hash map. And I do know that the concurrent hash map is not sized necessarily correctly at first. So you will get performance slowness, I'll say. When you do it, if you put a lot of things in it, it will have to resize a bunch of times. And concurrent hash map are not that good with memory efficiency. So it will have to use a lot of memory, it will get a lot of GC, and it will slow down because it's creating a lot of objects. So yes, if performance is really important, watch out a bit about the collection you're using and the sizing you give to them. Yes?
If you're using plain JDBC to talk to, let's say, MySQL, how can we use stream to,
You can't. So the question is, if you use plain JDBC, how can you use a stream? You can't. Sadly, JDBC is not reactive so far, and there's no stream return in the last JDBC version. I don't know if it's planned for 9. Do you know? No. They need to add that at some point, because at some point we should receive some kind of stream result set that will allow. A result set is already a stream, but it's not wrapped in an actual stream. So, because there's some result set, when you iterate a result set, it does the same thing. So if you want, you can take a result. I haven't looked, in fact. You can take a result set and implement your own stream above that, but for that you would need to do it's called a split iterator. I haven't talked about that because it's a bit more advanced, and I don't think there's one in there. Let's see. I will be really surprised if they added one. No, there won't be. So it's not impossible to code yourself a stream that is backed by a result set, but that doesn't exist offhand, as far as I know, at least. And it will be really, really, really nice to have it. Also, completable features, like you could receive a completable feature of a result set, and so there's some missing things like that in JDBC. Yes.
Is a Lambda popular in the real enterprise environment?
In a what?
Is a Lambda widely used by the programmers now?
If it's used by
Lambda is now very popular in China now. I mean, in the company, we are not very used to it, but is it very popular in America?
Ooh.
The press?
Ooh, that's a feeling question. Question is it popular to use Lambdas by programmers these days? Everyone I know love it. Yeah. So it's fairly neat. The functional programming is quite neat also. It makes things much clearer than before. And it makes you think a bit less about the border plating of the normal imperative code. So it's like the for each. The for each, you do the for each like that. You just process your thing. If you do the loop, you need to think about, I want to loop, and I want to iterate, and I want to do my stuff, and I want to break at that moment, and blah, 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 blah. Now you just don't think about that. You just for each. And you know that underneath it's optimized as needed. So yes, we kind of love it. So it's not like a feature Oracle wants to sell to the world. It's really something useful that you should use for real.
Developers that do support, they don't like it because they don't understand it yet.
Yeah. We need to get used to it. Right now, Java 8 is the only supported version officially. So all the others are end of life. So you should use Java 8 at least. Then, as I said, you need to watch out because it's all like every new technology. You need to use method references as much as possible. You need to prevent having huge one-liner that nobody can read. So as you saw in my cases, sometimes I'm returning streams for method to be able to do shorter lines. There's new design patterns that you will want to use based on that. I haven't talked about that, but there's some interesting patterns with functions. So it's like everything. You need to watch out and use it nicely, and never use Lambda with like 20 lines in it because it seems fun. But yes, it's useful. It makes your life easier. It makes the code cleaner. It makes the code shorter. So please do use it.
You can create.
It's done? Yeah. Okay. So we can continue discussion in the hall. Thanks a lot, everyone.
Hello. Thank you for coming here this morning. My name is Joe Darcy. I work in Oracle's Java Platform Group, and I'm going to be talking today about JDK 9 language, tooling, and library features. If we don't get to your questions at the end, or if you're watching the talk on streaming, you can tweet questions to the hashtag on the first slide here, JDK9 langs tools libs. This is a very important slide from Oracle's lawyers. They want you to make sure to not put too much trust in what I have to say here during this talk. This is the safe harbor slide. I must say, though, if you're interested in safe harbors, there are many other safe harbors in the Bay Area for you to visit. So please, especially if it's your first time here, please make sure to check out some of these other safe harbors in the area. Quick survey. Which JDK 9 release are you using now in production? Just a show of hands. JDK 9 early access with cutting-edge Jigsaw? A few people using that. That's good. How about the other JDK 9 builds, the usual ones? It's good to put these in your CI systems now to see how your products work with the upcoming builds. JDK 8? Good. It's good to see. Strong adoption, JDK 8. People still on 7? That's maybe 15, 20% or so. 6? Still some hands for 6. All right. Now admit it. Who is on 5 or older? Anyone? Okay, we have a few brave souls who will admit. Hopefully after this talk and others, you'll have more motivation to try to update to some of the newer JDKs we've had since then. An overview of JDK 9. Current schedule released next year in July. As I mentioned, the early access builds are already available. There's one main release line of development and a second one for Jigsaw that's a little more farther out for that product. JDK 9 is being developed under the auspices of OpenJDK. So if you're interested in following the development as it goes along, there are mailing lists and projects, so you can get the source code. There's also the adoption group if you want some help getting started with JDK 9. Part of the adoption group is also an outreach to various open source projects to have them run their test suites and their products with JDK 9 to give us more feedback sooner about how other software products in the ecosystem are working with 9 along the way. Throughout the rest of the talk, I'll be using the term JEP for a JDK enhancement proposal. These are documents we use for project tracking now. And Duke needs you, yes, you, to help out and try your Java programs with JDK 9. Please let us know how it goes so we can make any improvements before GA next year. Now, as you've no doubt heard, modularity is the big feature coming in JDK 9 in Project Jigsaw. And in a nutshell, modularity lets you group together groups of packages in a unit with stronger encapsulation than you find in a jar file. Now, this is a very pervasive change to the platform. We're changing the language. There are new module info files that allow you to declare the dependencies between modules and other aspects of the modules. So that means we have to modify the javac command to recognize the new source files. We also have to update the runtime command Java to recognize the modules. And there's also updates to core reflection and things like that. So we would have to do those set of changes for many larger language changes, such as Lambda, would have to change those as well. But with modularity, it's also a change to the programming model. So it's really a much more pervasive change than many of the changes we've seen previously to Java. So the modularity work wouldn't fit all in one talk. The Jigsaw team's actually giving 5 talks here at JavaOne. Most of them are given twice. There's some of them starting later this afternoon in this very room. So if you want to head out and come back in later on, you can get caught up with Jigsaw. There's also a hack session later in the week. After some brief notes about our stewardship of Java, there's 3 main areas we'll be talking about. First to note, though, that JDK 9, even without Jigsaw, is a significant release. It's very large. Just to give some scope, here's a quick graph of the bug counts in 8 versus 9. So basically, since the beginning, we've had a higher bug fix rate in 9 than in 8. So it is a very significant release, even without Jigsaw. And we'll be talking about the non-modularity features in this talk today. You can group those features in 3 basic areas: tooling improvements, language libraries. The features don't always align neatly with these divisions, so that's not a strict division of the talk. And if we have some time at the end, we'll do Q&A. So first, a quick note on stewardship. Now, the approach to stewardship we use in the JDK is not the sort of stewardship we saw by Denethor in the Lord of the Rings films. It's much more benign. Actually, under Oracle, the main priority of the Java Platform Group has been to keep Java vibrant. That's been our consistent priority over the years, and that influences the approach we use to evolving the platform. So this is written up in this document, the OpenJDK Developers Guide. Part of keeping Java vibrant is, for the most part, keeping the things that work today working tomorrow. There are exceptions to that, of course, but that's the default. In more detail, what that means in technical terms is that we want to preserve compatibility. And there are different kinds of compatibility you can talk about. First is binary compatibility. That's defined in the JLS as the continued ability to link. So when Java goes to run your jar file or other artifact, you can still link it and get it started. There's source incompatibilities. Does your code still compile? If it still compiles, does it compile to a program that means a class file that means the same thing? And finally, there's behavioral compatibilities. What does your code actually do at runtime? So we want to keep all of these in mind. This informs our language evolution too. We want to make sure to keep recognizing the old class files so you don't have to recreate your jars for new versions of the platform. We want to limit the cases where old code doesn't compile anymore with the new language version. And we don't want to introduce silent changes in how Java C generates code for the most part. And that is supposed to be a three-dimensional graph, but you can't see the axes on the display there. Okay, but just imagine it's a grid for source, binary, and behavioral layout, like you might see in physics class. So this compatibility policy differs for different releases, or the implementation of it differs. So if we have a release like the quarterly security updates that come out every few months, we want to have a very small compatibility impact in that kind of release. So we might have something that's limited to the source behavioral plane. So we want a little bit of behavioral compatibility. We don't want the exploits to work anymore if we're fixing a security issue, and maybe a tad of source incompatibility. If we have a larger update release, something like 8U20 or 8U40, we have a little more room to maneuver, a little more leeway to make behavioral changes because it's a larger release, but still not too much source compatibility. And in both of these cases, no binary compatibility change. We don't want people to not have the ability to link on the program. If we have a feature release like JDK 8 or especially JDK 9, there's more room. We will make larger behavioral changes. In some cases, we'll make source incompatible changes. And with enough justification, we will make binary incompatible changes in a release like 8 or 9. So let's give an example to help illustrate how this policy works in practice. This is the specification for hashmap.iterator, returns an iterator, and a particular note here, the elements are returned in no particular order. That means a correct program should not rely on the order of the elements returned by the iterator. So that's allowed by, so if we want in the implementation to change this order, that's allowed by the spec. So going through the different kinds of compatibility, that's binary compatible. There's the same set of methods, so nothing's changing there. It's source compatible for the same reasons. It's nothing that would affect the source code is changing. However, it is a change in the behavior compatibility. And we know that people can and do rely on the iteration order. Sometimes even our tests rely on the iteration order. Then we have to fix the tests. So this kind of change generally wouldn't be allowed in either kind of update release, but it can be and has been made in a feature release like 8 or 9. When you update to new JDK, or perhaps as you've already updated to JDK 8, we use this binary source behavioral compatibility documentation in the release notes and compatibility guide we produce for the JDK release. The slides will have a link to the guide for 8. A particular note, if you've updated to 8, you might have already run into this. The order of methods returns by class.get methods changed in JDK 8. So if you had a JUnit test relying on that, you had to update them. And later in the 9 timeframe, we'll produce a similar document for JDK 9. And if this sort of discussion about compatibility interests you, there's a talk by Ian Robertson later in the conference about the science and art of backwards compatibility. Ian is in the audience, but since this isn't a keynote, we won't have him come up and do a walk-on. So how is JDK 9 different from other platform releases? With modularity coming, because it's a large feature and it's one that we think is necessary to keep Java vibrant for the next 21 years, there's a larger compatibility, a larger set of changes we'll make to compatibility, more so than usual. For example, in terms of behavioral compatibility, we're making changes even in the layout of the file. So there is no rt.jar in JDK 9. So if you have some process that relies or assumes rt.jar will be there, it's not anymore, and you'll have to update that. So that's a good reason to start the early access builds now, to be aware of all these things sooner rather than later, rather than when you run into JDK 9 a few years down the road. To help support modularity, we're even breaking binary compatibility in a few cases. This was documented at the end of Java SE 8, and we've implemented it in 9. There are some unfortunate dependencies on Java beans in far-flung parts of the platform, like JavaUtil, which is part of the base module, so we don't want the base module to have to depend on beans in terms of property change listener, so we got rid of those methods in 9. So that is a binary incompatible change, but we feel there's sufficient justification to make it in 9. We're also going to have a more muscular deprecation policy in 9, and we'll be hearing more about that later in the talk. And that's to help better manage transitions across JDKs over the years. All right, so now we'll start talking about tooling improvements. First one I'll talk about is JShell. In a historical perspective, a common way of implementing with many other language environments, especially in the Lisp tradition, has been an interactive shell called a read, evaluate, print loop, or REPL. Now, there's similar functionality you may have seen for other languages you use, like Ruby and Python, and on the JVM side, Scala, Groovy, and so forth. So what about Java? Now we have one, a command that does this called JShell in JDK 9. I'll do a quick teaser demo of that. So JShell is a command in the JDK 9 bin directory, so we can just get that started here on a JDK build. So you have a shell. Good thing to do in a shell is get some help. So you can print that out here. If the screen was a more usual size, the help output would be more useful. And I will make this. Now the output should fit on the screen. Not quite. Even when you think you've gotten things set up ahead of time, sometimes you haven't. OK, here we go. So what's the first program you write in a programming language? Hello, world. All right, so we can start typing that right here, and hit return, and JShell evaluates that as an expression. So notice we didn't have to do any public static void main, string, args, all that. We can just start typing right away and get some results. But that's not terribly compelling. We can also define variables in JShell. So let's say we want to define a double variable tau that's equal to 2 times pi. And pi is, of course, in the math class. So if we do autocomplete, hitting tab, JShell will list the choices here. So if we type p for pi, that completes for us. So that's about twice pi, so that's good. We can define methods in JShell. So let's say we want to define a squaring method that takes a x and returns x times itself. So that's added to our environment now. And now we can evaluate additional expressions using this. So let's say we want to square, autocomplete for that, math.sign. You can take that, and we can use the variable we had previously, tau. We can do usual command line editing. And if we take the sine of a angle and add it, the square of the sine of an angle and add it to the square of the cosine angle, we should get something close to 1. And that's indeed what happens here. Go back to the presentation now. So a few things about this. If you're a new student getting started with Java, there's a lot less ceremony. You can just start typing your expression right away without having to void this. Well, what does public static void mean? It's like, well, it's a long story. We'll get to it later in the course. You don't have to do that anymore. But this is not just a feature for students or people learning for Java. It's also very helpful for experienced developers. This is a good way to explore using those new 9 APIs, or if you haven't upgraded to JDK yet, the new APIs that you haven't worked with so far. And we found this very useful in the JDK group, playing with new language features. In terms of how JShell is implemented, it uses a lot of interesting technologies in the JDK, including a API to programmatically call JavaC and some debugging APIs. And the lead engineer for JShell, Robert Field, will be giving a more detailed talk about JShell later in the conference. Javadoc. So for many years, Javadoc has been outputting HTML 4.01. A few years ago, there's a new HTML standard, HTML5 came out, and now Javadoc can output HTML5 as an opt-in basis. Even though it's outputting HTML5, there are no videos by default, though. So the Javadoc output still looks basically the same as before in terms of a frames style layout. How many people have worked with doclint that we introduced in JDK 8? There's a few hands there, perhaps a few grumbles with unwanted warnings or errors in your build. Doclint is a lint checker on the structure and semantics of your Javadoc tags. That works both in JavaC as well as Javadoc, so you can add it to your build. We've added some additional controls for doclint in JDK 9. Besides the previous controls over which categories of errors, you can now limit the doclint checking to particular packages. For example, in the JDK build, we only doclint the Java.x and JavaX.star packages. These are the particular doclint categories, and they do range over from the syntax of the HTML to the semantics of it. So you can do things like if you reference a @c or @link to a method that doesn't there, that's a semantic error, and that can fail the build at that point. So you can make sure to keep it up to date. Are there any doclet writers in the audience? Not this time. So the standard doclet is the most common doclet that we use to generate the HTML as part of the Javadoc output. But you can write your own doclets too. The original doclet API is very old. I think it's fair to say it doesn't follow current best practices in Java API design. So with the benefit of hindsight, we've been able to design better APIs, including a better language model that's more extensible, and we've re-implemented the Javadoc command on top of the new API in 9. Another Javadoc feature we're excited about in JDK 9 is search. I'll do a quick demo of that. All right, so now you can see in the upper right-hand corner of the Javadoc output is a search box, and you can start typing into it. So let's look for math. So this shows a few things here. It finds occurrences of math in the package names, so the java.math package in the base module, as well as type names, so JavaLang math and Java math big decimal. It also goes down to methods and fields farther along. This also works over modules, so if you want to look for the base module, that can pop up right there, and then you can go to the Javadoc page for the base module, and you can see the packages in that module as well. So you won't have to use the search engine as often to find things in Javadoc. You can just search right in Javadoc instead. This is a client-side implementation JavaScript. As I mentioned, it does index the names of packages, types, fields, and methods. There's also a way you can add additional index terms for your own items if you choose to do so. The next two features are going to be about facilities to help transition from one JDK to another one in the future. Multi-release jar files and the JavaC -- release option. First up, the -- release option. For many years, JavaC has been able to cross-compile back to older JDKs. In the JavaC man page and elsewhere, there's been a description of how to do this. You have to do 3 things. You have to set the source to the version you want, the target for the class file version you want, and finally, you have to set the boot class path for the rt.jar classes.zip of the old release. You have to do those 3 things. We've, starting in JDK, restricted the range of old versions we support to 1 plus 3 back. So in JDK 9 in particular, 9 is the default. We support 8 and 7 as well as 6, but 6 is deprecated and you get a warning issued when you use it. So likewise, when we roll them out to JDK 10, we'll support a 10, 9, 8, and 7, when 7 will be deprecated. All right, so why do you have to set the boot class path? Well, let's take an example here. In JDK N, we have a library that has a foo method, and then in JDK N plus 1, we add an overload foo that takes an int. In terms of our compatibility policy, this is a fine change. It shouldn't cause many problems. And let's say we have our client library here that has a foo with an integer argument. All right, that's good. So let's say we take this code, we compile it against this JDK, but we run it against this JDK. So when we compile it against JDK N plus 1, the compiler sees, okay, you have a foo method, it takes an int, so which foo method is it going to call in the class file? The one that takes an int or the one that takes a double? It's going to compile down to the one that takes an int. That's the more specific one. That's what's required by the language specification. So then when you go to run that class file against the earlier JDK, even if you've set the class file version appropriately, you'll get a message like this. No such method error. And what this basically means is it's looking for foo of int and it's not finding it. And that's correct because there's no foo of int there, there's only foo of double. So this is why you have to set the boot class path to avoid this sort of situation. But people kept running into this. Back in JDK 7, we said, you know, people keep running into this. We'll give a warning if they use the older source or target without setting the boot class path. So we did that. That helped a little bit. But we still kept having bugs come in. So in JDK 9, we thought, you know what, why don't we just actually provide the feature people want to use here, which is to cross-compile to the old version and make that easier to do instead. So that's just what we did with the -- release flag. A note on that, we're adopting a more GNU-style option convention, so -- release versus just -release. So this is semantically equivalent to doing all 3 of setting the source, the target, and the boot class path to the old rt.jar. Now, the information from the old rt.jars, the old versions of the platform, is stored as part of JavaC. It's part of the JDK build now. So it's a compressed format. As another benefit, and one way to help get ready for modules, the -- release will only provide the APIs for the older versions that you're supposed to use. So it'll only provide the Java SE APIs that are part of the standard, as well as the exported APIs in the JDK. And it's the same set of release values as for source and target. So this has a few advantages. If you were being diligent and using the old rt.jars, you don't have to manage that anymore. You don't have to try to get that from somewhere. To address this problem, people sometimes use Maven plugins like Animal Sniffer. That's come up sometimes, so you should have less need to do that because it's just right in JavaC. Another advantage is we may make improvements to JavaC in newer releases. There are bug fixes, sometimes there are performance improvements, and you can take advantage of them if you use the -- release flag. And we'll see an example of that later in the talk. So multi-release jar files. So if you have a library, it's inconvenient to have different jar files or artifacts for it to correspond to different versions of the JDK. Right? You prefer just to have one artifact and distribute that instead. So that has a few downstream effects. It means there's slower adoption of new features because more people are compiling for against the original jar files. Now you can work around some of these problems occasionally using reflection. So like if you want to call a new in 8 API only when you're running on 8, you can check for it reflectively and all that. So that sometimes works, but it's awkward code and it's certainly slower at runtime than just using a normal call. Now another feature is that with the modularity support coming in 9, it's going to be harder to access the APIs you shouldn't be using, like those tempting sun.star APIs that many people find helpful from now again, but you've long had a policy of not calling them. So you won't be able to get to them as easily in 9. So as an alternative, we added a multi-release jar feature in 9. So there's a common area of the jar files as before that's shared across all the releases. Then there's platform-specific overrides put in meta inversions. So if you have a base jar file for 8, you can put 9 specific class files that kind of override the other class files in a versions 9 directory. Similarly for 10 and so forth. You create these with the jar command using some extra options, and the other parts of the platform that read jar files, including the jar file API in JavaUtil as well as JavaC, are aware of the multi-release jar files now. We'll next talk about a number of the language changes made in JDK 9. First, I'll talk about a set of milling project coin features. Milling on a coin is the name for putting those ridges along the edge. That was originally done as an effort to avoid debasing the currency. Back when coins used to be made of precious metals, people would kind of shave down the edges to get the silver or gold and sell it separately to kind of devalue the currency. So for milling coins was meant to prevent that. In our sense here, milling project coin is meant to keep the value of the coin features up to date by fixing some unfinished work from early releases. These were the feature set in JDK 7. We were generally happy with that at the end of the release. However, there were a few features where we wanted to tweak it a little bit, but we ran out of time in the release, so we're getting back to finish that now. First one of these, Project Lambda is in a similar situation. They also had some work they didn't manage to get to at the end of JDK 8, so we're including that as part of milling project coin in JDK 9. First up is safe var args on private instance methods. So this is code you could have written in the JDK for many years, back from JDK 5. You have a list of strings, and you're using some platform classes, arrays.asList, to initialize it. So that all looks fine. When you run this through JavaC, though, you'll notice you'll get a warning like this. Unchecked generic array creation for var args parameter of type list of string array. So it certainly sounds very, very intimidating that something might be going wrong here. This sort of warning is mandated by the specification. It is possible that something bad is happening, something called alt heap pollution. This is discussed in the Java language specification. Basically, there's a bad interaction between arrays and generics that could possibly occur in this situation. Now, in this particular occurrence, using arrays.asList, nothing bad actually happens. The sort of bad things that could happen don't happen in this case. And that is a nature of doing this kind of soundness analysis. So if you have an analysis you want to be sound, that means you have to warn if you can't know that something bad doesn't happen. But that's not informative in this case. This is basically a false positive. And we wanted to address this situation with Project Coin back in 7. So what we did, we added a new annotation type, safe var args, that basically means, trust me, I'm not doing anything bad in the var args method. The sort of heap pollution problem, that's not going to occur here. And we updated the platform methods as appropriate to have this annotation. That did two things. It got rid of warnings in the declaration of the method, but more importantly, it got rid of warnings at all the uses of these methods. So all the user code that called these methods didn't have those warnings anymore. So that was pretty good. Due to some aspects of the design of annotations, we can only apply this annotation to methods that cannot be overridden. So what are some kinds of methods in Java that can't be overridden? Well, we can't override final methods by definition. We also can't override static methods. Now, for the same reason, we can't override constructors. From a certain point of view, a constructor is just a very special static method. That's kind of how it looks at the VM side. So we can use them there. Now, there's actually another kind of method we can't override either, and that is private methods. Now, private methods were omitted from the list of methods you can use safe var args on in JDK 7, and now we're fixing that in JDK 9. And this is a very small language change. I will show the entire specification change on the screen now. So we like it when we get nice, simple changes like this because they happen so rarely. So usually they're much more complicated. Next up, we have some changes to the try with resource statement to have it use effectively final variables. Just a quick refresher, the try with resources statement, so you have your resource being managed, and basically the try with resources make sure the close method gets called when you leave a block. So it gets roughly translated by the compiler as something like this. So there's an additional try finally around your block here. And you make sure to call close. It's actually more complicated. So in terms of full disclosure, this is what JavaC actually does on our behalf. But we don't have to worry about this because JavaC takes care of this. The extra complication is because of some nuances of exception handling. So in JDK 7, the resources being managed have to be done under a fresh variable declared as part of the try with resources statement. Now, if you followed Project Coin in JDK 7, that wasn't the original proposal. Originally, you could have any expression here that had the type autoclosable, which was the new type created to host the close method. But we figured out that this could be problematic. So let's say we have a resource here. We have it point to a first resource, resource 1. We pass that in. OK, it has the right type. And then within the try block, we change R to point to a different object, resource 2. Now we exit the try block. Which object should have its close method called? So this is a bit of a problem, and in particular, it's a problem we didn't want to have to solve. So we decided that, you know what, we're just not going to allow that. We're not going to allow the situation by requiring you to have a fresh resource variable, so you won't have to run into that situation. That was a bit overly strict, though, because there are variables that can't be modified in the try with resources block, like final variables, or effectively final variables, which are variables that the program would compile if you made them final, but you just haven't made them final yet. So what we can do now is to take advantage of that. If you have a variable that's final or effectively final, instead of declaring a new variable in the try with resources statement to host it, you can just pass it in directly. And since you can't change R inside the block, we don't have the problem of like which object to call its close method on. Here's the grammar changes for that. Not very hard to add the grammar change. The spec change is bigger, as we expect here. It's a little more complicated than you might suspect. So you might think like, well, you just need to have like final local variables or something. We prefer if the language changes are more orthogonal. So you can actually do things like if you have a final field within a newly allocated object, well, that's final too. So you can use that in your try with resources statement instead. And that's what the longer specification here allows you to do. Next language change has to deal with diamond. Diamonds are made under the earth in great heat and pressure, and we'll have to go down the rabbit hole a little bit to see why this feature is needed, but it is a good change we got in tonight. So we'll be using this little example of a box type. You can think of a box as a simplified collection. It's generified. You take objects in, you put objects in and get objects out. So you have a list of question mark here, and you want a new box to hold the list. So this should be fine. So what happens with this diamond? So inside the compiler needs to infer a type to use for box. So Java is still a statically typed language. It's just not always an explicitly typed language, meaning the compiler sometimes infers the types on our behalf as programmers. So what does that look like inside JavaC? So the type that's conferred is list of capture of question mark. So you can't write a type list of capture of question mark in your source code, so what's going on here? Well, this is something called capture conversion, and this is a non-denotable type, which is described in the JLS. Now, this is a part of the JLS where you might want to have a type theory book nearby to help figure out what's going on. Basically, what's happening is that, as is often the case in languages, there's a richer type system inside the compiler than the one made available to the programmer. So when JavaC sees a wildcard, the question mark type here, it translates that down to a new, fresh type variable inside the compiler and reasons about it. That's what the capture conversion process entails. So you have your box class. One thing you can do with the box, you can subclass it. It has public constructors. And you can also subclass it anonymously. All right, so that might be OK, but maybe it's not. So how do you compile down an anonymous subclass? So there's a full class file for it. So if we would write it in source code, it looks something like class of box $1, extends the box, and we need to have some type to fill in for how it extends box. And the type that's inferred by the compiler is this list of capture of question mark. So far, so good. However, there's a bit of a problem here because this information has to be stored in the signature attribute of a class file. The grammar of the signature attribute does not allow non-denotable types like list of capture question mark to be stored, to be represented. So this is a problem here of using Diamond with anonymous classes when you have these non-denotable types. So what's been the interaction here over time? Way back in 1.1, many years ago, inner classes were added. Years later, generics were added, and generics were added in a way that interacted with inner classes, so that was fine. Then in JDK 7, we added Diamond. And inner classes and Diamond interacting together work fine. Inner classes and Diamond and generics interacting together separately work fine. But when we combine all these three things together, we get a visit from Fang. This is Duke's evil twin brother who's coming to mess up our plans to improve the language. And as Brian Getz is fond of saying, this is a case where today's problems come from yesterday's solutions, where these language features made over a decade apart had this very unfortunate interaction. This was actually discovered by our JSK team when they were writing conformance tests for the feature back in 7. So unfortunately in 7, the solution had like, you know what, this sounds kind of complicated to deal with. We're just not going to let you use Diamond with anonymous classes. So that will avoid this problem for sure. That was a little unfortunate. So when we were finishing up the JSR 334 specification, we did note that, you know, as future in the platform, we could allow Diamond with anonymous subclasses if we don't get those non-denotable types. If we just had a normal denotable type, then it'd be fine and we could use it. And that is, in fact, what we've done now in JDK 9. The specification to do that is more involved. This is how you say non-denotable in JLSEs. Fortunately, our spec guys take care of that for us. So that's here. So what's been the effectiveness of this? When we were initially designing Diamond, we could get rid of about 90% of the explicit constructor arguments using the Diamond feature in 7. And we feel that by allowing Diamond with denotable types in anonymous classes, we can get rid of a lot of the remaining 10%. We've had good experiences using this feature in the JDK. We've updated hundreds of call sites to use this, often for this security privilege action. Next up, underscore is no longer an identifier name. So this is something that's been discussed as part of Project Lambda a number of years ago. When you have a Lambda parameter in 8, you cannot use Lambda as a parameter name. And if you use Lambda as a parameter name in 8, you do get a warning from JavaC notifying you that, well, one day you might not be able to use this as an identifier anymore. And indeed, that day has come to pass. So why are we doing this? This is against our usual policy of keeping programs that compile compiling. We feel it's not used very often and that there's better future use of it if we reclaim the syntactic real estate. Some things that might show up are partial diamonds, so just infer one type variable and another, or partial witness like this on a generic call. Maybe we can encode this as something else, like parameter names to specify, not use messages, and so forth. Private interface methods. One of the other changes made by Lambda in 8 was default methods. These are methods on interfaces that have code, so they're non-abstract. And so these are very helpful in evolving the platform. At the VM level, it was convenient and necessary to actually have private methods on interfaces to help have some of the metafactory stuff go on. However, at the source level, you couldn't have private methods inside interfaces. And now we're changing that in 8 so you can also have your own private methods in the source code of interfaces. You can both have private static methods and private instance methods. So what would you do with such a private method? Typically, you'd have that as a helper method for the default methods in your class. So you can put some common code together as a private interface without exposing that to all the users of the interface. Next up, we'll start talking about deprecation and import statements. So as a bit of background, the JDK is a large Java code base. We've had our share of technical debt over the years. This is a multicolored diagram of the JavaC warnings we've had building the JDK itself. As you can see, back in JDK 8, it was over 10,000. So we had a few number of messages in the code base. Over the years, we made progress on this. We had some good interns and some other days, and later on, we started turning warnings on in the build. And from the time of this diagram stops to later in JDK 9, we went from thousands of warning messages left down to 0. So in the core part of the platform, the open code, the closed code, the generated code, it's all warning free. We build with excellent WR. This covers many of the doclint features as well. So this covers the core parts of the platform, meaning the base module, and the Javadoc base module and desktop module. It does not include things like Corba, JaxP, and JaxWS instead. Maybe we'll get to those someday, maybe we won't. And people often talk about technical debt, but I think the benefits of a project like this can be seen as technical dividends. There are now entire classes of problems in the JDK we don't have to worry about anymore because they'll be caught by the build and people will fix them right away. So for your serializable class, did you declare a serial version UID? Even an exception type, because all exception types are serializable. How about equals and hash code? It's easy to make a mistake there. There's a very nuanced check we do now in the compiler that make sure you do things properly. There's even possible security implications. Something like a switch fall through, you can execute unexpected code, and that's the same basic problem that was in that go to fail security issue from a few years ago. And finally, is it really acceptable to have more deprecation warnings on a deprecated item? So I did write a blog entry if you want to, from the JDK experience, removing warnings, recommendations you might want to have for your own project to go through a similar effort. Now, the very bottom layer of that graph of the warnings, there was a crust of very stubborn deprecation warnings that we had to get rid of as well. Deprecation warnings are generated by the use of deprecated types, methods, and so forth. These are mandated by the JLS. Now, there's a few ways you can resolve these warnings. You can remove the use of the deprecated elements. That's great when you can do it. You can't do it all the time. It might be part of the API. You can propagate the deprecated annotation to the use site. In this case, kind of the cure is worse than the disease. You're making the deprecated part of the platform bigger instead of smaller. And finally, you can use the suppress warnings feature to suppress warnings of that case, and that's what we often did. All right, so here's some client code, and here's a deprecated library. So when you run the compiler, you see that indeed you do get a warning that it uses a deprecated API. It uses deplib right here. So you say, all right, no problem. I can't remove use of the API. I don't want to make my client too deprecated, so I'll suppress the warning instead. So right at the top of the class, I'll suppress the warning. I'll run the compiler again, and you still have deprecated API warnings. So what's going on here? If you look at more information, JavaC is warning you that, well, yeah, you're using the deprecated type in the import statement. You're not using it in the code, it's in the import statement. This is also mandated by the JLS. You might say, well, okay, I'll just add suppress warnings on the import statement. That doesn't work. That's not syntactically allowed. So if you really wanted to get rid of the deprecation warning, you could do something like, for each use of the deprecated type name, replace it with a fully qualified name of the type instead of the import name. Well, that's a little silly, right? The program is just as bad if it's using a short name versus the long name. So why do you have to go through this fuss instead? So we changed JavaC to not require emitting a deprecation warning in this location. So if you're on an import statement, you don't have to get the warning. And that was an easy fix here, just one sentence in the JLS. But because of this fix, it's now tractable to remove the deprecation warnings from a significant code base, and we have an existence proof of that in the JDK. So I encourage you to try to get rid of the deprecation warnings in your own code because of this fix. There's actually much more to say about deprecation in JDK 9. That's just part of it. So what does deprecation mean? It's been a little unclear over the years. Does it mean that this API is harmful? Does it mean it's going away? If it means it's going away, why haven't those guys in the JDK group removed any of these things that have been deprecated for years? So we wanted to enhance deprecation in 8 to help answer these questions and make the management of deprecated APIs easier over the years. So there's some new methods that were added to the annotation. one that says whether or not this deprecated item is full removal or not, and that defaults to false. Another one is since when has the item been deprecated. We've updated the deprecated annotations in the core part of the platform to have this additional information in them. They're supporting updates both in Java language specification, JavaC, and Javadoc. There's also a new static analysis tool called JDepreScan that will analyze your class files and jar files for use of APIs that are deprecated in the JDK. So one issue when we add new deprecations to the JDK, say in JDK 9, people don't always recompile their sources, so they don't have a way to get notified that things have been deprecated now. So JDepreScan is meant to resolve that problem because you can take an existing jar file, run JDepreScan, and see if it's using APIs that are now deprecated in the new version of the JDK. There's much more to say about the deprecation feature. You can get the full prognosis and history from Stuart Marks, aka Dr. Deprecator, at a talk later in the conference. Finally, we'll talk about some mostly library updates. Besides having a new version with JDK 9, we have a new version string scheme. The summary is we're getting rid of the one dot in 1.9. So if we're never going to change the one, we figured might as well just get rid of it. This is also done to align better with the semantic versioning and things along those lines. So this is what the current version output looks like from JDK 8 build, and this is what it looks like now in 9. So if you have some system that parses the version string output, you'll have to update that a bit. If you use native processes on systems, there's a better API to do that now. In particular, you can now get something that represents the PID of the native process, so that's handy when you need to do that. Strings are one of the most commonly used types in Java. There have been some changes there. The compact string project, previously, inside the string, the information was stored in a char array. So that's 16 bits per character. Often it's the case that all the characters in the string have the upper 8-bit 0 because the characters are all in the first 128 characters. So with compact strings now, based on the contents of the string, it always uses a byte array, and sometimes it uses a 1 byte per character encoding, and sometimes it uses a 2 byte per character encoding. So this is transparent to users. It's the same API, but there's better memory density. Related to strings was improving string concatenation. String concatenation is another very common operation. JavaC will generate calls down to string builder to do this. Now the pattern of string builder calls JavaC generates and the patterns of string builder calls a particular VM recognizes as being amenable optimization may differ. And they may differ over time as one of the other changes. So instead, to address this, because it's a common operation, we created a new entry point in JavaOne string concat factory that JavaC can use to output the string concatenation, and then the VM can recognize specially at runtime to optimize. So again, this is mostly transparent to users, but should result in better performance for string builder, and it should be future-proof in terms of API updates in the future, so it's less brittle in terms of the optimization front. There are other cases where we've improved the engineering of existing features. One of those is called tiered attribution, which dealt with type inference in JavaC. So we've talked about type inference before with Diamond. So we have it here. We have a class with a generic class. We want to have a constructor for it. We use Diamond, so that's fine. So we start compiling it, and we start having some nesting of these constructors. It takes a little bit to compile, and it's taking longer as we get more nesting, and it's seeming to take a lot longer than it really should for this length of program. So if you just have 16 nested calls here, on the machine we use, this took 25 minutes to compile. Now, it is a bit longer, but it seems kind of excessive. And the same thing holds true for Lambda. If you have nested Lambdas like this, you can also get very long compile times. Now, we don't want to give people an excuse for having sword fights waiting for their class to compile. So we can graph this here. At a linear scale looks pretty bad, but we can look at a log scale, and you recall that if you have a straight line on a log scale, that means you have an exponential growth curve. So this looks pretty straight here. So this is not good. Generally, in a compiler like JavaC, you want to use linear algorithms with linear growth in the program size, or as linear you can get. So exponential is pretty far from that. So we've addressed this in JDK9 with tiered attribution. And so these lines at the bottom show that. This is JDK9 plain, and this is JDK9 using -- release 8. So this means if you compile your 8 source code on 9 compiler, you'll avoid this exponential slowdown here. So how is this accomplished? Type inference isn't magic or mind reading. It's a form of constraint programming. So you generate lots of constraints, and the most straightforward way to generate constraints generates a lot of them, an exponential number of them, and then you solve it. So the essence of tiered attribution was using memoization, which is a fancy way of saying caching. So basically, when the constraint set was built, it didn't add redundant constraints going on, and that allows this much faster solution time for the type inference. So that's good there. And this also lays the groundwork for more optimizations for inference in the future. There are other parts of the platform, including security libraries. Let's see how we're doing on time. There's different parts of the security libraries. There's Java security itself. There's APIs that you can add, use with your own codes, like cryptography, including SSL for networking. There's also a few command line options like keytool and so forth. The policy of security is secure by default. That means out of the box you can have a secure configuration, even if you have to reconfigure it differently to be less secure to meet your own needs. And there's a notion, this is something that's always changing, to keep up to date on the security best practices and so forth. In terms of the algorithms that are used, Oracle's recently published a cryptography roadmap. This documents when and which algorithms are going to get retired, so you can make preparations for your own code. So in JDK9, the crypto roadmap and secure by default has had a few implications. We've increased the default key size in some cases. For certificates, weak keys are no longer accepted by default. So if you have a certificate using MD5 or RSA with short keys, those aren't going to be accepted anymore. And the reason is, even though the functionality of things like RSA and MD5 are the same, cryptographers are very clever, and they come up with better ways of attacking the old algorithms. And of course, there's more computing resources over time. So what was considered secure in the past isn't necessarily secure anymore. And the way to guard against that is to do things like use larger key sizes. And in terms of preserving behavioral compatibility, if you really need to use the older algorithm for some reason, there's usually a system property that lets you do that. We've also kept security libraries up to date with other involvements. There's new hash algorithms. There's a new random number generator, which they call a deterministic random bit generator instead. On the performance front, processors, including Spark processors and x64 processors, will have special purpose instructions to help speed up cryptography operations. And we take advantage of those in JDK9, so using something called a hotspot intrinsic. So basically, hotspot can recognize certain operations as special and replace them with the corresponding assembly code, so they go nice and fast. If you're interested in security, there's a session on that actually happening right now. So you can't see it, but you can probably catch the replay. And if not, the security team is having a BOF tomorrow evening. You can catch them there. Saying a few words on the client libraries and JavaFX. JavaFX has also been updated for the modularity features coming to the platform, as well as high DPI screens. For the client libraries, the generification of the client libraries has been completed. This was part of the warnings cleanup effort. Again, we have high DPI across operating systems. The font layout has been updated. There are a few places in the JDK where OpenJDK and the Oracle JDK use different code bases. One of those was in the graphics rendering. One used Pisces, one used Ductus. In JDK9, they've both been changed to use the new Marlin graphics renderer. And if you like TIFF files, you can now have support for those in the platform as well. If you're interested about client, there's a session right now that you could have gone to instead, but there is a BOF to meet that team later in the conference as well. A few miscellaneous small library changes that are helpful. Here's one for convenience factory methods. So how often have you written code like this? You want to have a set of strings, so you have a hash set, and then like, oh yeah, I got to initialize it, and now you want to make it unmodifiable, so you have to have this other call. It's like, it's a bit of a hassle. It's a lot of code for what should be a simple operation. So you might say, well, I'll do something else instead. I'll use arrays.as list so I don't have to have all these add calls, and I still have to have this wrapper here. There's other ways people get around this. I won't even show the trick with the double braces. We use anonymous subclass. I know people use it, so we don't have to do that anymore in JDK 9. We can just use code like this. This is nice and short. Yes, yes, thank you. Yes, this is Stuart Mark's work. What's going on here? There's new static factory methods named of on list, set, and map. They return unmodifiable collections. To make sure people don't depend on the iteration order, we randomize it for sets and maps, not for lists. And if you want to hear more about this, Stuart Marks, who added this feature, is giving a session on collections later in the conference. Java Util Objects has some utilities for common programming tasks. There's some more null handling. There's a few methods to take the tedium out of writing index checks. A few odds and ends on the mathematical front. We have support for a fuse multiply add operation, which is also going to have intrinsic supports on different processors soon. If you like taking square roots, you can now not only take square roots on double values, but also big decimal values and big integer values. Something you might find helpful is lexicographical array comparisons in Java Util arrays. These also have intrinsic support, so they go nice and fast on processors. For concurrent programming, there have been some updates there for timeouts for completable future. And if you do rocket science kind of concurrency stuff, there are interesting things in var handle that are on par with the features in C++ atomics. So in summary, there's fundamental changes coming in JDK 9 with modularity, but there are a lot of other features coming too, including completing planned work on Project Coin and Project Lambda. And these features are meant to support long-term evolution and help ease transitions to new releases over time. If you want to find out what's happening, you can follow along on OpenJDK. And the EA builds are available now for your evaluation. So with that, I'll take some questions for a minute or two. This is a URL to the slides. You can also tweet questions to this hashtag, and please make sure to download the JK9 builds for evaluation. Thank you. Question? The question is the of, for the hash set, does it use a perfect hash for the of? I don't believe it does, but that would be an excellent question to ask at Stuart's session later in the conference.
So if strings are no longer sequences of 16-bit car, is the public interface going to update so that one can more conveniently access higher plane characters?
So the question was about the higher plane characters in strings. Is that going to be changing given the new internal representation? So the answer is no. It is as inconvenient or as inconvenient today as it was previously to get the surrogate pairs.
But now one no longer has the satisfaction that these supposed to happen. So it's now inconvenient and slow.
Well, the relative speed of different operations, work was done to try to not have gratuitous degradations in performance. So there may be some operations that are slower with the new encoding, but others that are faster. Different people want different things. So that,
Regarding the boxing of the diamond operator on anonymous types.
yeah.
For the anonymous type class, can you try introducing a parameter, type parameter, that is denoted within the anonymous?
So the question was, could you get around diamond with non-denotable types by using an explicit type argument? Yes, you could certainly basically not use diamond or try to influence the inference that was going on to make it denotable instead. But since the purpose, so that is a fallback. But we did want to support it, the inference in this case where nothing bad actually happened with the denotable types.
Could you give us the differences between EA build and EA with latest Jigsaw? What's the difference in the latest?
So the question is, what's the difference between the EA and the EA with the latest Jigsaw? So the Jigsaw feature is currently and has been in the mainline EA builds for some time. The Jigsaw team, they do some more exploratory work in the EA builds, And then once that's stabilized, it gets put into the Jigsaw train. And then once that's stabilized, they put it into the other EA builds.
So it's more bleeding edge will eventually make its way into.
Right. It's more bleeding edge. It's a little more experimental.
Regarding security updates, are you still going to have to use the limited strength libraries in the Oracle JDK9?
The question was with the security updates and using the unlimited strength libraries in JDK9. I don't know offhand, but Sean Mullen and the other people on the security libs team will be able to answer that question handily at their BOF. And I think one more question.
Not clear to me regarding the compatibility, lack of compatibility with previous JVMs. I mean, everything will be flagged by the compiler when you compile your code, or do you provide the tool to scan your code for this kind of stuff?
So the question was on backwards compatibility. So are you asking about JDepreScan, or which are you asking about?
All of it. I mean, are there situations when we, for instance, I don't even know until runtime if something of those types will happen. You know, if I run my code on the JVM, do you provide the tool for scanning the code or something? Or the compiler will tell me after?
I'm not sure I'm understanding your question. I think I'll answer it offline here. So thank you for coming.
Okay, I think we're ready to start. Good afternoon. My name is Alan Bateman. I'm giving a talk called Prepare for JDK 9. If you're looking in the content catalog, you may have seen that it's actually Alex Buckley supposed to be speaking. That was just a bit of the mix-up with the names. So on my left here is actually Alex Buckley, and beyond him is Mark Reinhold. They may help with some questions at the end. So before we get into this presentation, I just want to say that this is not a presentation about all the cool features and the big long list of JEPs that Mark showed in the keynote. This is not about all the new things in JDK 9. This is instead a talk that's focused on the implications of the changes in JDK 9, particularly around the strong encapsulation of the JDK internal APIs, which a lot of applications and libraries have been making use of over the years. There are a couple of small features in JDK 9 that help with the migration and help with interop between JDK 8 and 9 that I will spend a few minutes on towards the end of the presentation. But for the most part, this is about the implications of JDK 9. So before I start, I guess I would be interested to have some idea from this audience as to how many people in this audience are tracking the features and the changes that are going into JDK 9. Okay, so there's a couple of people. I'm curious for a show of hands as to those that have actually downloaded the JDK 9 early access builds to try things out. Similar number of hands. Okay. Here's a strange question. Who has concerns that there are changes in JDK 9 that might break their existing code or the existing applications? A couple of hands. Okay, that's fine. This is what this presentation is about. One thing before I get into this is I should explain is JDK 9 is still in development. It's not going to ship until, or plan to be shipped until 2017. There's a lot of things that are still changing in it. There's nothing that is final yet. So when I'm talking about some of the changes, maybe that'll be where it is when it finally ships. Maybe there'll be some differences. So just bear in mind that it's not final yet. First thing, just to get into this presentation, to say is it's the first of 5 presentations that Alex and I are doing at JavaOne this year. The rest of our talks after this one are very much focused on the modularity and the all the features around modules in the JDK. We'll be repeating 4 of these, and I'll have a slide at the end with the times and locations of those, so you can see what we're talking about or when it's on. I want to go through a couple of background slides before we get into the meat of this presentation. So first is just some of the background for what the goals for JDK 9 and Project Jigsaw are. So at a high level, what we're trying to do is make the Java platform and Java SE a lot more flexible and scalable, and allow us to get to the point where there's a lot more reliable and compact deployments. So deploying runtimes in the cloud or on embedded systems. We're trying to get to the point where we have a more secure and maintainable platform. When we talk about security, we're talking about encapsulating this very much the security sensitive and internal APIs within modules. And for maintainability, having these strong encapsulation and encapsulating the internal APIs will make things a lot more maintainable for the JDK. It'll also make it much more maintainable for libraries and for those using libraries, because a lot of libraries and applications are making use of internal APIs in other libraries, maybe knowingly, maybe unknowingly. So having modules will get us to the point where things are a lot more maintainable. We want to make it easy to construct, maintain, deploy, and upgrade large applications. That's both Java SE applications and eventually in the future Java E applications. And importantly, we want to move towards improving the situation with what's called jar hell, which we have with the class path today. So we'll go a long way to improving the situation with modules in JDK 9. And finally, what we're doing with modules will actually go and enable a lot more performance improvements in the future. So I want to start by going into some of the categories of APIs that you have with the Java platform. We all know the java.star and javax.star APIs. So we use JavaLang object or JavaX Swing JPanel or something like that. These are standard Java SE APIs. They're tied to the Java community process. They get defined there. They're supported and documented APIs. We all understand those. There's a bunch of other APIs that are always a little bit confusing. We call them JDK-specific APIs. These APIs are typically in the, at least historically, have been in the ComSun namespace. If you go to the documentation pages, you will actually see a number of documented ComSun APIs for security, for management, and for a few other areas. In recent JDK releases, these JDK-specific APIs have been in the JDK.something namespace because we have, since we're no longer Sun, we have moved to, and we're now in OpenJDK, we've moved to defining these JDK-specific APIs in the JDK namespace rather than ComSun. There's a whole bunch of other internal APIs that are also in the ComSun namespace. Sometimes you'll see the word internal in the package name, and it's pretty clear that this is an internal package. Others are not as clear, so there's always been confusion around these. Then there is the sun.star namespace. Most people will know that if they see a sun.star API, that's probably JDK internal. There has been sun.star APIs all the way back to JDK 1.0. So this captures one of the pages from the documentation from JDK 1.0, 1.1. Mark dug this out, I think, for JavaOne last year to show the page where there was a warning about using sun.star APIs. The date on the bottom, for those that can't read this or forgot to bring binoculars, is it says 1996 at the bottom of the page. If I was to read out what I've highlighted in red, it says that the sun.star packages are not part of the supported Java public interface. A program that directly calls any API in sun.star package is not guaranteed to work on all Java compatible platforms. So there has been a warning in the documentation for almost 20 years about not using sun.star APIs. In JDK 6, this was actually enforced by the compiler, so it actually emits a warning if it attempts to compile code that's actually using any internal APIs. But my guess is if I polled the audience, is a lot of people will not have seen this warning, or they will ignore the warning, which we're all guilty of doing. So just a couple of things about general compatibility policies before I get into some of the real slides is that at a high level, if an application is only using supported APIs and it works on a particular release, then it should work on the next release. And that's even without compiling it. If I have something on JDK, I've compiled it with JDK 7, it should run on JDK 8 without recompiling it, assuming it's using just the supported APIs. This has been the compatibility story for the most part of 20 years. And it means that a lot of people can actually preserve their existing investment because they know or they have some confidence that things will just work on the next release. The JDK tries, but does not promise and has never promised that it won't break applications that are using internal APIs. Incompatible changes in supported APIs tend to be confined to major releases. Sometimes with internal APIs, there is breakage across other releases. But typically people try, when they're working on the JDK, try to take into account the possibility that people are using those APIs. There is a policy that was established a couple of releases back to allow supported APIs be removed. This is not something that's actually being used all that often, and it's only something that happens with significant advance notice. For Java SE9, we are proposing to remove a small number of deprecated methods, and we'll see those later in the presentation. Just a couple of points about managing incompatibilities. So managing compatibilities is all about judging risk and impact, and a lot of the time we're trying to use real data when trying to judge where something is an incompatible change and what the impact is. There are many times where we have done static analysis on thousands or tens of thousands of projects in Maven Central, for example, to get some idea about API usage. So a lot of data is often used when trying to figure out whether to make a change or not. When there are incompatible changes, we try to communicate early and often. for some of the changes that we're talking about for JDK9, we've been actually talking about these now for almost 5 years. The things that we're going to be talking about that are proposed to be removed are things that we had planned to remove a long, long time ago. We deprecated them a long time ago in preparation for moving to modules and JDK9. When we do incompatible changes is that we try to make it easy to understand how tools and code will be affected. A couple of people put up their hands to say that they're testing out the early access builds. That is really the time to, during the development of a major release, to actually define these incompatibility issues early on. There are times when we may make a change, we may not realize what the impact is, but we get feedback and we get grumbling from people that are trying out the early access release to point things out that we may not have actually spotted. So having that kind of feedback with the early access builds is very, very useful. And often as well, when we're making changes, we have system properties, or we have other command line options to retain or restore the behavior of old releases. If you look at every major release of the JDK in the documentation, there's always system properties or other little knobs to be able to restore and retain old behavior. Finally, we write lengthy migration and release notes. I don't know how many people actually read them, but every single major release has an exhaustive list of release notes that document all the compatibility issues that we are aware of. Okay, at a high level, these are some of the incompatible changes in JDK9. The important one that I'm going to spend most of the time on is the first one, which is encapsulating most JDK internal APIs. I want to talk a little bit about the binary structure of the JDK and a couple of things that have been removed and a couple of other changes, and also the version change, which turns out to be quite a significant issue. So I'm going to start with a data point which is based on analysis that we did last year on the usages of JDK internal APIs. So this graph here is based on an analysis of about 100 different libraries, some popular open source libraries, and a couple of proprietary applications that we were able to get our hands on. So running some static analysis on this, we get some idea of which of the JDK internal APIs are actually being used. Now, the way this graph is structured, or sorry, shown is that the internal APIs are plotted on the x-axis, and the usage count is on the y-axis. So looking from the left, we can see that based on this static analysis, there's 125 usages of some internal API. And there's just over 100 usages of another internal API. And we can see that there's a big long tail here. This goes over on this corpus of code that was examined. There was over 700 different internal APIs that were used. So I don't know if anyone would like to guess what the most popular sun.star API that was used by this code base, or this group of libraries and applications that you haven't seen. Does anyone want to give a guess? I hear someone said unsafe. Well, that's quite a good guess. But for this, for this group of libraries and applications, it turns out to be Sun Misc base64 encoder was the most popular one used, and Sun Misc unsafe wasn't too far behind. If we were to go down to the third one, it was actually Sun Misc base64 decoder was the third most popular one used. One thing just to say about base64 is that we did finally, after almost 20 years, introduce a standard base64 API in Java C8, finally. So based on this is there's a categorization of internal APIs that was put together, and I'll go into in a few minutes to talk a little bit about how this is documented in JEP 260. What we can do when we look at all of these usages of internal APIs is we can essentially put them into two buckets. There's the non-critical APIs, which is really the APIs that are not really used by anything. There's no evidence that they're actually being used. Also in this bucket would be the internal APIs that are really just being used by convenience. Someone happened to find that there's a very useful sun.star API, so they make use of it. There's no real reason or critical reason for it. Then there are the critical APIs, Sun, Misc, Unsafe being the most obvious one. It's not possible to write your own Sun, Misc, Unsafe that is outside of the platform. And there's a small number of other critical internal APIs like this. So in JEP 260, sorry, JEP is JDK enhancement proposal. It's how features and other big changes and significant changes in OpenJDK are actually tracked. We have JEP 260, they're all numbered, I should say. It proposes, and this is what we have in our current JDK 9 builds, is to encapsulate all non-critical internal APIs by default. Remember, non-critical internal APIs are those are no evidence that they're being used, or they're just being used for convenience. We'll encapsulate all the critical internal APIs which have supported replacements in JDK 8 or Java SE 8. So if there's really a supported API and there's no reason to use this critical internal API, then there's no reason why it should be available for widespread use in 9. And then the final one is do not encapsulate the critical internal APIs like Sun, Misc, Unsafe, and I have the complete list from JEP 260 in the next slide. Instead, what we want to do is deprecate them and then plan to remove them once there is a supported API available for them. Anything using these APIs, we'll also have a workaround via the command line and other means, as you will see, to be able to still get at those APIs when you really need to. So JEP 260, as it stands at the moment, lists the following as critical internal APIs. Sun, Misc, Unsafe, which is critical to a lot of low-level access and high-performance libraries. We have the Signal API, which is related to signal handling. Reflection get caller class. Now, that is widely used by logging frameworks. There is a new stack walking API, which was done as part of JEP 259 for Java C9. And eventually, we would hope that the logging frameworks and other usages of this API would migrate there. Then there's Sun Reflection Factory, widely used by serialization frameworks because it provides some features that you need to be able to, for example, instantiate objects without running the constructor, things like that. So just back to the data that we had in this a couple of slides ago. So this is about 100 different products. And this actually puts colors on the internal APIs that are actually used here, so that you can see how it relates to the categorization in the last two slides. So when I look down through this and I realize the color, it's hard to maybe differentiate this, is those that are colored in orange, if you look at the second one down, Sun, Misc, Unsafe, that's the critical internal APIs. Purple, which is quite a few of them from the Sun, Misc, Base64, encoder and decoder near the top are the good examples. They are non-critical APIs. There's a supported API for them. There was never really any reason to make use of the JDK's internal version anyway. And green are non-critical and but supported in 9. That's a very small number of categories where when we looked at these internal API usage, we realized, oh, these ones should really have been supported APIs. So these OR, W3C, DOM, XPath, that was a case where we weren't doing the right thing in terms of providing aligning it with the W3C APIs. And then red is no replacement. Sorry, a lot of these are just there used for convenience. How do you find these usages? So just back to polling the audience a minute, is how many people here have heard of the JDEPS tool? Okay, maybe I see about maybe 10 hands here. The JDEPS tool is a tool that allows you to do a static analysis on your libraries and your applications to see what APIs are actually being used, what their dependencies are. That tool is in JDK 8. We put that tool in as part of preparing the platform to move to modules and strong encapsulation in the future. It's really, really useful with an option called, or the option is named -JDK internal. I have an example in the next slide. And that allows you to quickly see whether you have any direct dependencies on JDK internal APIs. You can quickly run this and point it at your jar files or your application, and it'll tell you if you're making use of any JDK internal APIs. I see Robert Schulte in the audience there. He's written Maven has a plugin that actually uses JDEPs, so you can actually incorporate it into your Maven projects, so that it can actually report, I think, and optionally fail if you're making use of JDK internal APIs. So this is very, very useful. So I'm going to show a couple of examples. I've taken for start one of the Glassfish jar files, just to show what the sample output is when you run JDEPs-JDK internals. What you're seeing here is a printout of a number of sun.security.something APIs that are being directly referenced by code in this security jar file. I think what's happened here is that there's an internal framework within the security library code that is being used here. What's happening is it's pointing out that Sun Enterprise, IOP security, something, has a direct reference to Sun security util object identifier. This is possibly an extreme case. This is possibly being used for convenient use, but it gives you an idea of what the JDK internal output produces. The other thing at the end is that JDEPs has a little mapping of old historical internal APIs to new supported internal APIs. In this case, if you read down at the bottom of the slide, it suggests changing your references to Sun Security X500 name to Java X Security Auth X500 principal, because that is a supported API. Anyway, the main thing is it's very, very quick, even with JDK 8, to be able to just run this tool and see whether you have any dependencies on internal APIs. So now that we know that this Glassfish jar file is making use of internal APIs, what happens if I were to run that code with JDK 9? We will see. It actually fails at runtime with an illegal access error. Ignore the detail of the error. It's essentially saying that some code in this Sun Enterprise security something is trying to access Sun security provider policy file in module Java base. Ignore that. We'll talk about Java base later on in the later talks. And then you see a stack trace. It's essentially telling you it's a warning. Maybe it's fatal with Glassfish here, that you're trying to make use of internal APIs. I said earlier on that you would have got a compilation error with from JDK 6 onwards if you try to make direct use of internal APIs. Now you've got the runtime enforcement, with this stronger enforcement at compile time too. This gives you an idea of the implications of strong encapsulation and encapsulation of the JDK internal APIs. Now let's look at another example. I'm using a slightly older version of Gradle for those that are tracking Gradle. And I try to run the compile Java task. I've highlighted in red that this is failing. Could not create an instance of ComSun tools JavaC API JavaC tool. That's not a huge amount of information there, but Gradle is actually quite good in that you can give it a stack trace option on the Gradle command to give you more information. So we're getting a failure here, and if we run with the stack trace option, we get a little bit more information. We get a stack trace. In this case, it's a legal access exception. If you know your errors and exceptions in the Java platform, you know that the static reference failing with an error equivalent with core reflection is an exception, because core reflection does the same access checks as the virtual machine. So here we have some core reflection usage in this older version of Gradle that's trying to make use of an unsupported API in the JavaC compiler. It's failing at runtime. So I realize when you see these for the first time is these scary exceptions just look scary, but you don't panic. I said earlier on about there is always going to be a workaround, and that workaround is we'll start with the command line version of it. So for going back to the Glassfish example, I can get the existing version of Glassfish to still run by giving it a bunch of command line options that tell it that I want to break encapsulation and really, really get at these APIs. So out of the box, I cannot compile, I can't run, and make use of these internal APIs, but I can still get existing code to work via this command line option. I'll explain the details of what this means in a few minutes. Now, I don't like to pick on things beginning with G, and in the case of Glassfish, there was actually an issue that's already tracking this issue, so that this old code that's using some of the security classes will, I assume, get fixed in time. So back to the option that I just showed a few minutes ago. The format of this option, so the name of the option is --add exports. So one of the other things, and you may see this in some of the other presentations today or this week, is we've started to add new command line options in JDK 9 that are GNU style, in quotes. So they're a bit more verbose than the Unix style and the sort of uniquely JDK style options that we've had in the past. So in this case, it's --add exports because, and all of the new options, by the way, are in this style. The value to this option has 3 parts to it: the source module, package, and then what the target module is. If you come along to the talks later today about modules, you'll show how we've migrated what was the monolithic platform into a nice graph of modules. The core module in the system is called JavaBase, and that's what I'm specifying here is the name of the module, then the package name of the internal API that is being used, and then who am I going to give access to. Ignore the detail of what all named is. If you attend the modularity talks that we're going to be doing today and tomorrow and Wednesday, then we'll explain a bit more about what this means. In fact, Alex's Under the Hood talk goes through a lot about what this notion of unnamed module. For now, just assume it means the class path. In other words, I'm exporting the Sun security provider package so that it can be used by code on the class path. That's the simple way to read this command line. We also, in our early access builds, have a way to do this via the main application manifest. So in the main application jar file, you can take responsibility for making use of these internal APIs by declaring in the manifest that exactly like we had in the command line option. So that's all I want to say for now about encapsulating internal APIs. I want to move on and try and get through some of the other things, other big changes in JDK 9. Right, so I want to talk about the binary structure of the JRE and the JDK. When I mean the binary structure, I essentially mean its layout on disk. The fact that we have a bin directory, rt.jar, tools.jar. These are things that you would have seen in the JDK and the JRE releases going back several years. We're finally getting around to looking at this layout on disk. So this is actually a disruptive change to tools. I'll talk a little bit about that in the next couple of slides. But we have many motivations for finally re-examining this layout on disk. When we move to a modular runtime, what's happening is that we're going to completely blur the historical distinction between the JRE and the JRE plus tools that we call the JDK. In Mark's keynote, you saw he created a little runtime that only had one module, or a small number of modules. This is another runtime. The existing or the long-standing runtime image layout does not lend itself to doing this kind of linking a whole bunch of modules together and producing your own runtime image. Other motivations are things like the zip format. We've been using the zip format as the basis for jar for a long, long time. It's not an efficient way to store the platform classes. We have had so many different startup and other performance issues related to jar files and rt.jar, especially as the platform has got bigger and bigger and bigger over the years. So it's finally, after 20 years, time to revisit this old format. There's lots of interesting things we can do around performance when we re-examine this. So all of these changes went into JDK 9 back in late 2014. It's a disruptive change for tools. It's a disruptive change for IDEs, compilers, and so on. As part of this, we've introduced a supported way for these tools to be able to access the contents of the image. So this is the first time we've had a supported way for tools to be able to access the class files and resources. So this is useful. So a lot of the tools have already migrated to making use of this, particularly in early access form. There's still some tools that haven't got there yet. Just looking at it, the old historical format, this is JDK 8. You can see there's essentially 2 levels of directory. At the top level, you've got the bin directory where you'll find tools like Java and Javac. Within it, you've got a runtime. And there's also a lib directory where you'll find tools.jar in there. Going down a level, you'll actually find another bin directory with copies of the same tools and a lib directory where you would have found rt.jar and a bunch of other jar files in there. There's other jar files. They all have history as to how they came into being. If you start digging into the lib directory, you will actually find a whole bunch of other interesting files that some of them are supported configuration, like for example the security policy file. There's other configuration files in there. You're not really supposed to change those because if you do, then the JDK won't start up or it'll misbehave and so on. We've never been clear as to what's the configuration that's intended to be edited versus configuration that shouldn't really be edited because it's going to break things. So the new format that we have in JDK 9, again, as I said, since late 2014, removes the one level of directory. It's very, very simple. You could just think of it as only 3 interesting directories in it. The bin directory, as before, where you'll find the Java launcher, Javac, RMID, all of the other interesting tools that you'll find in there. A conf directory, which is where all of the configuration that is intended to be edited is moved into this. This is where you'll find the security file. This is where you'll find the things like the properties to configure the management agent. All of these things that you want to be able to edit are in the one place. Everything else is in the lib directory in some format that possibly will change over time. In the case of the class files, and this is within the JDK, we've put them into a completely new optimized format that will change over time, but is very, very useful for the JDK in terms of startup and other performance things that we want to go and do. So that's all I'll say for now about the runtime image. This is primarily an implications for tools rather than most applications. I mentioned about removing some deprecated methods. So these are 6 supported Java.star methods that we're actually removing. You probably don't recognize these, or most people won't recognize them. These have been removed since the first build of JDK 9, and I'm not aware of any bug reports, which suggests that there's not too many people that are using these. These have been deprecated since 8, and they were flagged for removal. So as part of modularizing the platform, which we'll talk about in the next talk a little bit, is these are the 6 that were most problematic and had to be removed in order actually to get to the nice module graph that we'll show in the next talk. There's some extension mechanisms that have been removed. The standards override mechanism, hardly ever used, originally intended for app servers that are replacing and upgrading some of the components in the JDK. And the extension mechanism, again, this hasn't been widely used. It was very much a misfeature, but essentially it was a way that you could actually dump jar files into the runtime image and have them being visible at compile and runtime. So these are not too interesting. The next one might be kind of interesting. So I want to show you a jar file on the class path in jsr305.jar. Assume this jar file has a couple of annotations in there in the package javax.annotation. I guess anyone that, and most people may even recognize these, not nullable, often used for defect detection in applications. These annotations are in the same package as the so-called common annotations, the JSR 250, yes, defined annotations. So now what you have is, by putting this JSR 305 on the class path, I've got some annotations in JavaX annotation that are part of this other one API, and they're loaded at runtime by what's called the platform, or in the past, the extension class loader. And then I've got these other non-nullable, nullable, and so on the class path that are loaded by the application class loader. This is a little bit strange. What I've got here is a split package problem. I've got some classes are part of the platform, some are on the class path. This is just one of a couple of APIs that are highly problematic. The transaction API is another one. JavaSC defines a small subset of the transaction API. The reason it does that is part of supporting transactions with Corba. JavaE defines the full transaction API. Another potential split package problem. Things really go downhill when you start looking at Corba. The Corba vendors, the app servers, typically will upgrade and overlay a bunch of support for additional OMG standards. So what has been proposed and what has been in JDK 9 for some time is that the modules that are shared with Java EE, and by the way, everything here, all of these problematic packages, they're all things that are typically upgraded by Java EE. They are not resolved by default. Now, we haven't talked about modules and resolution or anything. For now, just when I say these modules are not resolved, just assume that the types in the transaction API, in any of these other 6 that I've listed here, they're not visible by default. It will appear as if those types do not exist. You will get a no class def found error if you try to run code that makes use of them. We have documented in JEP 260 a write-up as to the rationale for this. I'll read it out. Number 1, to avoid unnecessary conflicts with popular libraries that define types in some of the same package like we saw in the previous slides. And number 2, to make it easier for existing application servers to migrate to JDK 9. Application servers often override the content of one or more of these modules, and in the near term, they most likely do so by continuing to place the necessary non-modular jars on the class path. So this is, if you're using any of these, and there's 6 of them here, and you don't know the module names because we haven't showed them yet, but we will in the other talks, is we have organized these modules that are overlapping with Java EE into 6 modules: Java Corba, Java Transaction, Java Annotations Common, Java Activation, Java XML WS for the web services, and Java XML Bind for the binding APIs. Again, we don't panic here because we're always thinking through what options you have to keep the existing world going. It's very simple on the command line. If I'm using Corba, I can continue. It'll continue to work exactly as it did in JDK 9 by just using this option called add module. Add modules. Alex just pointed out that I have a typo here. This should be plural modules. So add modules Java Corba. What that does is it essentially adds that module to the set of modules that should be resolved at startup. Existing code that uses Corba will continue to work with this option. For the app servers, not really the most applications, it's possible to deploy an upgraded version of Corba as a module. And you just use this upgrade module path. This is like the module equivalent of the endorse override mechanism that I mentioned earlier on. Mostly only interesting to the app servers. It's also possible because these modules are not resolved by default, I can actually just throw this on the class path. There's no split package issues. So there's a couple of possible workarounds for this this type of issue if you're making direct use of these APIs. One final thing just to say on this is this policy of not resolving the EE modules by default is very much something that we're dependent on feedback on. So we need to see over the next couple of months whether this type of a change is disruptive or not. Maybe this set of modules should be adjusted. We will actually see. This has been in JDK 9 for quite some time. There's been very, very little feedback on it, but it's possible that not too many people making use of these APIs are trying things out. Okay, a couple of other things that are interested in changes in JDK 9. I'm not going to spend time on them today. Is the application, the extension class loader, which is renamed the platform class loader, are no longer instances of URL class loader. We've had a couple of cases where there's existing libraries or code have been making the assumption that the application class loader is an instance of this type and blindly casts to that type And then, of course, because this is completely changed in JDK 9, they get a class cast exception. More details are written up in JEP 261 on that. There's a couple of options have been removed, like the ability to override or prepend to the boot class path. The reason is the boot class path, as we know it, really doesn't exist in JDK 9, and it's all part of moving to modules. And system properties associated with that have been removed as well. I want to quickly go through a couple of other things. The version string JEP 223. Surprisingly, this is probably the most disruptive change that we have had in JDK 9 so far. The JDK 9 versioning scheme has historically been confusing. If I read from the JEP, this is again, the JEP in its motivations has a little write-up. Which release contains all of the most recent security fixes? Is it JDK 7 update 55 or JDK 7 update 60? It looks like JDK 7 update 60 is 5 releases later than update 55. So therefore, it must include more security fixes. That conclusion is incorrect. These 2 releases contain exactly the same security fixes. Security releases based on the previous minor version are odd numbers incremented by 5 or by 6 if necessary in order to keep the update number odd. Always been confusing. This is the proposed new version string format. You'll find all the details in JEP 223. The simple way to summarize this slide is, after 20 years, we're finally dropping the leading one. Now, changing the version scheme has an impact on system properties. And this is where it's been quite a disruptive change. There's a lot of code out there that reads the Javadoc version property and parses it. So there's one thing just to keep in mind if you have any code that is dependent on the versions. What I haven't gone through in this slide is there's a new API for Java SE9. It's called runtime.version. You can actually call runtime.version and it returns you a version object that allows you to introspect the major, minor, and other things about the version number. Very, very useful. So I've been talking about disruptive things. I just want to spend a few minutes on things, on 2 features that I think are interesting when you start looking at migration from 8 to 9. And these are described in JEP 238 and 247. 238 is multi-release jars. 248 is compile for older platform versions. So consider this scenario. I'm making use of internal APIs, but there's a supported API available in Java SE9. So maybe you're making use of var handles, so you don't have to make use of some of the lower level APIs. Maybe making use of the old internal XML APIs for serializer or catalog, and there's a new catalog API in 9. My application, well, I really want it to work on 8. I need to build it on 8 and then run on 8 or 9. So this is a common scenario, particularly when we're talking about 2016 and JDK 9 isn't going to be released until 2017. So I need to be able to do this kind of scenario. So one feature in JDK 9 is multi-release jars. The jar format has been extended to allow multiple Java release specific class files to coexist in the same archive. I'm not going to spend a huge amount of time on it today, but it's something to look up and is a very, very useful feature. So if a multi-release jar file has in its manifest an attribute named multi-release that has a value true, so it's a Boolean. It then has a section, meta-inf version / the version number, in this case 9, and the classes and the resources in that section can override what's in the top level or base section. So if we were to study this example, we can see that there are two helper.classes in this jar file. In the top section, we've got com-acme-stats internal helper.class, and down in the meta-infs versions 9, there's also another com-acme-stats internal helper.class. When you run on 9, the bottom one will be used. When you run on 8, the one in the top level or base section will be used. So in this example, I'll run it just as the main application jar for the moment. When I run it on 8, we can see that com-acme-stats internal helper loaded from the top section or base section. On 9, it's loaded from the meta-inf versions. This is very, very useful when you're trying to do this migration from internal APIs to supported APIs. Immediately when you start thinking about, oh, now I've got to have a JDK8 and a JDK9 in my build environment in order to do this, I want to make you aware of one other feature in JDK9, which is the ability for the compiler to target old releases. We've always been able to do javac-source.target 7 or 8, and then give it the boot class path. Okay, that means I have to have another JDK on my system. If I'm on 8, I want to target 7. Then I've got a JDK8 for building. I'm targeting 7 in order to be ensured that the compilation is consistent. I can do that all now at one step in JDK9. I can do javac --release, whatever my target release is. And it's equivalent to -source-target-boot class path with only having one JDK on the system. So this is really, really nice. With JDK9 in my build environment, I can compile to 6, 7, 8, or 9 without having multiple JDKs on my system. So that combined with multi-release jars provides a great way for actually moving away from internal APIs and building applications that run on different versions of the platform. I believe there's a talk tomorrow on Maven too that will touch on some of the support for these features. So I need to start wrapping up. So a couple of things to start thinking about for JDK9. The most important thing that I've shown in this slide deck today is the JDEPS tool. Very few people put up their hands when I polled the audience earlier on. So there's not a huge awareness of this tool to do a static analysis on your libraries and applications. It's a really, really good tool to quickly identify whether you're using any JDK internal APIs. So that's one thing to be aware of. The version change, as I said, has been highly disruptive. Now, a lot of open source code has been catching up over the last 6 to 9 months. I have no doubt there's a huge amount of other code out there in applications that's parsing the value of Javadoc version and isn't going to get the right answer with 9. So that's something to check out. Primarily for tools, but maybe you've got this already, is that we've had a lot of code that has assumed there's an rt.jar. It starts looking for jar files in the JDK's lib directory or JRE lib directory because it needs to find class files. This is all changed, as I said, because there's a new layout in JDK9. Other things to be aware of is and some people did put up their hands at the beginning, is there are weekly JDK9 early access builds. And we're working on modules. We also do a Jigsaw early access builds on a regular basis as well. There's always early access builds to download and try out. I've pointed out a couple of the things that help with the migration, the multi-release jars and compiling to old versions. That's also worth checking out. More information. So we're working on the module system and the modular JDK for JDK9. This is all being done in OpenJDK under Project Jigsaw. There's the links to the project page and the mailing list. Early access builds for JDK9, early access downloads is there. The JDEPS tool has its own wiki page that Mandy Chung has been maintaining. That is a useful page to be able to see a quick list of internal APIs versus supported APIs that would be better APIs to use. I've also included some links to the JEPs that I talked about towards the end of this session. I'll come back to this slide in a few minutes, but just to advertise the other sessions that we're actually doing here. I said this is the first of 5 sessions that we're doing, Alex and I are back in, I'm back here at 2:30 about introduction to modules. The two of us are back here later in the afternoon to do advanced. Alex then has the services and Project Jigsaw under the hood tomorrow. And then we have repeats. 4 of the sessions are actually repeated. We also have a hack session on Wednesday, first thing in the morning. And I think they're all mostly in this room or next door. So back to the links, and I think we're done. We've only got a few minutes for questions, but if you want to ask some questions, please go ahead. We may have to take some of the questions outside after if we run out of time. You'll have to shout.
I've heard it's with the improving some of those internal ones, there's I heard that programs like Keto and so forth will have problems. Will that come now or later that with using some internal APIs?
Okay, I didn't quite catch all of the question, but I think what you said is that there's some libraries are having problems with 9 because they're using internal APIs. Okay, so all I can say is until they migrate away from those APIs, we have some ways to mitigate it via the command line options that I showed. That's really our solution for that at the moment.
Does multi-release jars imply multiple source files as well? Or do you have some provision for interweaving different language features in source files?
Right, so the question is with multi-release jars, does it imply multiple source trees, I think? I think that's a really good question. So the multi-release jar feature doesn't prescribe a source layout for that, but you would have to have some way to be able to support that. Sorry, Robert, is this something you're going to talk a bit about? Okay, you're sitting actually beside Robert Schulte, who's leads Maven. He will be giving a talk tomorrow, and I think we'll cover this.
Everyone is prepared.
It's great. Okay. Okay, thank you. Good afternoon. Welcome to this session on Introduction to Modular Development. I'm Alan Bateman, working on the JDK. This is number 2 of 5 sessions that we're doing at JavaOne this year on modules and JDK 9. We did the first one just before lunch on Prepare for JDK 9. That's repeated tomorrow. Other talks here are repeated as well. I'll show a slide at the end with reminders. Just a little bit about some of the background on what we call the modularity landscape, so that you have some idea what's going on for Java C9. So the module system itself is being developed through the Java community process through JSR 376, and this is targeted for Java C9. Mark Reinhold, sitting at the table here, leads this JSR. Java C9 itself has its own umbrella JSR, that will own the overall contents of the Java C9 release. It will also own the modularization of the platform. So for the first part of this talk, I just want to spend a few minutes and talk about what it means to be on a modular platform. So this module graph that I'll show you is essentially something that Java C9 will have to standardize. Within OpenJDK, we're working on the implementation in Project Jigsaw. That will be the reference implementation of the module system. There's a number of JEPs, or Java enhancement proposals. They're all numbered. If you Google for them, you'll find them all. That document all of the detailed implementation choices and command line flags and everything else related to the implementation. You'll find it all listed and documented in these JEPs and updated as we go along. The important thing to understand is that JDK 9 is not completed yet. It's not intended to ship until 2017. There's quite a few things that are undergoing design discussions, so there will be changes before it ships, no doubt. So bear in mind that as we go through some of the examples and in this presentation. I've split this into 2 parts. I'll really introduce modules in the second part, but I want to start by talking about and saying that modular development starts with a modular platform. So I'm going to talk about what it means to be running on a modular platform. This graph, in quotes, is where we were with the JDK back in the sort of JDK 7 timeframe. This looks pretty horrible. There's not a lot to say about it. This is where we were a couple of years ago before we put in the effort to actually break up the JDK into a set of cohesive modules. And a lot of progress has been made on that. The only thing to point out on this horrible slide with cycles and all sorts of weird dependencies is even back then, in the early days of modularizing the JDK, we did identify that there had to be some core module. We called it base at the time. It's now called Java base in the current module graph. And this is the graph that we have now for the standard modules, or the Java SE modules. These are the modules that are named with a name starting with java.something. Right down the bottom, you'll see java.base. That is the core of the system. That is where java.lang.object lives. There's a couple of things to say about this graph is when you study it for a few minutes, is you will see that for the most part, there is only one technology in each of the modules. There's a couple of areas that aren't completely clean, but for the most part, one technology per module. The graph is extremely hierarchical. That's partly because we've got aggregator modules for profiles in there, but it's also hierarchical because we've been able to do a clean separation of headful and headless. You can actually take a subset of these modules and have a completely headless system. Another important thing about this graph is there are no cycles. This is important when you get to some of the later presentations on the module system and Alex's talk tomorrow on Under the Hood. You'll get to hear more about this. I've only shown you here the modules that are the standard module graph, or, as in the java.star modules. There's also a set of modules that are JDK specific. Their names are start with jdk.something. I'm not showing them here just to keep the graph readable. Now let's take a JDK9 build. This is last week's promoted build. So every week there's an early access build of JDK9. This build is build 136. So I'm just doing Javadoc version on it just to show that it's real. That didn't come out right, did it? I just do Javadoc jar to run an existing application. I randomly picked the JEditor text editor. It's a text editor that has been written in the Java language. It's been around for a long time. I have absolutely no idea whether the maintainers of JEdit have tried out JDK9 builds or not. I tried it out, and it just works as it did in JDK8. Now, there's a few issues on some platforms, but it just works, at least on the Mac, without any issues. The important point to take from this is that an application, and maybe it's using a bunch of libraries, if it's using supported APIs, it should just work exactly as it did in JDK8. There are a few issues, and they're covered in the Prepare for JDK9 talk that when I talked just before lunchtime. So here I am. This looks, for the most part now, it looks just like a regular JDK. But let's look a little bit further. I'm calling a new command line option here, --list--modules. What this option does, java-list modules, is it lists down the modules that are in the runtime image. I showed a graph a few minutes ago. I've repeated it here on the right side of the slide. And what you're getting here is just a list of all of the modules that are in the runtime image. And that's just to show that the system is actually made up of these modules. I can go further, and I can give to list modules a module name, and it'll give me more information to describe those modules. I mentioned Java Base a minute ago. It's the core of the system. So if you can read this at then it says at the top java-list modules space java.base. So I'm asking the runtime to list the java.base module. And what you see here is a bunch of exports. And these are expressed in terms of package names. The core module exports JavaLang, JavaIO, JavaNet, and all these other core packages of the system. That's what Java Base does. It clearly defines these are the supported packages, and the APIs and the types are in those packages that you can use with Java Base. I'm taking another module here, the Java Desktop module. The Java Desktop module is the module where we have grouped all the headful APIs, the graphical user interface, not JavaFX, more the traditional AWT and Swing APIs. So when you look at the list of exports for Java Desktop, you see Java AWT, all the other, there's a whole bunch of other sub-packages in the AWT or Java AWT namespace. You'll also see JavaX Swing and a bunch of other UI ones. So it's got exports exactly as Java Base has, just different set of packages. Right down the bottom is the requires. Each of the modules in the runtime describes what its dependencies are. The Java Desktop module requires Java Base. Everything requires Java Base. We'll see this as we go through the presentation. It requires Java XML. There are some of the APIs and for persisting beans and things that are based on XML. There's a Java prefs because there's part of the APIs can store preferences. And there's a data transfer API. That's the one that exports the AWT data transfer API. So the important thing is I could go through every one of the modules in this graph, and I could specify them to list modules, and I could see exactly what APIs do they export and what other modules do they depend on. Another little thing as part of this introduction, I just want to mention the Java linker. Mark showed this in the keynote. where he used the Java linker to create a small runtime that only had the Java base module. I think it was a 64-bit image, and I think it was compressed down to 17 megabytes. So what the Java linker is a tool that links a set of modules and creates a runtime image. In the earlier talk today, I talked about the modules completely blur the historical distinction between what we know as the JRE and the JDK. The JRE was just the runtime in the past. The JDK was the runtime plus tools in the past. Now that everything is broken into modules, you can combine them in different ways. You can even link your own modules in, and I'll show this later in the presentation, to create your own runtime image that you can actually distribute. That runtime image has a bin directory where you'll find tools like the Java launcher. It has a conf directory which has the configuration. This is user-editable configuration. And then there's other parts of the runtime image that are not intended to be edited. So let's run the linker command just if you didn't see this in the keynote, just to show what actually happens. So in this JLink command, and JLink is the name of the linker, I give it a module path, which is, just think of it as the directories on the file system where it will find the modules. I'm telling it to add the module named Java.desktop. I showed that module in a slide a couple of minutes ago, and I'm going to generate it into a directory called myimage. And then, once that churns for a couple of seconds, I'm then going to type java.list modules on that generated runtime image. And I see in there that it produced a runtime image with only 5 modules. If you remember a few minutes ago, I showed the Java desktop module, and at the end it had this requires Java base, required XML, required data transfer, and so on. These are the modules that have been linked together to produce this runtime image. Now we'll go back to our little JEdit example that I used in one of the first slides. I'm going to use java-jar JEdit, and I'm going to run the JEditor with this small runtime that I've produced. So I've only got platform modules in this runtime image that I've created, and I can use this to run my existing application. So that is a huge step forward for distribution, because you can distribute a small runtime with your application. So that's a quick summary of part one, which is we've moved from this huge big monolith, that horrible big, lots of dependencies and cycles in the graph. We've moved to a set of mostly cohesive modules. Each of the modules has a clear set of exports. We saw 2 examples, and dependencies. If you stay on the class path forever until you retire, you will still be using modules whether you know it or not, because the platform itself is modular. And I've quickly just shown you the JLink tool to create your own runtime image with a small subset of the platform modules. So the tagline from this is modular development starts with a modular platform. That's part one out of the way. I now want to start right back at the beginning and introduce what modules are, particularly how you would actually go and write a module yourself. We'll start with the concepts and start building up and writing our own modules. So this is a very gentle introduction to modules, assuming that you've never seen them before. So starting with the basics, every module has a name. In the previous slides, you saw Java Base, you saw Java Desktop, you saw a couple of more Java.star modules. In this example, my module that I'm going to start with is called stats.core. Assume that it's a statistics library that I'm going to be making into a module. The code in a module is organized by packages. In this example, assume my module has 2 packages, com acme stats core clustering and com acme stats core regression. These are the packages that my code is organized in this module. I've just listed out 2 sample type names there to give you an idea of types that might be in this module. In addition to Java code, my module may have resources, it may have native code, it may have configuration, it may have commands. We're not going to get into all of this in the introduction, but your module may have those as well. The module's self-description is expressed in a source file called module-info.java. That is the module declaration. By convention, this source file is placed in the root directory of your source code for the module. So it's like being right up at the top. The syntax for a module declaration is module, space, and then the module name, and then we'll open curly brackets, close curly brackets. We'll flesh this out over the next couple of slides. We will assume that our stats core module has a dependency on Guava. For this presentation, assume Guava is a module. I express that dependency with a requires clause. So in my module declaration, it says requires Guava. If I start building up a module graph on the right side of the slide as we go along, we see a dependency on Guava, the module. We'll add in a second dependency. We'll assume that it depends on the JavaSQL module. So this is a platform module. If you looked at the module graph I showed earlier on, JavaSQL was actually in there. We went through it quickly. We didn't look at all of the modules. Assume that the JavaSQL module is the module that exports the JavaSQL API, or the JDBC API as it's sometimes known. Now we start to build up a module graph here. We've got our three modules. We've got our stats core. We've got our Guava. I'm going to add one more module to the module graph. Assume that we have a stats CLI module, command line interface. Assume it's some kind of command line tool that makes use of the stats core module. And we assume, sorry, I may have introduced that in the last slide. This is the module that has the dependency on Java SQL. So we've got a number of modules. Stats CLI depends on stats core and Java SQL. Stats core depends on Guava. Every module depends on Java base, whether they declare it in their module declaration or not, because everything ultimately is a Java-lang object. Now let's start fleshing this out a little bit more, and we start looking at the Java SQL module. If I were to do a list modules Java SQL, I would actually see that it depends on Java XML and it depends on Java logging. The dependency on Java XML might be a surprise, but if you look closely in the Java SQL package, you'll actually find there is it supports storing XML in databases, so therefore it depends on the XML API. When one module depends on another module, then we say that that module reads the second module. So this is important, is the stats core module depends on Guava. We say the stats core reads Guava. Stats CLI depends on stats core. We say that stats CLI reads stats core. This readability relationship, which we'll build up over the next couple of slides, is actually the basis for reliable configuration that Mark mentioned in the keynote. So now let's take a little subset of the module graph, and we'll just look at stats CLI depends on Java SQL, which ultimately depends on Java logging. We'll add a little bit of code to this so you can get an idea as to what code might be in those modules. It may be that, well, let's see. So let's start with Java SQL first. So it exports the Java SQL package. There's a type in that package called driver. Anyone that's used JDBC probably has heard of Java SQL driver. There's a method in there. It's a public method, public class, that returns a logger instance. It's called getParentLogger. Let's suppose up in stats CLI, we've got some code that creates a Java SQL driver and then invokes its getParentLogger and then a log method. So you've got some method invocation chaining actually going on here. So how is this actually going to work? Stats CLI only depends on Java SQL, therefore it only reads Java SQL. what's happening with these types in the logging module that stats CLI doesn't know anything about. There's nothing in the code that immediately tells you that it's using the logging module. Now, one way we could do this is we could change stats CLI's module declaration to have a dependency, direct dependency on Java logging. That will work, but it would be a little bit disappointing. As a user of JavaSQL, I do not know about as a user of JavaSQL, I don't know anything about what its dependencies might be. So the module system helps with this by introducing a modifier called transitive. So in the JDK9 public builds, this is actually called public. In the early access builds for Jigsaw, it's called transitive. I mentioned earlier on about JDK9 not being final, but this is what the current proposal is and what's in the Jigsaw early access builds. So in the JavaSQL module, its module declaration says requires transitive Java logging. What this means is that anyone that depends on JavaSQL will read Java logging. So we'll build up now in a few seconds the readability graph. I'm stats CLI, I require JavaSQL, therefore I read JavaSQL. JavaSQL does a requires transitive on Java logging, therefore stats CLI reads Java logging. In Alex's Under the Hood talk tomorrow, he will go through a lot more on this. But this is what the readability graph is. So I started the black edges in the graph, just think of it as a dependency graph. When I start adding the orange edges, I've built up here a readability graph that takes into consideration the requires transitive or implies readability as we call it. Okay, so that's readability. The next thing I want to look at is exports and then combine things together to show how this supports accessibility. So in addition to a module having a requires clauses, it can also have exports clauses. We saw that with Java Base, we saw that with Java Desktop. Our module stats core will export two packages. Let's suppose it exports the clustering and the regression package that I showed in one of the first slides. Let's suppose there is also an internal package. It's not part of the stats core's API. That package is acme stats core internal. Essentially what we've done is we've divided the types and the packages in this library into two. Those that are part of its public API and those that are internal. Nothing outside of that module is intended to make direct use of them. The little X there over the acme stats core internal makes it just as a visual indication on this slide to say none of the types in that package are accessible outside of the module. Now let's combine it with readability that we saw a few minutes ago. Stats CLI reads stat core. Remember, it does a require, so therefore it reads it. If stats CLI reads stats core, then it can access any of the public types in the packages exported by stats core. It cannot access any types in the internal packages because they're not exported. So this is a two-way street. I read the module, and the other module exports some packages, and that allows me to access the public types in those packages. If stats CLI does not read stats core, nothing in that module is accessible. None of the public types, not even in the exported packages, are accessible. So this is important to get. If it reads it, the public types in the exported packages are accessible. If it doesn't read it, they're not accessible. So the big take from this design is that public no longer implies accessible. This is a significant change to the platform. but it's because we're retrofitting modules to a mature platform, and this is how we do it with minimum disruption. Okay, they're the basic concepts. I now want to go through some of the commands. I'll take questions at the end as to how we're actually going to compile modules, how we're going to package them, how we're going to run them. I want to go through some of the commands to do all of these things. We'll start with our stats core module, and we are going to compile it. So I've got a bunch of source code that's organized in a directory called src stats core. The important thing from this directory structure to understand is I've put the module name into the file path. At the top level directory of the module source code, I've got the module declaration. And also under stats core, I've got all the other classes that are for all the types that are in this module. When I compile it, I get a class file for every one of the Java files. It's the familiar thing that we see where the output directory reflects the same structure and the same class files as you see in the source directory, ignoring additional classes that might get generated for inner classes and so on. The javac command that I'm using here has a couple of options that you may not have seen before. The first is the -- module path. This is the option to the compiler to tell it where to find dependencies. Remember, our stats core depends on Guava. Where's it going to find the Guava module? It's going to find it on the module path. So for the examples as we build up here, assume that we have a directory of modules and the directory is named mlib, and we'll work through all of these as we go along. So I'm just running one javac command, and I'm compiling all of the source code for this module into an output directory. So a couple of things just to say about module path is that when I'm resolving dependencies, I'm going to find these dependencies on the module path. The module path is not equal to the class path. It doesn't suffer all of the problems that the class path has. There's no splitting of packages. There's a whole bunch of issues that the class path had. We've learned from all of those and have come up with a much more reliable mechanism, which is the module path. So when you're finding modules, you search down the module path as before, and they can be packaged in different form. They can be exploded. If there's two modules in the same directory, then the module system will give up. It's not making a choice as to which module you're looking for. You have to fix those kind of issues. So this is actually very simple. We can go through some of this in the hack session on Wednesday. I'll give a link to that later on to show how the module path is and how it works. The important thing is to understand is that's where modules are found, and it doesn't suffer the same problems as the class path. So now we'll go and compile another module. This time we'll compile stats CLI. So we've already compiled the stats core module. That's compiled into the mods directory. We're now going to compile the stats CLI. Stats CLI requires stats core. We're giving a module path, this time with two directories, because this time we want to be able to find the stats core that we've compiled into the mods directory. As before, you've gone from a tree of Java files, and you've generated with the compiler a tree of class files. So the module info gets compiled as before from source into its binary form, which is moduleinfo.class. Now we've compiled our two modules, stats core and stats CLI. Let's run the stats CLI code as a module. So this is our command to run it. Now, the first thing is I've pulled a trick here. We've got a short form of module path, which is -p. So rather than having a big long command line option, I've replaced --module-path with -p, because that is the short form. What you'll find in JDK9 is a lot of the new options have a long form and a short form. I've switched to the short form in this slide. I'm also using another short option, -m. I'm telling it what the main module is. This will initially look a little bit verbose. We'll shorten this as we move through the next few slides. -m tells the runtime what the initial module is and what the main class is. So there's two portions to this. Where will it find the stats CLI module? it'll find it on the module path. It'll load that module, and it'll locate the entry point here, which is com acme stat CLI main. So we're actually executing code in the module with this command, and that little prompt, welcome to stat CLI, we'll just assume that's what this tool runs when you start it. Now let's see what's actually going on here. So when I typed that command, what actually went on? So remember, this is our dependency graph from a few minutes ago. Stats CLI depends on stats core. It also depends on stats SQL. As I said earlier, every module depends on Java base, so therefore you have an edge from stats CLI to Java base. Here's the full, when I compute the transitive closure, this is the full dependency graph. As before, this actually happens at startup when you typed java-m, because what happens is when it attempted to resolve the stats CLI module, it's like, oh, that depends on stats core, therefore I've got to resolve that module, that depends on Guava, and so on. So what you've actually computed at startup, when I typed java-m, is I've actually computed the transitive closure. In fact, it's actually gone further. It's actually computed the readability graph. Remember the readability graph, I've added these additional edges because of the required transitive. So at startup, when I did java-m, the runtime has produced this runtime graph and resolved all of those modules to ensure that they can all be located on the module path or in the runtime image. So this is actually what happens at startup. So I can't actually start up if something is missing. If I attempted to start up with Guava missing, then I would get an error at startup. If you want to see more as to what happens at startup, there's a diagnostic option on the Java launcher which will print a little trace. We're going to have to work on the trace a bit better in JDK9, but this is a subset of what you would actually see when you attempted that command that I did in the previous slide. So you get trace information as it locates modules, where does it locate them, why as well. Right, so everything so far I've compiled and I've run. But when I compile things, everything's exploded on the file system. If I looked in the mods directory, I see stats core and I see lots of class files. That's a very inconvenient way to distribute an application or a library as just a bunch of class files. I want to package it up into a jar file. And we have this notion of a modular jar. A modular jar is just a regular jar file, but it has a modulinfo.class file in the top directory, the top level directory. And that allows it to be used in other ways. I'll talk about that in a few minutes. But if you see a jar file that has a modulinfo.class in the top level directory, it is a modular jar file. So what I'm going to do on this is I'm using some of the newer options with the jar tool to create a modular jar from what I compiled previously. So stats, I'm using this one to package up stats CLI. The modular jar I'm going to create is I'm going to create it into the mlib directory, and I'm going to name the jar file statscli.jar. As part of packaging up stats CLI, I'm going to specify what the main class is. If you're used to producing an application jar, then you're probably familiar with the main class attribute. This is sort of the equivalent for modules, and I can configure this with the main class option to the jar tool. So what this does is, this is all of the class files that are in the mods, stats CLI. I'm going to package them all up, create one jar file, stats CLI, and that's on the right. The jar tool has a whole bunch of new options in JDK9. I'm going to just show you one of them here. If you find a jar file, you can actually you can give the name of the jar file for our file path to the jar tool, and give it the option print module descriptor. What that does is it'll describe the module that's in that jar file. In this case, it's our stats CLI module. We can see what does it depend on, and the stats CLI has no exports. It's a tool. It's got no exports, and it has a main class. So the jar tool is able to print that out. So that's useful when you get a bunch of jar files. You want to figure out what modules are in them. Okay, now we've got our our stats CLI has been packaged up. It's in the mlib directory. I'm now starting to shrink down my Java command a little bit by just giving it the name of the initial module. A few minutes ago, I specified to -m 2 values, the name of the main module and the main class. Now that I've packaged up the module, the module now knows what its main class is. I don't need to specify that anymore, so my command shrinks down. I can just tell it what the main module is, -m stats.cli, and it will load the main class from that module, and everything will get resolved as before. Okay, I've talked a little bit about the module path, and we're used to the class path. One thing to be aware of is you can mix them. It is possible to start or to compile or to run with some code already as modules and some of the code on the class path. You can combine them together. Now, the code in the modules, of course, can't depend on anything that's on the class path, but what you might want to do, particularly for migration, is run code on the class path, but you're making use of libraries that have already been migrated to modules. So this is where it comes about, where you will want to combine the module path and the class path together. So the orange little box here is stats GUI. Assume that's a graphical tool that makes use of the stats core API that I'm using. The maintainer of that has not got around to migrating that code yet to a module. He wants to keep it on the class path for now because it hasn't got around to this yet. All of the other libraries that are used in this system are already modules. Stats core has been migrated by us in this session. It makes use of Guava. We've been assuming that's already been migrated before the session starts. And we have a couple of platform modules. So how am I going to run these two together? And here's a sample command. So I'm using -p, short form again of the module path. I'm giving it the mlib directory where we've got all of our modules in there. We've got our Guava, we've got our stats core, we've got our other modules in there. And I'm using -jar, stats GUI.jar. So this is where the main class for the stats UI application is. There is nothing in stats GUI.jar to say that it depends on the module stats core. This is just a jar file. It has no dependency information. I have to tell the system, and that's what this add modules option is here. This application I'm going to run is making use of a module stats core. So by combining these two together, my main class is on the class path, no dependency information. I have to tell the system that I need the stats core module to be resolved. So that is the reason for the add modules stats core. If stats GUI was migrated to a module, then its dependency information means that the system would know to be able to resolve stats core, but there's nothing when I keep that code on the command line. Now let's get back to linking. So ignore the stats GUI library for now. I'm going to start producing a runtime image that has the stats CLI module. So this is a module that we have compiled, packaged, and now I want to go and create a runtime image for distribution. I could just distribute it as a modular jar, but assume that I want to be able to distribute a complete runtime that doesn't have a dependency. I don't want to have to ship a separate JDK. I just want to be able to produce one distribution with the JLink command. So I run the JLink command. I give it the module path, and that tells it where to find the modules. There's two locations I'm giving to the module path. One is where do you find the platform modules. They actually are in the JDK download. Where do I find the other modules? That's the mlib directory. I'm giving an add modules to tell it which modules to include in the runtime image. I want to include stats CLI, and then I give it an output directory, which is the location of the runtime image that I want to create. That churns for a couple of seconds, and I get a runtime image that has 1, 2, 4, 7 modules in it. At the beginning of the presentation, I used JLink to create a runtime image with only platform modules. Now I'm using the JLink tool to create a runtime image that is a mix of platform modules and a number of my own modules that I have written here. So when I run java-list modules, I see the names, I see the Java base, logging, SQL, XML. If you remember the dependency graph that I had earlier on, these are those platform modules you see there. Plus I then see my own modules, stats CLI and stats core. So that's a sample JLink command. In the advanced talk later on today, we'll actually have a couple of examples that have more complicated and interesting JLink commands, and we can talk about it on Wednesday at Hack Session if anyone wants to come up and talk about that. So that's it. So in this section, we've got I've talked through the basic concepts. A module has a name. It expresses its dependencies. It may have some exports. You've seen how we've turned a dependency graph into a readability graph. So you've seen the notion of implied readability or requires transitive. And hope in this quick introduction, you've seen some of the tooling and the updates to the javac command, the jar command, the Java launcher to be able to give it the location of modules, and so you can see how to compile, package, and run with modules. And that's it. So I said at the beginning that we have five sessions. So prepare for JDK 9 is something we did just before lunch. We're repeating that tomorrow. The advanced modularity talk, Alex and I are doing that, I think, in this room later on today at 5:30. And Alex is doing the services and the under the hood talks tomorrow. And we've got a hack session on Wednesday at 8:30 if you want to bring along your laptop and try things out, or just come along with questions. So for more information, as I said at the beginning, we're working on the implementation of this in Project Jigsaw. This is the link to the project page, the mailing list, and where we have the early access downloads. So if people have questions, then please come up. Mark Reinhold is at the table here, and I would hope will help answer questions. I actually have to shout. Okay.
Hello. Yes?
Okay. I'm curious about how JDK 9's modular approach compares to OSGI. What would be the advantages over using JDK's modular approach?
Is this on?
You answered.
No, mine isn't on. That might be on.
Is this one on? Hello? Yes. Right. Oh, he left. Okay, never mind. Oh, you are here. So OSGI is more than a module. I give you a very brief answer. It's a deep topic. OSGI is much more than a module system. It's a security layer and a services layer and a bunch of other stuff, and it does dynamic reloading and lots of fancy things, which some applications need, but many don't. The module system we're designing for, to be the standard module system for Java, doesn't have all of those capabilities, but it has a bunch of additional capabilities. Namely, you can actually use it to modularize the platform itself, which you can do with OSGI. OSGI is built on top of Java, right? And we need to modularize all the way down into it, which is why modules are a fundamental new program component in this design, rather than some class loaders with some fancy stuff around them. So OSGI works perfectly fine on top of 9. And it is intended to keep working forever. If you need to use it, keep using it. It's a good solution for some problems, but not for everybody. That's the quickie answer.
I could fire up JVM and test this myself, but it's easier to ask experts. What happens?
Lazy.
What happens if an exported class tries to expose in the API an internal class that is not exposed through the module. Does that make sense?
Yeah, your users will be unhappy.
Well, will we get an error at compile time, or will that just be at runtime when the application craters?
Some of those cases can be detected at compile time. If they're not, they will definitely be detected at runtime.
Okay.
But one thing just to keep in mind is that it is very normal to have an API that returns back some internal implementation that implements something that is exported. So this is it's very normal for me to I was using the Java SQL driver there for you to have a reference to a driver, but it's some internal, I don't know, Oracle database driver type that's in a non-exported package. That kind of thing is normal. I think what your scenario is what Mark was getting to, whereas you make an error in your signature of your method, and you end up having public driver impl get driver, something like that, and that's something that can be detected at compile time.
But it is acceptable to return a reference to the implementation class as long as it's referred to as the.
Yeah, as long as the return type is available to whoever is using your module. That return type could be defined in some other module. That's fine.
Okay, thank you.
I'm just curious about the transitive requirements. How you determine what to declare as transitive versus not? How do you know what people are going to need access to?
So the simple answer is, and this actually relates to the previous question, if you have an API that's using basically types from some other module in its API, you have a method that returns a type foo that came from some completely other module, then it's probably helpful to your users for you to require transit of that module. If not, they'll have to do it themselves. Right? Make sense?
Hi, I have the questions. So we know we are using Gradle to manage the version right now. So it looks like modules is helping us to replace the Gradle. So my question is, I can see now we put everything into a jar as a module. So is that something overlap when we should using the module be as the Gradle managed jars?
Do either of us know enough about Gradle to answer that question?
I think there's actually one or two Gradle sessions which actually talks about JDK 8 and JDK 9 support at JavaOne. So the module system doesn't replace Gradle, I think it'd be better to bring up some of those questions at the Gradle sessions.
Okay, thanks.
But in general, our whole approach is to design something that will work well with existing tools. So it's designed to work well with Maven and Gradle and everything else. We're not trying to replace those existing systems.
I see. Thank you.
Does JLink work cross-platform? Can I create a...
Yes, it does.
Okay. Yes, it does. We had a few issues, but they, I believe, have all been resolved.
And does that mean that the final product that gets produced will run on any platform? Or does that mean I have to specify that I want to export to Spark or to ARM? Or
Okay, JLink figures out what your target platform is based on the platform modules that you're linking in. So if you're on Mac and you give it a module path to a Windows distribution, then it will actually link in the Windows versions of those modules. Okay. And produce you a Windows runtime that will only run on Windows.
Okay, so it really comes down to which Java base you point at.
Correct.
Okay.
That's it exactly.
Okay.
Yeah, Bob, actually, Mandy's in the front row is just pointing out that Bob Vandette, who works on embedded, gave a talk, but his talk was this morning, where he actually was doing some demos of cross-linking to embedded platforms.
I was learning how to hack my toothbrush.
Thank you.
So I have a question related to migration. So you said for migration purpose, we have option to use modular path and class path at the same time. And modulars will not be able to use libraries from class paths, but libraries from class paths will be able to use classes from modulars, right? So if it depends on something, I cannot start to use modulars in my projects until guys who created these libraries will migrate them to modular system, right?
This is a really, really good question. And in our talk at 5:30, we will be talking about migration and particularly around automatic modules that allow you to migrate to modules without waiting for everyone else to move to modules first. So come along to 5:30. We have a lot of sessions, a lot of slides on this exact topic.
Does the module system solve jar hell?
We hope so. that is one of the primary goals.
And how does it do that?
You were in the room, right?
Right, but I didn't see any versioning besides maybe the @9 to suggest that might be versioning.
Oh well, if the solution for jar hell you're looking for involves version numbers, then no, we're not solving that problem. And that's related to the answer I gave a minute ago about fitting in with existing tools. Yeah. So jar hell, like any pejorative term, has many different meanings, right? Mm-hmm. The jar hell problem that we are out to solve is the one of, okay, you've got a zillion jar files on the class path. I mean, we've seen Oracle internal products with more than 1,000 jars. It's like, wow, how does this even work? You can't figure out you can't tell when there are conflicts. You can't tell when things are missing. You can't tell when it's safe to replace something. That's the particular form of jar hell we're trying to give a way out of. And once you can get to a sane module graph, then you have good answers to all of those questions, and you don't have the chaos of the class path. Now, as to versions, there are lots of reasons why this module system does not have versions. In terms of, it doesn't have version constraints. You can stick a version on a module as basically as documentation, and it gets carried around. It will be reported in stack traces and things like that, because it's very useful to know, well, code came from version what of what module. But there is no way, and this is intentional in the module declaration, to say that this module X requires version 1, some version between 1.2 and 3.9 of Y, but never 2.4.1 because I know that one's broken, right? The very early prototypes of Jigsaw, we actually were trying to solve that problem, and we realized, wait a minute, Maven solves this problem, Gradle solves this problem, other systems solve this problem. Now maybe those existing systems don't solve the problem in the theoretically optimal way, but you know what? Millions of people use these tools already. And to try to displace that would just be a fool's errand. So this module system works with the concept of the module path, which is a way to find modules, and we rely on your build system, whether it's Maven or Gradle or Makefiles or take your pick, to make sure that the correct versions of things you have are on that path.
And just add something very, very practical is, suppose you have a bunch of jar files on your class path today that are either different versions of the same library, or they all happen to be using the same package, or whatever it might be. Try that with the module system and as modules on the module path, and it will not allow these. It will detect these kind of split package issues. It won't even start up. It'll if you've got issues there, or if you've got two versions of the same module. Then it will pick whatever the first one is, and on your module path, it will completely ignore all the other versions that you might have. So you've got no scenario where to be trying to load some parts of, in our example here, acme stats core from this jar file and more from this other jar file. That just doesn't happen with modules.
What about the Guava? Speak into the mic, please. We're streaming.
So related to that, if you're mixing a class path app with a modular app, so in your example, you pulled in Guava. So if I have Guava on the class path as well as embedded within a module, what happens?
Okay, so module wins.
So if my app is the class path app, right, and it requires Guava, then it's pulling the version of Guava from the module?
So my app is on the class path, so it doesn't require anything. There's nothing in your my app to say what it depends on. So we out of the box, we assume that when you're running things on the class path, that you just require any of the modules in the runtime image that export APIs. So you
But I can also have a dependency on a local jar file in the class path. That could be a Guava version, right?
yes, it could.
So if I do that, and then Guava's also packaged up in one of the modules, then what happens?
So in that scenario, nobody requires Guava because there's no module that requires Guava here. Your module path isn't even being looked at here unless you give it an at modules to tell it that you want the Guava module to be resolved. So you might remember in the slide we had to do an at modules stats core in order to ensure that that module was resolved. If you did at modules Guava, then the Guava module will be used. The guava.jar on your class path would be ignored.
Okay.
To go back a little bit, just to be clear, if I had a module dependent on two different modules, and each of those modules is dependent upon a different version of a same module, it's going to kill it, knock it out and say, hey, this isn't even allowed.
Yes.
Okay, thank you.
I mean, if you're doing something sophisticated like writing an app server, there's some advanced features of the module system that let you support that kind of scenario. But in practical use, for smaller, less sophisticated applications, which is most of them, that's just not needed. In general, if today you have two different versions of a library on your class path, you're already in trouble. You just might not know it yet.
Right.
So I had a question in regard to, you had a slide where you made a very strong statement that public does not mean accessible. What about for like reflection? So can reflection still peek under the hood and violate all your system of trying to hide things cleanly?
So core reflection has been specified for 20 years to do exactly the same access checks as the language and the VM, and that continues. So with strong encapsulation, then even your public types and your non-exported packages can't be broken into with core reflection.
So you would have to explicitly export them and declare them as dependency, and you have to export them to make them reflectable then.
Right, exactly. And there's also another concept on the table I didn't go through in the introduction talk, but Alex will touch on it today in the advanced talk. That is sort of designed for, especially for applications and other libraries, then that are intended to be deeply reflected on by other libraries. So Alex will touch on that this afternoon in the advanced talk.
The quick teaser is there's basically a way to export. You can export a package, and you can also say don't not only export a package, but let reflection get into my internals as well, because you're expecting this module to be supported by JPA or something. Okay, we're supposed to get
Yep, I think we're done here. Thanks for attending.
Thank you.
Okay, so hi everyone. Well, the few of you who managed to show up. I mean, this was admittedly a bit far out there for a presentation, so, but it's good to see some of you here. This presentation is going to be about how you can build your own autonomous robotic vehicle and the various techniques I used to build that particular one that's over there. Yeah, so that you can do the same thing yourselves. So that is Coffee. He's named Coffee because he runs Java, and he looks a bit like Wall-E with his laser rangefinder, so of course he had to be called Coffee. And I did this project for fun, to do it with my kids. I mean, that was the idea anyways. My kids hate it, so, you know, from that point of view, maybe not such a stellar success, but yeah. So this is Coffee running autonomously, an earlier version of Coffee, and you're going to hear my son scream in Swedish that he doesn't want Coffee to be anywhere near him. I don't think we hear anything, but yeah. Anyways, so yeah, he's a bit terrified. I think he was probably a little bit too young when we did this project. So he was 5, so can't really blame him, but yeah. It was very close that I couldn't get Coffee in here because Swiss, the airline, basically said, well, kindly note that it looks like a tank, and therefore the authorities at the airport might reach a different decision, and Swiss as an airline cannot guarantee anything on our end. So, and it's ridiculous. It's like, yeah, of course. So I had to reconfigure him. He doesn't use tracks here at JavaOne because the friction between the tracks and the mats were too much. So he doesn't look as cool, but, you know, he can still, you know, do his thing. Okay, so there are 2 main goals with this presentation. The first one is share the fun, because it is hilarious fun to have your Java applications or programs run around in the physical reality and interact with things. It's hilarious, especially when you have bugs. I mean, you really do get to see the bugs. So that's a lot of fun, and it's not really that hard anymore. So key message here is that you can go home and build these yourselves. And I'm going to provide very pragmatic pointers about where to go, what to buy, things like that. The second key message is this all becomes so much easier when you're using Flight Recorder. So I used it for fun, and it turns out it was best thing ever for this project. So I'm going to talk about that. And it's unsupported in JDK 9. So what I'm going to show you are unsupported APIs, just so you know. In JDK 9, they are going to change. So they will be supported. It will be a slightly different set of APIs, much easier to use. But it is just so very useful that I thought, you know, I just wanted to share this now. and you're on your own if you use them, but you know, they are useful. Yeah. So 2 disclaimers. Robotics is not my field of expertise. I did this for fun. I'm a hobbyist. There are probably other ways you can do this, probably much better. The second disclaimer is I will be mentioning different companies by name. That is to be pragmatic, to just tell you where you can get stuff. These companies are not by any means endorsed by Oracle. I don't get any compensation whatsoever from them. You know, these are good stuff that I think is worth knowing about when you build these things. So mostly sensors, engines, and stuff like that. Okay, and since I usually say more than I intend, I have this safe harbor slide, which is mandatory if you're talking about future functionality in the Java platform. And I don't think I am going to, but I might. So just for safety, I'm putting that there. So this is the agenda. I'm going to be talking first about building hardware for Java. and what versions of Java there might be and that you might want to consider for your projects. I'm going to be talking about designing stuff for 3D printing, because there are several things in him that are 3D printed. I will be talking about how to record sensor and actuator information into the flight recorder. I will also maybe talk a little bit about some unsupported functionality in Misc control that you can use to plug this into. And then I'm going to talk about some of the results and some future ideas for work that I would like to have time for, but never ever will, I think. We'll see. So, the brains. Nobody can escape the Raspberry Pi revolution. I mean, you all know, likely know that there is these miniature, full computers, credit card sized. Credit card sized in XY, not Z. They are thicker than a credit card. They have quite a lot of memory. So 1 gig of RAM, a powerful 4-core ARM processor, and they run Linux. And you get these pretty cheap. So, and you have all the ports you could need. So you have GPIO ports, general purpose IO ports, you have serial ports, everything you would need to build your hardware project. In Coffee, there is a Raspberry Pi 2, so 0.9 gigahertz quad ARM v7. There is now a Raspberry Pi 3, which has built-in wireless and a 1.2 gigahertz quad. And then there is this small form factor Raspberry Pi 0, which just has a single core. So I used the Raspberry Pi for the brains, and there are several reasons why. And this slide describes one reason. So when you build your embedded system, you can select between Java SE embedded or Java ME embedded. And Java ME embedded is optimized for small devices. So devices with less than 1 meg, so 128K. They have really pleasant libraries for communicating with the hardware. I mean, they are more object-oriented in a way than the thin layer that you otherwise need to use, thin JNI layer. Then you have Java SE embedded. You get tiered compilation, you get generational GC, you get multi-core support, you get to use Java NIO, Java concurrency, you have the flight recorder, but you need to access the hardware through this small, thin, native library called wiring Pi. So the Java library is Pi4j. It's using another library underneath. And that's sort of the trade-off. Of course, I went with Java SE embedded. So that's what I'm going to use, if for nothing else, flight recorder. Then we need to have sensors. We have a brain, we need to have some sensors. Since we are going to be running Java, I avoided or tended to avoid sensors that require timing-sensitive decoding in Java. Because, yeah, you get a GC and then you're screwed. So sometimes that's not really possible. Sometimes you have this sensor that you just want to use anyway. And then there are several different paths you can take. One is to write your own library in C and do the decoding there. Use it as a module. And that's something that I did not for that project, but for another project when I wanted to use a Korean sensor that had humidity and temperature and had its own one-wire protocol. So that's certainly doable. Or you can use a PIC or some other thing like an Arduino Nano to do the decoding, and then use I2C or some other protocol to read the results. So for instance, at home I have an Arduino Nano decoding pulse width modulation signals from a radio receiver. And then I can read from that Arduino Nano using I2C and do the decoding somewhere else, right? So in Coffee, for that thing, you don't need any of this. I mean, you have I2C, a module that you can use in Raspbian, and that's all you need. I'm using Serial as well. But Serial and I2C, that's all you need. So You don't need to write any native code for this to work. So the sensors in Coffee is a laser rangefinder. And this is so cool. You can get a laser rangefinder for $89 now. I mean, this was unthinkable a couple of years ago. So this one is from a company called Lidar Light, but they've been acquired by Garmin, so you can't buy them right now, I think. They said that there would be a new laser rangefinder available later this year, but a Lidar Light V3. So it should be available very soon. And that thing talks I2C, so you just wire it up and use it. Very easy. Then I'm using a breakout board from Adafruit, which is an IMU breakout board, inertial measurement unit. It contains a magnetometer, an accelerometer, gyros, and a barometer in one very small package. So this is something that you can use to, for instance, make sure that you turn exactly the number of degrees you want it to turn, and you can use it for controlling it even. I used to use the accelerometers for deciding when to go into autonomous mode. I just switch it over so that you got G downwards in the wrong axis, and that was a signal for it to start running autonomously. Or when I lift it fast, it goes off of autonomous mode, because that means I had a bug and it ran into the wall or something. So lift it up, it stops. For right now, I'm not using it for that, but yeah, certainly possible. Then I have a GPS in it. The GPS I'm talking to over serial. There are some things that you need to do with Raspbian to make that work, but I'll talk about that later. And then I have a camera as well. So there's a camera module so that I can get images. Right now I'm just streaming whatever I see. I'm not processing the image at all. I'm relying on the laser rangefinder for navigation. Okay. So then you, of course, want it to do something. You want to have actuators in the robot. There are several different ones that you might want to consider. Servos is the most popular one. So it's the same thing with servos as with sensors. You really want to have something that doesn't require you to do timing-sensitive encoding of signals in Java for the same reason. So there is, for instance, this chip from NXP Semiconductors, PCA 9685. It contains its own timer. So it can generate pulse width modulation signals. You just configure it. I want the signal to go high at this time. I want it to be this long, and I want it to go down afterwards. And then it's just going to generate that signal until you tell it to do something different, which is excellent when you're running Java. Then you want motors. And for motors, you need to start considering what your demands are for the robot in terms of speed. How fast do you want it to turn? What torque requirements do you have? This thing is overpowered, so it's crazy overpowered. You could put it anywhere and it's just going to tear itself out of it. So you might not need to go that far, but there are, I'm using metal gear motors, so you can select the gear ratio. There are several different ones available. So just, spend a little time considering what your requirements are going to be, do some calculations, and then just select the motor. Then you need to control the motors. And there are several different ways there too. You can use an H-bridge, simple motor controller breakout board, for instance, or build it yourself. Those are usually using just high-low. You need to sort of control them yourself, right? Then you have other ones that are a little bit more expensive, a little bit more complicated, but they have built-in quadrature encoders and a built-in PID controller. So it has its own control loop built in, which is a time saver. So I have one of those in there. I started with having quad H bridges so one for the motors, two for the motors, and one for the claw, because you can, of course, operate that claw as well. but now I'm using one of those slightly more complicated motor controllers for controlling the motors and using quadrature encoders. The video you saw in the beginning that scared the living daylights out of my son, and you didn't hear the audio, unfortunately, but if you would have heard me laughing. So that's how bad a parent I am. Scaring kids is fun. That one wasn't using quadrature encoders at all. So you don't need it. But it's much better when you start looking at things like SLAM, simultaneous location and mapping algorithms. Then you at least have a pretty good idea of how far you've gone. Okay, motors. In coffee, I'm using 25 millimeters, 12 volt high-powered Pololo metal gear motors with quadrature encoders. Probably an overkill. Then for the claw, I'm just using the thing that came with MakeBlock. I'm going to be talking about MakeBlock a little bit later. Motor controllers, talked about that. Servos, I just took 2 cheap servos and I put the laser rangefinder on them. So I have one servo for tilt and one for pan. That's it. Works fairly well. Again, these are cheap servos. If you buy one of those $3,000 laser rangefinders, it's probably going to have mirrors in it and have something spinning, and it's going to be much more precise. But that was not my budget for this project, so I'm telling you how to do this on the cheap. Okay. So one thing that might be worth noting is that servos usually have an operating voltage of 5 volts. If some are specified to work on 6 volts as well, and you usually get more torque and you get more angular speed. So it might be a good idea to actually have a step-down regulator for 6 volts in your robot as well, so that you can run your servos on 6 volts. Then for generating the pulse, so for generating the signals that you control the servos with, I have this Adafruit 16-channel PWM breakout boards. I'm not using 16 channels, but hey, never know. Might want to have a cannon on it or something. Shooting kids, no. Then of course you want to wire everything up. And one thing that I wish I knew before starting all this, starting building things, is that those little things that you use to connect servos are called DuPont connectors. So instead of buying prepackaged servo cables of a certain size at quite the dollar, you can buy hundreds of connectors for $3 on eBay and then build your own cables, as many as you want to. So that's a much better idea. Just buy a crimp tool and go make your own cables. You get them exactly the size you want to, and it's much, much, much cheaper. Since I fly radio-controlled aircraft and helicopters and stuff, I wanted to be able to use my standard batteries, so I put XT60 connectors on them. So another pragmatic hint from this session is when you solder these, put them together first, then solder. It will cause you way less pain. Otherwise, they get misaligned and too hot. And you can nerd out in terms of connectors and connectors to have on your circuit boards. It's quite fun if you're a nerdy person. So I'm using a lot of different connectors. That one over there is the kind that you usually have on your PC builds for PWMs fans. So I'm using all of these inside for where they are best, and this ties very well into my OCD. You can have little sorting boxes with connectors for everything. So at home I have connectors, capacitors, everything sorted by value. Okay. Prototyping with MakeBlock. So MakeBlock is this, I think it was a crowdsourced thing. So it's like the next generation Meccano thing. It has these really smart aluminum profiles that you can put together and you have tracks and wheels. So it's very easy to build things like robots and toys using this. So that's what I bought. And so my kids hated the previous thing, so I built them a radio-controlled version instead, which was much more appreciated. So I think it's a thing about control. The kids want to be able to control stuff and play with them. If it just runs around on its own, it's like, so? they just don't get that. So that's my daughter driving for I think it was the very first time she drove it, so she was doing well. Now, designing parts for 3D printing. Nowadays, it's actually, you have tools for free, really good parametric modelers that you can use for building these things. So Autodesk Fusion 360 is free for hobbyists. You can just use it, which is brilliant. So one thing I learned the hard way, to continue with the pragmatic tips, was that, of course, you want to parameterize things that you want to change afterwards. So things like the server width or the server height and similar things. You want to have parameters for that. And of course, I did that. But I never, during the design phase, tried them out. So of course, I wanted to have a slightly bigger servo. And of course, I changed the parameter. And of course, everything broke because the constraints weren't right. So if you do this and try this out when you model, you're going to save quite a lot of time. Right. Then you need to design around the current limits of 3D printing. So today, fused filament fabrication is the normal state-of-the-art sort of printing for things that you actually want to use and not just look at. It has some limits. So the way it works is that the printer deposits plastic or whatever material you're using, layer after layer. And if you have a design that requires you to print into thin air at some point, of course that will not work. So, it will just put things into thin air and it won't exactly be the way you imagined it. So there are two things you can do. You can either design around these limitations, and if you do, other people can print your designs because not everybody has a dual extruder printer. So that is the best thing to do. The other one is to use a dual extruder printer. I have one, and use a material called polyvinyl alcohol, which is soluble in water. So you can actually print on top of that material and then just put it into water, wait a very, very long time for the material to dissolve. And then you have your more advanced design. So I do that sometimes, but very seldomly, because I want other people to be able to print my designs. Okay. Also, printing today is a very slow process. It takes quite some time. So it's actually well worth it, I think, when you build something a little bit more advanced, where you have lots of different components that need to work together. I think it's a very good idea to do some mock-ups, right? So you lay out where you have your geometrical constraints. For example, to the left is where I have my connectors on one of my custom boards that I use in Coffee. Then to the right is the make block aluminum profiles. And I modeled those so that I could see that everything fits together and everything works together before printing it. Because printing it, just the top is a 20-hour thing, right? So you want to know that that this works. So this is what it looks like inside of the modeling tool when you're trying to fit things together and see what it looks like. So I did actually model, most of the stuff, and oftentimes you can find models readily available for you that you can just use. So if you have a Raspberry Pi 2, you can often find a Raspberry Pi 2 model that you can just put into your design and see that everything fits. Okay. So 3D printing, yes, takes quite some time. The one on the upper left, the top, again, took 20 hours to print on fine. Other parts of the robot took less, but it still takes some time. Even the bottom plate took several hours to print. So these are the parts that makes out the brunt of the robot. So you have somewhere to put your Raspberry Pi 2, somewhere to slide in your special circuit board, and you have little buttons so that you can control the LCD on the back and give it commands. So even a little holder so that I can do demos without him running away. Okay, so let's say you want to do a project like this. A good way to start is to start small. Try one chip at a time. Go for the, I don't know, the gyros, the accelerometers, whatever you find is the fun chip of the day. And then read the specifications. Because if you go online and look at blogs, you're going to utilize half of what's available in that chip. I mean, my experience is that there is so much more they can do if you just read the specs. So read the specifications. It's like in the back good old Commodore 64 days. It's all about peek and poke. That's what you're going to do. You're going to be reading stuff from it, and you're going to be putting values in it to do things. And just read the specifications to see what you can do. It's very well worth it. And also be mindful of logic and power levels, because the Raspberry Pi is 3.3 volts, not 5. So, be careful. And you can buy power converters, you can build them yourself. But, yeah. Most of the things that you can usually find things that do what you want at 3.3 volts. So it's not a big deal. And then build a little library of abstractions. So if you have a GPS, build a little library that talks to the GPS the way you would want to talk to it in code. And pretty soon you're going to have this library of nice little abstractions, and then you can go top down again. Start with, I have a tank. I want it to be able to go at a certain speed and turn. And you build those abstractions from the top down. When you do this in Raspbian, you might need to enable some modules. The I2C protocol is not enabled by default, so you need to enable kernel support for it. That's pretty easily done. And to use the UART port on the Raspberry, you need to modify the boot command line because it's used as a terminal, so you can just connect the terminal straight to those pins if you want to, and it will be available for you on boot up. But I wanted to use them for my GPS, so yeah, that's what you need to do. Also, own more than one SD card, because you might release the blue smoke out of the Raspberry, and your SD card might be gone. Might happen, true story. So, I've killed one so far. It's pretty good track record since I've been doing this for a few years now. But own more than one, and once you have configured the SD card with everything you need, like your SCM, your Java version that you love, you have everything on your SD card, back it up. Back that image up as soon as you're done. So you can start from there next time. Then use an SCM, standard Java development, please. The Raspberry Pi is very powerful, so you can actually run things on top of it. You can just run VNC into it, and even develop, on the Raspberry Pi. That's how powerful it is. So that's certainly possible. So run a desktop if you want to. You can run your IDE and your tooling straight on the Raspberry Pi. I think I've probably done most of the coding on my Mac, so not on the Raspberry, but I've been switching. So, once I've done a big change to everything, I sync the code, I run with the new code, and then I have an Eclipse, and I just do minor changes straight off of the new code. But if I want to code bulk, it's probably not going to happen on the Raspberry. But it does simplify the whole run, edit, compile cycle. Right. So, Flight Recorder on the Raspberry Pi. So, Flight Recorder contains an unsupported API, will be supported in JDK 9, but in JDK 8 it's unsupported, for creating custom events. And this, I can't stress how useful this is. This is, I mean, when I started doing this, it's like the whole game changed. It's not that hard to use. JMC is not available on ARM, so you can't run it locally, but you can run JMC on another computer and just hook up. And you can also use JMX for controls. Just publish a few mbeans that publish your model, and then you can control it, radio control it, remote control the thing if you want to. So I did a few JMX mbeans, but that was only for the demos. I didn't actually use it when developing the robot. It's just there for fun now. So these are the events I have, and the most important one is the laser scans. So getting point information. But I have engine changes, I have the laser scans, both one overarching for the actual scan. So I have a timed event that tells me how long the actual laser scan took, one scan. Then I have the individual points that I got from the scan. I have events for navigation, so goals and targets. I have event for planning, so that I know how my crazy algorithms for raycasting, etc. takes, so that I don't run into trouble when trying to decide what to do. So here's an example, the laser rangefinder scan event. For those of you who went to my presentation earlier today, you can see that it's slightly more complicated in the old API. But the important thing here is the relational key. So the relational key is used to connect different kinds of events together, tie them up together. So in this case, I'm having a scan ID for which I can associate all my points to a certain scan. And I'm using that later in Misc control to be able to see discrete scans. Okay. Then this is also an important thing to note in comparison to the to the new API. You actually needed to have a public getter or have the field public. That was necessary in the previous API. It's no longer necessary in the new one, but back then it was. So if you don't get things to work, this might be it. Here's the scan point, nothing special or strange. You get the X, you get the Y in local coffee coordinates, and then you have the scan ID that everything is associated with. Then generating events is very easy, but I'm utilizing a technique that is no longer necessary in JDK 9, by the way, but in this case I'm actually reusing the event, because I know that a scan is always going to be from one thread, the entire scan. They can be initiated from different threads, but one scan is going to be done fully in one thread, which means that I can actually reuse that event. So for the scan implementation, I just set it, and then for every point that I get, I'm just resetting the event, and then setting the data into the event, and then committing it. So a small optimization that is no longer necessary in JDK 9. Here's an example command line. I'm starting with commercial features, a flight recorder, and the JMX agent up. That's it. If you want to do this through command line only, or if you want to dump the recorder with jcommand, you can find out how to do that on my blog or the documentation. So then I went further. So I integrated this with Misc control, which is, of course, even more unsupported. But useful. So if you're interested in how to build that kind of integration, come talk to me afterwards. But I basically built a custom component that is always going to be a slave of other components. So whatever I select in the master component is going to be forwarded to that slave. So I can see the exact scan. And that is the important thing. Right? Because when I was developing the algorithms for doing feature extraction and the algorithms for deciding what to do, what goals to pick up, I was doing that entirely out of old data. I let the robot run, and it was pretty stupid at the time, through my apartment. And then I had a run. I had data, real sample data from the laser rangefinder. So what I did then is to just fire up my Mac, my development environment on the Mac. I was running the algorithms just inside of mission control instead, looking and seeing what kind of results I would get from my raycasting. Does it make sense? Is the goal it is picking out of this data sensible? And I didn't need to run the robot after that. I mean, that was it. And once I was done developing the algorithms, just straight in the client, then I just copied them to the robot and good, sure, it works, cool. So, seriously, using Flight Recorder for this is just such a wonderful thing. Okay, so I thought I'd do a few demos. So I have coffee here, and it's been on for a while, so I'm not sure how battery-wise how well he's doing. We'll see. He's booted, and he's telling me his IP address. Please don't hack him. And I'm not going to point him at you, David, because I will be shooting lasers now, and I shouldn't be shooting them in eye height at people, I think. So first thing that I'm going to do is that I'm going to just SSH into him. And then I'm going to start VNC. Yes. And then I'm just going to hook up VNC to him. Here we go. So this is actually, my robot. I'm inside his brain now. And we'll see. Let me do this. Run coffee. No? What did I call that then? Start coffee, maybe. Start coffee. No? Oh, okay. So now I'm starting coffee. So it's in attention now. And ready to scan. So I built this really simple, just something to check what's going on his side of things. That normally not running with this UI at all, but just for demo purposes, it might be fun to have. So I'm going to do a scan now of the environment, and so that's what he's seeing, and he's decided to have a goal point, nearing the corner there, and that's where he wants to go. When he's running autonomously, he's actually running with various levels of granularity, and depending on how close he is to things and how much he thinks he needs more information, he might resort to making a slower scan. When he's running full ahead, of course, he doesn't really have time to scan very, very finely. Right, so I'm going to start. I have mission control here. And let's just use I took the liberty to build a plugin for the console as well. So we can run coffee from here, remotely, over JMX if we want to. We can initiate scans. And it's all connected to the same model. So if I do start driving autonomously, which is going to be crazy, because he's going to get really upset now. But if we subscribe to the model data, you're going to see whatever stuff he's doing now. And yeah, not getting any closer. What's happening? Right. So I'm going to stop him right there. So of course, JMX for control is probably, quite fine. That's what having ambient operations is not such a big deal. You don't do them that often. Getting a little bit of data is probably fine too. Getting thousands and thousands and thousands and thousands of scan points over JMX, this poor little robot, is probably not such a good idea. So what I did was that I built this integration with Misc control, the flight recorder. So I'm going to open some whatever. We'll see what it is. Let me see. Yeah, I guess you see that. Okay. So I built this user interface, which, by the way, is really quite easy because there is a built-in GUI builder in Misc control. So if you want to build and customize the user interface, all you need to do is to start the GUI builder, and then you can, rearrange the user interface to your heart's content. So, for instance, if you hate dials, some people do, then you can get rid of the dials. But anyways, so this is the user interface. So what I did was I let it run around. This is in my apartment at home. Have lots of scans. He's getting closer, here. And you can see, the points from the scans. But I also built so that I can test my algorithms. So if I wanted to render the raycast that I'm using for deciding where to go, that is pretty easy. And if I wanted to render the features that I've found from my feature detection, I can just try out my algorithms on the sample data that I have. And of course, the sample data, when you put a laser rangefinder on a cheap servo, is going to be pretty noisy. But it works fairly well. So for instance, here we have discovered that we do have a corner over there. And Coffee tries to avoid corners when it gets too close to them. So you can see that there is a bit of a no-go zone there in the raycast. And I take my features, and then I do a raycast on a pretty fine-grained to see what I hit. So I have no-go zones around every point. And then he finds his way. So this kind of integration with Misc control, of course, the scan visualizer is custom built, but the tables and everything around that is not. So if I wanted to do things like, let's say that I wanted to redesign this. So window, show view, designer. I have the design view, I have flight recorder here, and I have my UI here. Let's say that I wanted to show the durations for a scan, for instance. That might be interesting. Then I could go to my little scan page here, stop it all, and say that, yeah, I want to redesign this. I want to have some column here, which is the duration from the scan. Oh, I actually already had that from the demo. But let's enable it. So that's how you would do that. And you can see how much time the scans usually take. So fine-grained scans take a little bit longer, about a second. And the shorter ones take about 400 milliseconds. Okay, so let's see how we are doing on time. I want to have some time for questions later, so I'll stop there and move over to the demo. Hey, did I? Okay, so one final demo then. Last night, when everybody was preparing the pavilion, the exhibition hall, I went up there and I let him run in fully autonomous mode up there among all the cases and stuff. So this is him running on fully autonomous mode without tracks, with wheels, and running about, avoiding things, even avoiding things I thought would get him into trouble, like the legs of, you'll see later. Like, I thought he would crash into that, but he actually discovered it. And he's taking it a bit easy when he gets very close to stuff. And there he goes, well, I should probably go out of here. And then he continues. So that's him running on 0.3 of the speed. So he can run more than 3 times faster. Then, of course, you have the issue with him not maybe discovering things until it's too late. So you need to have more safety. Okay. Yep. So, the results of the project. It was very fun for me. It was really boring and scary to my kids. Kids seem to like control, so the radio-controlled model version that I did was very much more appreciated, and I think it's an age thing. They probably like this more when they get a little bit older. So what I would like to do with him that I didn't have time for would be to implement a full simultaneous location and mapping algorithm so that he can map out the world as he's traveling through it. He does feature extraction now. That's a good start. But FastSlam 2 or something would be really cool to implement. The thing that I really want to do is fully autonomous thermal glider, because when you have a thermal glider, the way you notice that you have upwind is that you can see that it starts tilting outwards from where the upwind is. And the gyros could easily discover that and start navigating towards the upwind. So that's something that I want to do. I want to take this, put it in a thermal glider, and probably ask permission from the authorities before I have it roam around Switzerland. But yeah. Then again, the time changed. The time schedule changed because I got twins. They are now 9 months, and they destroy all the spare time I have. So, it's this is put on hold for now. Yeah. Okay. So for additional resources on mission control, flight recorder, unsupported serviceability APIs in the JVM that I probably shouldn't be talking about, etc., you can go to my blog. I put my designs on Thingiverse. I just started doing that like a couple of months ago, and there's been thousands of downloads, so that's really cool. Yes, and mission control is on oracle.com. Mission control, and my Twitter name is Hurt. And I think that's it. Cool. So questions?
So here's a question. So
yeah.
You talked at the beginning that probably you like the flight recorder because you can record all those events very clearly. But for most of the stuff in robotics, you've got tons of data event security, right? So we've got that timing problem again. So what do you do when you have a situation where you have lots of sensors and you record that fine granularity of events? I guess.
Well, I couldn't. Okay, so the question was, in robotics you could have quite a lot of sensors and immense amounts of data that you need to record, and what would happen then? And this is what Flight Record was built for, to be able to handle those kinds of data. Because you can imagine in a JVM, the number of times you synchronize on a monitor, for instance, you can imagine the frequency that happens in, right? That's going to be way more than you can produce sensor data, right? So it's actually quite good at handling very large amounts of data, the flight recorder.
I guess probably the question is really, it's great.
How do you get the data from the robot?
No, it's great to collect the data.
Yeah.
But then to process the data in real time to get that.
Oh, real time. No. So that's right. I wouldn't even begin to try to process that in real time and do something with it. At least not from the Raspberry. I mean, it wouldn't be able to.
It's really great for collecting data.
It's great for collecting the data and for visualizing the data. So you can use mission control to visualize the data and draw your own conclusions about how well your or not well your algorithms are working. So it's very good for finding problems. Submersible? No, I want to fly. Not a submersible, no. I had that as an idea when I was a kid, but now I want them to fly. So next project is definitely going to fly. Not sure if it's going to be quadcopter. My brother is very much into quadcopters and builds stuff for quadcopters. So, but I would like to build a thermal glider. That's what I would want to do. Any other questions? Previous slide. This one? Oh, okay. Sure. Any other questions? So you're all going to go home? No. What's your budget? The budget? My wife might see this. So we can talk later. Yeah. Sorry? Oh, the battery. So I overdosed it on LEDs. So I don't know. Well, depends. I don't know. It's been up there for an hour now. So just running the Raspberry on batteries doesn't take that much juice. It's the engines, when you start running them, that take the brunt of the. I haven't actually run it for an hour, but I think it should, yeah, maybe. Maybe. We can try later. I'll have it in the pavilion.
What kind of algorithm do you use to decide the waypoints?
Right. So I wish I had a better one. So currently it's really stupid. All it's trying to do is to maximize the amount of travel time it gets without having to do any major turns. So I'm using a raycast algorithm. I just threw something together. So what I'm doing is I do a feature analysis of all my points so that I find the walls and I find the corners. When I have done that, I have a no-go zone, exclusion zone around each point. And then I start raycasting. I don't know if anybody has done this before, but I just raycast, throw out rays, see what I hit, right? And if I do hit something, close to me, I don't want to go there. I want to go somewhere far. So that's the choices it makes now. So it tries to avoid corners when it gets close to corners. But in the future, I hope to have a fully working simultaneous location and mapping algorithm running on him. I'm probably going to need to do some optimizations because the raycasting currently takes a bit of time. So I'll need to optimize what I have currently a little bit. But yeah. So that's what I'm doing today. And if you want to know how I do the feature extraction, we can talk later because I'm going to need a little bit of time on the whiteboard. Any other questions?
I apologize in advance because I was not at the beginning
Oh.
of the presentation. Now, how many iterations did it take you to get to this point?
How many iterations? Depends on how you define iterations, because I've done smaller modifications over time. So, for instance, I've exchanged the H-bridge for a more powerful and more featured motor controller. I've changed the engines to have quadrature encoders. So I've done little modifications, but the main 3D printed parts, I've done one. And that's why I say, modeling the different parts that you are going to be using inside saves you quite a lot of time in the end. If you can just see that everything fits together before you start printing, you save time in the end. So that's what I recommend. And I might have built him differently now that I know more about 3D design. Yeah, looks like an F117 a little bit. If you no, no, but I think it's nice. He works well. Okay, cool. Any other questions? Okay, cool. Thank you.
Okay, hi everyone. There are a few more people coming in, but it looks like that is almost it. So, welcome everyone to the last Jigsaw talk of the day. This is Advanced Modular Development. My name is Alex Buckley. I'm in the Java Platform Group at Oracle. I do the first half of this talk, and then my colleague Alan Bateman does the second half. Mark is here for emotional support. This is, believe it or not, even though it's the end of the day, this is the third of 5 Jigsaw talks. Alan will have the dates and times of these at the end of the presentation. But modules and services and Project Jigsaw Under the Hood are tomorrow in this room. And then we also start the repeats of the whole cycle with Prepare for JDK 9. I think that's on Wednesday. That's not getting repeated tomorrow? So, anyway, this talk is in 2 parts, and they're really both about migration because there's a whole module system API. You can look at the Javadoc for that. But the first and most existential question when modularizing an application for JDK 9 is where did the modules come from? And that's really what this talk is about. So I'm going to talk about migrating your application top down. And then Alan will speak about migrating libraries that sit closer to the JDK than your application. So that's bottom-up migration. So application migration. At heart, a typical application has 3 layers. At the top are your jar files. At the bottom is the JDK. And in the middle of this sandwich is the filling. A bunch of jars downloaded from the internet in the nicest possible way and thrown on your class path. In Project Jigsaw, we've turned the JDK into modules such as Java Base, Java Logging, Java SQL, and Java XML. Modules are good things. They're always in green. Their benefits are strong encapsulation so that no one outside a module can access its internals, and reliable configuration so modules know what they need and there's no need to set the class path. If this sounds good, you might be wondering how to turn your application into modules. Let's put some names on the jars at the top to get started. Let's assume that the main application is myapp.jar and it has some helper code in mylib.jar. And let's assume that the cloud of third-party jars, that filling in the sandwich, can be simplified to just Jackson, the JSON processing library. Jackson comes as 3 jars: core, data bind, and annotations. Of course, to run the application today, you have to ensure the class path is set up like this. Everything's in the lib directory. I'm going to have my things first, and then the Jackson jars, and then my main class. No problem. JDK 8. Now, you wouldn't have to bother with that long invocation that sets the class path to this and that and the other if myapp.jar and mylib.jar turned into modules. Now, turning each jar into a module one for one is a fairly natural way to proceed. It's not always possible, especially if jars have cyclic dependencies among their classes, but let's go with it for now. Whenever you see a module, you should ask 2 questions. What does it require, and what does it export? Let's ask that for each of our prospective modules, myapp and mylib. One way to find out what a module might require is to run jdeps on the jar file that you have. jdeps is a tool in JDK 8 that analyzes classes in jar files and finds whatever classes they refer to in other jar files. Here are the results of running jdeps on myapp.jar and mylib.jar. The classes of myapp.jar make use of classes in Jackson core and Jackson databind.jar, and of course in mylib.jar, that's the helper. plus myapp.jar uses classes from the Java base module. I'm pretty sure JavaLang object is among them, since that's down in base, and string is another one. And for sake of argument, it uses JavaSQL as well. mylib.jar turns out to only use classes from the Java base module. So that's nice and simple. The arrows are, my app depends on all sorts of things, and mylib, and then mylib is just, for sake of argument, depending on the JDK itself. So with this knowledge, we can write the module declarations. Here's the moduleinfo.java file for mylib, our helper library. All it requires is java.base. Now, you never actually need to write java.base, since it's literally impossible to write a Java program without indirectly relying on JavaLang object. So we always give you the dependency on Java base for free, even if you don't write it in source. But we put it out here to be clear. Now, there's an exports here which I've written by hand. JDeps cannot realistically help you determine the exports of your jar. We could just say it exports everything, but when you're writing the module declaration, you still have to choose. So let's say that mylib exports a package, com myapp libutil, to the myapp module we're going to make. Now, this is a qualified export because it's specific about which other modules, namely myapp, can access this exported package, in particular the public types of that exported package. Let's now turn to the moduleinfo.java file for myapp. It requires mylib, our newly created module, and it requires JavaBase and JavaSQL. And of course, we know that it's going to use Jackson. So we'd like to write requires Jackson core and requires Jackson data bind. Does that mean that I, as the developer of myapp, have to write moduleinfo.java files for Jackson as well? That would be a pain. I don't control those jar files. If only there was some way for the Jackson jar files to become modules automatically. In that case, we could then write the declaration of the myapp module, moduleinfo.java, like this. We just require those jars like any other module. We would have a beautiful module graph with myapp depending on mylib, those are two explicit modules, and myapp depending on some of the Jackson modules, and then also down on JDK modules. You can do this. The solution is automatic modules. An automatic module is a jar file that you put on the module path rather than on the class path. Once you do that, you have a real module. You don't change someone else's jar file. You don't change its manifest, you don't put any class files into it. The name of that module is derived from the jar file name in a fairly obvious way. It strips the version off the end and other things. That automatic module exports all of the packages. Like I said, there's nothing else you can do, really. It exports all the packages from the automatic module. And that automatic module requires all other modules that are in the system. So, in effect, automatic modules mean that today's jar files that you're running on JDK 8 are tomorrow's modules. They can act as modules in JDK 9 very often without you doing anything. Without you doing anything to them, rather. So once automatic modules spring into existence for Jackson core, Jackson data bind, and Jackson annotations, the module graph looks quite different. The automatic modules basically require everything. That's a feature, not a bug. They require each other, they require all the modules in the JDK image, and all of your modules, look, the arrows are going up as well. Now this is to provide the maximum possible compatibility surface for code in older jar files. You might think that the module system could run JDeps on the jar files, those 3 jar files at startup and try to figure out what modules they require, but that wouldn't really help. And the reason it wouldn't help is a bit subtle. The thing is that the libraries that you typically find in the filling of the sandwich often make use of core reflection, that is the JavaLang reflect API, and they use it to inspect classes dynamically. Now, JDEPs can see the invocations of the core reflection API, but it can't very well predict statically what classes will be inspected dynamically. And in fact, the Jackson databind module makes exactly this use of core reflection. When code in my app, here it is, doing an import of the Jackson API, and then calls the Jackson API object mapper, it passes, there it is, the final argument, it passes its own class object. The intent is that Jackson databind can create an instance of the myValue class, which is an application class. Why? So that it can then assign the field name to Bob and age to 13, because it's doing JSON object mapping. Now, on JDK 9, this code won't succeed because we never actually got round to saying what the module myapp exports. Myapp doesn't really have an API. It's the top node. It's the application. Yet, it needs to export some packages anyway, and you may find, if you're using any frameworks at all, even if you don't think as an application that you have an API that other people call, you have this implicit API anywhere you add it at inject, right, or at entity, or at path param, or you pass any of your own class objects down to a library. The solution is to declare myapp as a weak module. A weak module exports all of its packages in a way that allows a framework like Jackson Databind to reflect over its internals. You do not need to manually export the packages one by one and then keep this module declaration up to date with the source tree of myapp. With a weak module, in effect, you get the benefit of reliable dependencies, but without the full strength or the full power of strong encapsulation. Frameworks that reflect over application code are a reality in everyday Java development, and they aren't going away. So application code like myapp can't always be strongly encapsulated. There is business value in the frameworks that call back into you reflectively. So we think this weak modifier at the very beginning of a module declaration is a clear statement about the nature of this module. It's open for reflection, but it doesn't have an API. Without the weak modifier, a module is strong. It explicitly defines an API via exports statements. So let's come back to the module graph. It is pretty messy, but it's better than when everything was a jar on the class path. And by the way, because myapp is now exporting what it needs to, that arrow that says databind is going to require implicitly myapp, there's that, and then there's the export from myapp because it's a weak module, and all the reflection from databind will just work. But the overall graph is still pretty messy. But better than the class path because, for example, there is no arrow from mylib to myapp. So there is no danger of code in mylib accidentally reaching into myapp's internals. On the class path, code in mylib.jar could access code in myapp.jar quite easily. It's just scan the class path until you find the class. And that kind of chaos is what causes maintenance headaches down the road. In fact, if you think about it, the class path, at the end please, the class path is crazy. With just 10 jars, you get 100 possible ways for classes in those jars to interact. The class path is the ultimate in erasure. Whatever you know about the structure of your system, the class path throws it away and connects everything to everyone else. And that means conflicting classes and missing classes and duplicate classes in different jars, and generally slow sequential lookup every time the VM needs a class, which is often. With modules, you're telling the compiler and VM about the structure of your system. And automatic modules, there is a tension between the cleanliness and the usability, but it all works out. You're telling the compiler and VM about the structure of your system, and finally they make use of that information. Speaking of the compiler, let's see how you run it for these module declarations I've been talking about. We've got the JAX and jar files in the lib directory, where they always were, and we're going to treat them at compile time as automatic modules by putting them on the module path to the compiler. Then we've got the myapp and mylib source in the source directory, and we tell javac about that directory with this new module source path option. And that's necessary because there's a new level in the directory hierarchy for the modules. So you can see source myapp and mylib are a new level in the traditional compile time hierarchy, so that we can put in source module name and then modulinfo.java, and then the package hierarchy at the same level as modulinfo.java. The result then is class files -d in the mods directory. We can run jar to build mylib.jar based on the classes in mods mylib. We can run jar to build myapp.jar from the classes in mods myapp. And because it's going to be the main class, we specify that on the command line here. And then because these jar files have modulinfo.class files in them, compiled from the two modulinfo.java files, we call them modular jars. Modular jars is a term you will hear a lot in the succeeding talks in this sequence. So you can then run the modularized application with this simple command line. All the stuff passed to -cp in the past is now wrapped up in the modulinfo.class files. The explicit modules are in mlib. I think I moved them there from mods. And the automatic Jackson modules are in lib, where they always were. And so that's it. So we modularized an application with two techniques. First, we built modular jar files for our own application code by writing and compiling modulinfo.java files. And we also created automatic modules for third-party code, for library code, simply by putting their jar files on the module path, passing that lib directory to module path rather than to class path. So if you like, you can think of this as top-down migration. I wrote the module declarations for the application and then kind of worried about what was underneath it later. So if I say top-down, you should think, what does bottom-up migration look like? And for that, I will hand over to Alan.
Library migration. So this is the second part. So we will roll back to where we were at the beginning of the presentation, where we had the modular platform at the bottom, our sandwich of jar files in the middle, and our application and whatever libraries it comes with at the top. So what we're going to do is we're going to start at the bottom now and try and move the Jackson jar files that we have. We want to move and migrate those to modules so that we end up with this picture. Green is module. Orange is the class path. Exactly as Alex did in the first part of the presentation, when you're migrating and you see a module, you have to ask us the questions. What do they require? What do they export? So for each of our 3 Jackson jar files, if we're going to think of them as modules, we need to think about what do they require and what do they export. We'll start by running what we call the JDEPS tool. So if you're at the earlier talks, you will see that we use the JDEPS tool to actually do some static analysis on existing libraries. Alex used it in his part of the presentation to look at myapp and mylib. We'll do the same thing with the Jackson jar files here to understand what they require. So we see that the Jackson annotations jar file has code in there that makes use of types that are in Java base. That makes sense. Jackson Core also has some code in there that makes use of some types in Java base. Jackson Data Bind is much more interesting. There is code in that jar file that has references to types that are in Jackson annotations. There's also references to types that are in Jackson Core. There's also a couple of other references to types that are in Java base, of course, Java SQL, and Java XML. I should say is that when you're trying to understand what a module depends on, you don't need to, of course, use the JDEPS tool. There's other ways. If it's a Maven project, then you've already got a POM, and that will give you some idea what it depends on. So this is the dependency graph from the JDEPS output, and just keep this in mind because we will be coming back to it in the later slides. I'm now going to run JDEPS again, this time with a new option, gen module info, which is a way basically to get your starting point or your starting module info.java. Now, in the earlier talks, we had JDEPS being usable on JDK8 to be able to look at your jar files in your applications that you're using with JDK8 and older. The version of JDEPS that's in JDK9 has a bunch of additional options that aren't available in the 8 version, and this is one of the command line options that is new in the JDK9 version. When you run JDEPS on a bunch of jar files with the gen module info, it will generate you a starting Java info, module info. So I've run it on these 3 jar files, and it has created me 3 module infos, one for each of the jar files, and we'll look at that in the next slide. So for Jackson Data Bind, which is probably the most interesting one in this set of jar files, this is the module info that the JDEPS tool created for me. There's a bunch of requires at the top that is based on the static analysis of what's in the jar file. And JDEPS has no idea which parts of the jar file are in the exported API and which are internal. So it assumes that every type is part of the API, therefore every package is exported. So it generates a little exports directive for every one of the packages in the jar file. If you look closely at the requires, it also looks at the signature of the methods that are, and that's able to determine whether to generate a requires or a requires transitive. So in the previous talk we talked about requires transitive, and so here you're seeing an example of it in a generated module info. For this part of the talk, assume that we are the maintainers of this library. So we have much more knowledge about this library than JDEPS does. So, and as maintainers of this library, one of the things we will want to do is, or not want to do is, we don't want to be exporting our impl packages. That's where our internal implementation is. It's not part of the API for this library, we'll assume. So what I might do is I might edit this generated module info and delete the exports that don't make sense. So JDEPS generates me a module info where everything is declared as being exported, but assume as maintainers that we know better and these impl packages don't make sense. So we will delete these as part of creating the right module descriptor, right module declaration for this Jackson Data Bind module. Now we'll do similar to what Alex did, and we'll start to compile these. So what I've done is I've generated these module info into the source tree for these 3 modules that I'm going to compile. Remember, with our modules, we have an additional directory now in the file path that is the module name. So all my source code for these 3 modules is organized src/module name, and then my traditional hierarchy of classes organized by package in that tree. My module info is in the top level directory of each one of the modules. So for Jackson Core, the location of the module info is src/module name Jackson Core/module info.java. Same for the other 2 modules. I'm now going to compile all of these 3 modules together. So I'm recompiling all of Jackson in this case, all 3 of them. And I'm doing a multi-module compilation. So with one javac command, I'm compiling all 3 modules together. I'm giving it an output directory of mods. That's where all the class files are going to be generated. And the input to it, I'm just giving it a find command where it'll find all of the Java source. So that will compile. I've now got a mods directory with 3 directories in it and all of the class files. I'm going to run the jar command 3 times, and because I'm going to create a jar file for each one of my modules. These are modular jars. The options you're seeing on here is new options on JDK 9. So the jar tool has historically had very obscure and very uniquely Java options, a bit like the zip tool, some of them. They've been modernized in JDK 9, particularly to use the GNU style format, or at least close to it, as you saw that, and maybe in the introduction talk earlier on with some of the other tools. So the jar tool has -- options, so -- create and -- file. So I'm creating a jar file. I'm telling it what jar file to create. This is a modular jar. I'm going to create it in the mlib directory. I'm naming it Jackson Core and a version number. And I'm telling it the location of the class files I'm going to package in, and I'm creating 3 modular jars. So that's really, really nice. Exactly as Alex did with myapp and mylib in the first part of the presentation. Now this is what we've got now. So we've recompiled Jackson Core, Jackson Annotations, and Jackson Data Bind. We've packaged them up as modular jars. This is the module graph that we have. So the platform modules at the bottom, and then our 3 Jackson modules as explicit modules. Their dependencies are clear, their exports are clear. This is a nice module graph. Just to recap how we ran these on the class path right at the beginning of the presentation. We're now going to change this command so that we're running with these 3 libraries as modules. So that's the old command. Now we've got the new command. So for those that attended the intro talk earlier on, I talked about how to mix the module path and the class path together. This is exactly a scenario where you have to do this, because myapp and mylib are on the class path. Our 3 Jackson libraries are now modules on the module path. So there's both a module path and a class path specified to the Java command here. My 3 Jackson modules are in the mlib directory, and I'm specifying the mlib directory to the module path option. My class path has myapp and mylib, so I'm specifying those with the -cp or -class path. But exactly like the intro talk earlier on, there is nothing to say in myapp or mylib to say that they depend on Jackson Data Bind. There's no dependency information available on the class path. So I'm having to help the runtime with the add modules option to tell it to resolve the Jackson Data Bind module. This is one of the complications when you're trying to mix the class path and the module path together. There's nothing on the class path to tell you what the dependencies are. So I'm helping the runtime with the add modules option to tell it I need to resolve the Jackson Data Bind. So that is a command line that I've ended up with modules on the module path and my application on the class path. Questions at the end? Right, so now we're going to put it all together. So I've got modules on the bottom. I'm going to take the modules that Alex generated in the first part of the talk, and I'm going to combine everything together. This is what we have for the second half. Now we've got Alex's modules with myapp and mylib, and we have this nice module graph. Everything is green, everything is modules. It's very, very clear what the dependencies are in this graph. So now let's go and run this, now that we have everything as modules. Just to recap, everything is modules. So if I look in my mlib directory, I have 5 modular jars: myapp, mylib, and my 3 Jackson modules. My command to run this has shrunk because I'm just telling it the module path and the initial module. The initial module, our main module, is myapp. So I'm going to ask it to run myapp. That will resolve what does myapp depend on. Myapp depends on mylib, depends on Jackson databind. We will generate the transitive closure. All of these modules will get loaded in order to run myapp. We can go further. So if we combine, in the intro talk, we had some simple options or some simple examples using JLink to create runtime images. Now we have our application and the Jackson libraries as modules. We can actually do the same kind of thing. This is the advanced talk, so I have a couple of advanced options on the JLink option. So what I'm producing here is a runtime image that will have myapp and all of its transitive dependencies in a runtime image. So this is something that can be distributed with just the modules that it needs. So the options I'm giving to JLink, just like JavaC, just like the Java launcher, I'm giving it the module path as to where to find the modules. I'm using the add modules option, telling JLink what modules I'd like in the runtime image. JLink will generate the transitive closure and link all of those modules to create the runtime image. I want a relatively small image, so I'm giving it some options to do compression, to do some stripping. There's, like any linker, there's much more complicated options I could give it to do other customizations of the runtime image, but I'm just sticking with the size for now. And what I ended up with is a runtime image that is, in this case, it's 26,000, yeah, so just about 25.5 megabytes. If I look in the bin directory, I see in there only a small set of tools. The Java launcher, I see something for myapp that has been generated by the linker. If I run the list modules option on this generated runtime, then we see that it has, this is the list of the modules that are in that runtime image, myapp and mylib, the Jackson libraries, and then in this case there's 4 platform modules that have been linked in. So this is quite nice. I've ended up with a small runtime that for my application. And I can just run it with this. There's no module path specified because they're all linked into the runtime image. I can just do java-m myapp and my application will run. In addition, the linker will generate a little launcher script for my application as well based on the module name, so I can make the command line even shorter if I wish. And that is a quick run through of things from the bottom up and then combining the modules that were generated from top down so that everything is modules, and then we go further and actually create a custom runtime image. So the main thing we've got through in this presentation is, I hope that we've actually demonstrated, is that you have the freedom to adopt and migrate to modules at your own pace. Alex has shown how to migrate and modularize applications before the libraries have been migrated. It's possible, as we saw in the second half of the presentation, to modularize libraries completely independently. In addition, you've got a flavor for the different kinds of modules. So Alex started off with explicit modules for myapp and mylib, and then made use of the Jackson libraries as automatic modules. So that gives you a flavor of explicit versus automatic modules. And also showed you one of the current proposals on the table, which is weak modules, and how that they can be actually used as well for, especially for applications that don't export any APIs. So hopefully that has given you a flavor of what's there to support migration to modules. So we'll just finish up with a nice catch line and go forth and modularize. So we have a couple of other sessions. We're mostly in this room. So this is our third one today. We're starting to the repeats of this tomorrow at 2:30. But the important talks that haven't been done yet are the modules and services at 11 tomorrow. And then Alex is going to do Project Jigsaw Under the Hood at 4 p.m. tomorrow. There's also a hack session, which is You can think of bring along questions, bring along your laptop if you want to try things out. That's on Wednesday at 8:30. One of the rooms here, I'm not exactly sure which, and that's a 2-hour. And more information. So this is the link to the Project Jigsaw page where we're working on the implementation of Project Jigsaw. There's also a link to the mailing list and where the early access builds. Let's see. So as I said in the other talks earlier on, is JDK 9 is still in development. It doesn't ship, and it's not scheduled to ship until next year. So many of the things that we're actually showing here are things that are just not final yet. Nothing is final yet. There's still JSRs, there's still discussion, there's still early access. Everything is still in progress. So what we've shown here, maybe the final JDK 9 isn't exactly like that. So I think we've got about 10 minutes for questions. Actually, we've got 15 minutes if people have questions. So protocol for questions will be, if you can make it as far as the front, then call into the microphone so that people can hear us. Otherwise, we'll have to repeat the questions. So Mark is available for questions as well.
Please come up and use the mic. We're not going to repeat your question. We can't hear it.
We can't actually hear. Yeah.
In the first one, with the automatic module, Jackson automatically depended on the My App, which allowed it to do the reflection. In the second one, how does Jackson reference the My App?
You should stand up there.
Oh, yes.
Especially considering Jackson probably isn't something we are able to modify.
This is a good question. So the question is, I was wondering if someone would spot this. In the first part, when Jackson data bind is an automatic module, it's requiring implicitly actually my app and my lib, because it requires everything. But then when Alan modularized it, all the way, putting it all together, the arrows are all down. Yes. So the thing is, so data bind is using core reflection to access the classes, the exported classes from my app. My app passes a class object to data bind. That was in the that's in the data bind API, and that means the code in data bind can access all, as long as that class is exported from my app, data bind can reflect over it. It doesn't need it actually gets an arrow for free going back up to my app. Even when data bind is an explicit module with a module declaration. But clearly it doesn't know what modules what classes in what modules it will be reflecting over, so it can't possibly say requires them. When it reflects over them, as long as the class is exported to it, the reflection just works.
Okay.
Which, if you're paying very close attention, is a change from last year. But pretend I didn't say that. It just works.
Yeah. Cool.
Yes.
All right, thank you.
It's a good question.
Once I modularize and link and create the image, and if I decide to upgrade one of the jars, do I need to start from scratch for that jar or for that module to rebuild the image? Or how do I manage the version upgrades of individual jars?
Right, so I think what you're asking is, do you need to rerun the JLink command?
Oh, I need to rerun.
Yeah, exactly. And JLink will actually record all the options that are actually used to make it easy to rerun it if you have new versions of the modules.
I was wondering if you could quickly go over again what required transitive exposes about.
Which we didn't say, but okay. So the question is about what's different about requires transitive versus requires Java logging. The full answer is in Jigsaw under the hood, but it's not a complicated feature. It's not an advanced feature, so fair question. So you'll see Jackson data bind requires Java logging. Logging is an implementation detail of data bind. It's just calling logging's methods. It's not exposing it in any way. But data bind requires transitive Java XML. Now, I haven't looked at the data bind Javadoc in detail, but what the requires transitive Java XML tells me is that The way that data bind depends on Java XML isn't for just an implementation purpose. It's because the API of Jackson data bind, somewhere in all these exports, has in a public signature a type from Java XML.
Yeah, so if I write a module that requires Jackson data bind, what do I get from Java XML?
Right, so if you write a module that requires Jackson data bind, the fact that data bind says I depend transitively on XML means your module, you could say requires Java XML, there's nothing wrong with that. If you don't, it will be as if you had said requires Java XML. What do you get from Java XML? Whatever it exports, everything.
All right, so that's what I was wondering.
Yes, it's how you get modular granularity dependencies while still allowing refactoring.
By the way, there's a couple of slides on this in the intro talk from earlier. You may have missed that, but you may want to catch up as well.
Two questions. One is, say you've got 3 third-party libraries, and they were all built with slightly different versions of Jackson. So different parts of your application, maybe even using different versions of Jackson. But they're compatible, they're just slightly different bug fixes, for example.
Pick one.
Yes. Okay, so you pick one. Does that mean everything else will still pick up the version you've decided to pick?
Let me ask another question. Your application, it's not your code necessarily, but transitively uses different versions of Jackson.
Yeah.
How do you put those jars on the class path in JDK8?
Well, at the moment you specify them explicitly.
But if you specify version 1 of some third-party jar and later on the class path version 2 of...
Well, no, you pick one explicitly.
Then we're done, right?
But it's still in the class path. You're saying now that you don't use the class path.
If you do, so you don't in whatever you used to put on the class path, you would now the exact same jar that you picked to put on the class path, just put it on the module path.
All right. Okay. So
and then it magically, really it's magic, just becomes an automatic module with the name, and we drop the version qualifier according to some heuristic that's in the Javadoc. So these are the real module names that you get from the real jars.
Yes. And I guess, will there be something like a Maven build plugin for it?
The Maven
Mr. Maven
Chief
is behind you.
Is behind you and has an entire talk about that.
Okay, fantastic. Thank you.
Hi. Once you've upgraded an existing library to be a module on the new system, is it still possible to compile it using the class path rather than the new module?
So if you, let's bring the application, let's bring it up. Let's bring the Java C invocation. Right, so here we are recompiling the library for JDK9. Right, so this is the source, this is the library source. I'm going to compile it, put it into the mods directory. The class files that come out of this will be version 53 class files, Java SE9 class files. Clearly they won't run earlier than JDK9. What you can do, did you show this in intro? We were going to
Not an intro, I was going to actually show it on Wednesday. Right, so there's,
what you can do is compile the source once with -release 7, for example, and then compile again just the module info.java file, or files in this case. Don't specify -release, the default will be 9. So that will give you class files where module info.class is version 53, which it has to be. The rest of the classes from these 3 source trees will be 51. Run them through jar.
Okay.
The resulting jar files will run on 7 and 8.
Yeah, let me clarify my question. Say you're compiling for Java 9.
Mm-hmm.
The reason I ask this is there's a lot of existing build tools that use class path that will not understand what modules are. So if you just drop in...
Yeah, if you're running on JDK9, the class path will still take modular jars, just nothing will read the module info.class files.
Right, so it'll just act like an automatic module.
Right, with all of the the n factorial dependencies.
Right.
Yeah.
Just to clarify what Alex said is you can take a modular jar and you can put it on the class path, and it'll just work as a library on the class path as it would have always done.
Yeah. Thanks.
But I would, in the nicest possible way, question why you want to do that. If you're running on JDK 9 and you've made a module, you've written modular.info.java or you found one, why you would then want to put it on the class path on a JDK 8 installation, clearly. But on a JDK 9 installation, I'm trying to work out what you're trying to do.
I wouldn't personally, but there's a lot of automated build tools out there that generate class paths. And so if you upgrade one of those to a new module, you still want it to work with that build tool.
Yes. In time, though, I think you would expect the tools will eventually add support for modules.
Yes, absolutely.
Yeah. Yes.
So I have two questions. One is I'll start with a follow-up to his, which is it appears that if you put a module on a regular class path in JDK 9, you're actually breaking the protections, the access protections.
Yes.
So the access protections are actually not as tight as they may appear otherwise.
On the class path, there is no such thing as a modular jar on the class path. They're just jars.
Right.
And because they're not modular jars, we're ignoring modular.info.class, we're ignoring the exports.
So there's no way for a publisher to kind of bake in the protection into. It's only protecting the runtime as you configure it, but the publisher cannot actually protect.
That's correct. No,
that's true. And if you're in control of the on-disk layout, the on-disk placement of jar files, you are in control of everything. Even if the modular jar files are put on the module path, if you're controlling the command, if you're controlling the environment, you can just say ---- add exports and decide that you wish to, as the system configurator, overrule the exports in the modular jars.
Okay.
You can do that.
Okay. And the other question is, in your first example, where we're using legacy jars, if I wanted to protect my app from not being a weak module, then I could actually have a qualified export to Jackson.
Yes.
And that'll work.
Yeah. So if you don't say weak, the default is that the module is strong. You then have to enumerate your exports. You can choose to have them being exported qualified to not just to Jackson, but to Jackson Databind in particular.
Yeah.
Yeah.
Yeah. And the rules for reflection and regular access are basically the same.
Exactly.
Okay.
They are dominated by the exports that aren't on this slide because they're implicit, but yeah.
Okay, thanks.
I have a question so in future, are you expecting those providers to expose module or jar?
We are hoping that framework developers, like the Jackson developers, will write module.info.java files for their code and produce modular jar files. They're still jar files, but they have this module.info.class file in them, so that on JDK 9, the runtime knows to do the strong encapsulation.
Okay, but I noticed you have a feature here. So for a jar, the public doesn't mean they will expose that interface, right?
So
even that class is public.
That's right. So if you look at the crossed out lines, so confaster XML, Jackson Databind, DSer, impl, that package I'm pretty sure has public types in it.
Yeah.
Those public types will only be accessible within the Databind module.
Okay. Yeah, my concern is they expose their module, so they define which should be exposed. But when another provider, they might use this jar, but they define their own module. Then they expose this one. When you use it, even they are in the same version, but you don't know exactly what was exposed.
I'm confused, sorry. It's amazing. In some ways, it's always so simple when you look at the artifacts, but he did this and she did that.
Yeah,
So
just like version confliction.
well, but don't bring versions into this. You're saying that, so here's DataBind that has chosen to export a particular API, right? The author of DataBind is saying export the first 4 packages, and then there's another one, etc., etc. You said another module, someone else wants to do what?
For example, Jackson DataBind, they use the Jackson annotation.
Mm-hmm.
When they define the Jackson annotation module infer file, they say they expose this class, right?
Okay.
So this was used by DataBind. But another class, maybe my application, I also use the Jackson annotation.
Mm-hmm.
But I decided to use another, the same version of annotation, but I decided to, I don't expose this class. Then another one, they use my application.
Mm-hmm.
They also use Jackson DataBind. When they look at the module information, they will see the same information because they use the same version. Then they randomly pick one, then they don't expect what's the real result.
I understand you're saying that the Jackson annotations module, one version exports a package, and another version of Jackson annotation doesn't export the same package.
Okay.
That's your scenario.
Yeah.
I think that's a little unusual that you could imagine it happening, but let's assume it happens. Jackson, whoever is picking the version of Jackson DataBind to go on the system, because my app requires it, also has to pick the version of Jackson annotations that very first requires clause will resolve against. There's only one version of anything on the system.
Yeah.
If there are 2 versions of Jackson annotations, pick one.
Yeah, because I think it's a good feature to have those decide to expose which class or which package. But but I still think I have some concern on those conflicts.
You can't do it on the class path today.
Okay.
You can't do versions on the class path. If the next 5 questions are about versions, it's still going to be pick one.
Okay.
Sorry.
Thank you.
Thank you. Okay.
So you've shown how to do top-down when you're the application owner. You've shown how to do bottom-up when you're a library developer that has just Java modules dependency.
Mm-hmm.
What's the story if you're in the middle? So you have a library, you'd like to move it to be a module, but sadly, some of your dependencies are not yet modules. Should you do it, or should you wait until the graph underneath you is clean?
You should do it.
Yes.
Okay.
You should do it, and you should document. And when you do it, here, let me bring up DataBind. So if DataBind required Guava, for example, and Guava is not yet an explicit module, you are presumably testing your library against some version of Guava. You can write requires Guava in here. I'll assume it's not exposing Guava types and signatures. And you need to put in your documentation that please put Guava, download some version of Guava, and put it on the module path. Because you are being a good citizen, but this is the issue of issues. If you wait to modularize, then some other library, it's a complete tragedy of the commons.
Right.
And
the
so
important thing is that libraries can actually migrate independently. That's really what the first part of the presentation.
I guess there is just a small tie-up in the way you end up. The modules end up being named, so you need to pay attention.
I was going to say, the next question that people then ask is, okay, I'm DataBind, I'm a good modular citizen who hopes to be linked into an image one day, that would be nice. But I require Guava, and Guava is working as an automatic module on my system and therefore everyone's. What about when the vendor of that module, of that jar, makes it into a modular jar? When they declare a module, and they decide to call it something else. That would be impolite of them.
Okay, so in a way, the name that your jar has today, and the way you have automatic naming should be respected and be part of the public API.
We should.
Okay.
You should be giving this presentation.
This is a great trick, but we think it will be a powerful.
Exactly. Was there another question? Oh, here you are. You're here. Okay.
But sort of similar question.
Uh-huh.
So the second question I had was is much simpler. So I missed the intro talk.
Uh-huh.
So what I understand from here is if you're just a regular application developer,
Uh-huh.
it just depends on libraries like Jackson and stuff. So then probably you should just do the top down, which seems much less work, and it's just if your app is there, you just have to declare it as a week. So that's the con side. But then if you just do top down and get up and ready, at least for your your app to be modularized, and that should be good enough to go.
It is very common to be able to download a jar from the internet, such as Jackson. They might be JDK 5 or 6 era class files in those jars. Put the jar on the module path. It will very often work as an automatic module, which gives itself a name, it springs into existence so that your module info.java in your application can require it. That works surprisingly often. And if it doesn't work, don't call us. Call the author of, and I can tell you some of the reasons that they are either accessing JDK internals, which is nothing to do with the module. So it's not really the module system. It's not automatic modules that are the problem. They're accessing some internal thing, and their jar won't work on the class path either. If they're not accessing JDK internals, you occasionally find traditional jar files that contain classes in the JavaX annotation namespace, in the JavaX XML registry namespace, and so on and so on. They should not be including those classes, but they do, and the module system at startup detects that there is some package that has classes in the JDK image, classes in this automatic module. That's a bad thing. Something funny is going on, so the system will stop.
I see. Okay.
And if that happens, don't call us. Call the creator of that traditional jar to say, why have you got Java SE types in your random jar file?
I see.
That's never been a supported thing.
Right. So there is still that class naming conflict on that.
There can be.
Yeah.
It's actually relatively rare, but when it happens, you are in trouble. Someone else has got you in trouble.
Yeah, makes sense. Cool. Thank you.
Thank you. One more question.
Yep, I think so. We'll have to wrap up in a minute.
Last question.
My main question is, outside of like smoothing over some of the class path issues that you can have while you're doing Java development, is there any other benefits that these modules will give you?
Are you developing, is your jar an application jar that no one calls, or is your code a library that lots of other people call?
I have both.
Okay.
So.
How many jars are there in your application?
I'm
Some.
looking at, there's probably maybe 30 to 50.
Just in your application?
Yeah.
How do you track the dependencies of code between classes in those jars?
It gets messy.
Is it a big ball of mud?
Yeah.
That's what the JDK used to look like.
Okay.
The ability not only to express, the ability in a module to say not only what it depends on, but also what its API is. Now, there are some jars at the very top of the graph that don't have an API. They've got the main class. But for everyone else, there's an API that it is worth declaring explicitly. You can declare, these exports are to everyone. If you have a nest of jar files, you can export to your friends. And what that means is you will never again, it's an investment you make once. And once you made it, you will never backslide into, why is he, are you the business partner? Why is he calling this type in my package? It was meant to be internal.
Yeah, but shouldn't you have just marked it protected at that point? Or
Protected is a whole mess of access control complexity. In order to share anything between, sometimes you want to share between packages with public.
Yeah.
You want to share with him. Other times you have types in you have a package that you don't want to go outside a jar. I'm pretty sure you have at some point said, this package is just for other packages in the same jar file.
Right.
That's it. That's what the module system gives you.
Okay. All right. Thank you.
And by the way, on the ball of mud, we had the slide showing that in the intro talk earlier.
Well, the ball of mud is kind of, that's a ball of mud. It's very clean, but
Yes.
it's...
Very symmetrical. Okay, I think we're done. We're wrapping up. Thank you.